JEE Mains 2026 in the January sessions. All the papers we are discussing, and we made a wonderful arrangement that all the questions are arranged chapter wise or unit wise. Electric field will be modified, you might have studied, due to the polarization process. Dipoles will be developed and aligned, and there will be an alignment of the dipoles formed due to the polarization, but not due to the movement of free charges. Total potential energy of the system. First term will be, this is 10 to the power of 7, 10 to the power of minus 6, that is 10, that is 70. Second term minus 2 is minus charge, this is coming to be minus 20. Third term is coming to be minus 0.7, this is coming to be 0.7. So this is 70, 49.3. So answer is. Very good morning, all of you. We have come with a program to discuss all the questions asked for JEE Mains 2026 in the January sessions. All the papers we are discussing, and we made a wonderful arrangement that all the questions are arranged chapter wise or unit wise. So we will be discussing all the questions asked for the JEE Mains examination in that unit or in that chapter. Like that, we'll be discussing all the units and all the chapters, and as a result, we will be discussing all the questions. Okay? So it will be beneficial for you, not only for those students who are going to appear for the April session of JEE Mains, and other students also, those who are going to appear in the year 2027. Okay, come on. So we'll start with, first question is, we have to identify correct statements, not one statement. There are 2, 3 more statements may be there. So we have to go through each statement, and we have to do all the statements correctly mentioned. Effective capacitance of series combination is always smaller than. We know that 1 by C effective is 1 by C1 plus 1 by C2 plus 1 by C3. Or we can find that effective capacitance in series combination is even smaller than smallest. Even smaller than the smallest. So the statement is very correct. Statement B, when dielectric medium is placed between the charge plates, there will be no free charges moving through the dielectric medium, but electric field will be modified, you might have studied, due to the polarization process. Dipoles will be developed and aligned, and there will be an alignment of the dipoles formed due to the polarization, but not due to the movement of free charges. So it is mentioned that dielectric medium is placed between the charge plates. Displacement charges cannot occur due to the, there will be some arrangement of charges within that. As a result, there will be modification of the electric field, and there will be, so that statement is a wrong statement. B is a wrong statement. What about C? Increasing the area, capacitance is given, everybody knows it, epsilon 0 A by D. Capacitance will be increased when area increases, plate separation decreasing, thickness decreasing. So that's a correct statement. For a point charge, concentric spherical shells centered at the, for a point charge, equipotential surfaces are concentric spheres are equipotential surfaces. So that is also correct statement. Statement A correct, statement C correct, statement D correct, B is not correct. So this is your correct option. We can go to the next question. Again, identify the correct statements or statements. Okay. Now come on. Effective capacitance of a series combination of capacitance. Effective capacitance of series combination of capacitance is always small. Oh, no, this is same question. Oh. Yes, this is second question. Identify the correct electrostatic field lines from closed loops. We know that only magnetic field lines are forming closed loops. Electrostatic field lines will never form it. Electrostatic, I'm not generalizing electric. Electrostatic field lines will never, they start from positive charge, end up in negative charge. So your option A is wrong. Option A is wrong. Now, electric field lines point radially outward. When if positive charge, electric field lines are radially away. So that statement is correct. Then C, Gauss law is in your NCERT book. They have given 1, 2, 3 numbering. What are the cases in which you can apply the Gauss's theorem? Gauss's theorem will be applicable in the case where inverse square law is valid. So it is mentioned that Gauss law is valid only if that is a correct statement. Work done in moving a charged particle in a static electric field around a closed path. Electrostatic field is a conservative field. In a conservative field, work done over a closed path is 0. So this is a very true statement. Now, the motion of particle under Coulomb's force must take place in a plane, and that reference goes to the central forces. Central forces, the line of action of force is acting along the line joining them. And you must have studied this idea of studying in NCERT book, gravitation chapter. They given numbered conditions for 1, 2, 3 for a central force. Electrostatic force is central force. Line of action of the forces is forces acting along the line of forces, and force, there is no torque acting because angular momentum is to be conserved. Angular momentum is conserved. Therefore, the torque will be 0. Torque will be 0. Therefore, force should be confined to the plane in which the charges are lying. Force is confined in the plane. So that statement take place in the plane. That statement is also correct. So one is A is wrong, B is correct, C is correct, D is correct. So the correct option is B, C, D, E. And question number 3. Yes. 2 point charges, 1 nanocoulomb, 2 nanocoulomb are placed at the 2 corners of an equilateral triangle. And what is the work done in bringing the charge 3 nanocoulomb from infinity to that corner? Work done in bringing a charge from infinity to a point is, by definition, it is potential energy. So we have to find potential energy of 3 nanocoulomb charge. 3 nanocoulomb charge. When it comes to third vertex. When it comes to the third vertex. Okay. So I'll draw an equilateral triangle for convenience. We have 2 charges. One is Okay, we have two charges. Two nanocoulomb, then 1 nanocoulomb, sorry. 1 nanocoulomb, 2 nanocoulomb. This is third vertex. Okay, so I have to calculate the potential energy. Who comes? The 3 nanocoulomb charge comes to the potential produced by 1 and 2. So I can write it like this. This is potential energy is equal to potentials of charges 1 and 2 nanocoulomb into the third charge. What is the third charge? I call Q3. Q3 comes to the point of potential produced by 1 and 2. So since it is taken from infinity, that will give you potential energy of the third charge. What is the potential produced by, and this is an equilateral triangle of side, how much? 3 centimeter, that is 3 centimeter. So I can say potential of 1 and 2 is 1 by 4 pi epsilon 0. Q1 by distance is 3 centimeter. 3 into 10 to the power of minus 2 plus Q2 by 3 because it is an equilateral triangle. Okay, that will be 9 into 10 to the power of 9 into Q1 is 1. So common thing, who can take it out? 3 into 10 to the power of minus 2 is taken it out. We have to take Q1 plus Q2. Q1 plus Q2. Q1 plus Q2 is how much? 1 plus 2. 3 into 10 to the power of minus 9. So that comes to be uh, 3 into 3 get cancelled. We are getting 10 to the power of 9 get cancelled. We are getting 900. This is 3 nanocoulomb, correct? Q1 plus Q2. Yes, that is 3 into 10 to the power of minus 9. This is coming to be 900 volt. Now, potential energy of 3 nanocoulomb, potential of 1 and 2 into 3 nanocoulomb, 3 into 10 to the power of minus. This is 900 into what will be the charge you are coming? 3 into 10 to the power of minus 9. That comes to be 27 into 10 to the power of minus 7 or 2.7 microjoules. What about the answer? Answer is it there? Okay, 2 into 10 to the power of minus 7 microjoules. 2.7 into 10 to the power of minus 6 microjoules, or 27 into 10 to the power of minus 7 joules. Okay, so answer is coming to be fourth option, fourth answer. We go to the next question. Again, a point charge 1 microcoulomb is placed at a distance 2 centimeter from a uniformly charged rod of length 10 centimeter and charge density charge 24 microcoulomb. So we have to calculate force between them. Force between them is force on Q by the rod or force on the rod by the Q. Both are correct. So I'm considering a small element. I'm considering a small element. Better I change the color. So yeah, small element we are considering of length dx at a distance x from the charge. Okay. Now, first you calculate charge, linear charge density of the rod. Linear charge density. Linear charge density. That is coming to be 24 divided by 0.1 because it is 10 centimeter. 240 micro or 240 into 10 to the power of minus 6 coulomb per meter. You got it. Then we have considered a small portion of length dx at a distance x. So charge on the small portion I can call lambda dx. Lambda's values we have. This is your lambda, linear charge density. Let it be lambda dx. Now, then small amount of force acting on this charge element will be 1 by 4 pi epsilon 0. This lambda dx into cube divided by distance between them is x square. So this is coming to be, df is coming to be 1 by 4 pi epsilon 0 is 9 into 10 to the power of 9. Lambda will be 240 into 10 to the power of minus 6 into 2 is 1 microcoulomb, that is 10 to the power of minus 6 into dx divided by x square. Okay. Now, for getting total force, what you have to do? Integral x is equal to, this is x1, this is x2. x1 is how much? 0.02. x2 is 0.12. We have to start finding the force on the small length dx. Start from right end at a distance 0.2 meter to the other end at a distance point, and we have to sum it up. That can be easily done by integration. So I'm going to write it as, I'm making some simplification. This is 9 into 24, 10 to the power of 9, 10 to the power of minus 12. So this is coming to be 24 into 9 into 10 to the power of minus 10, minus 2, sorry. 24 into 10 to the power of minus 2, because 10 to the power of 9 and 10 to the power of minus 12 into 10, it comes to be 10 to the power of minus 2 into x to the power of minus 2 into dx. Okay, and this is the total force. So we have to pull out 24 into 9, 10 to the power of minus 9. Result of integration will be x to the power of minus 1 divided by minus 1 into limits 0.02 to 0.12. So this is coming to be, this is x to the power of 1. Now, so now I'm leaving to you, substituting for that. This will be one more step I will write. 24 into 9 into 10 to the power of minus 2, isn't it? And this will be 1 minus sign will be there. So I'll write first this 1 by 0.02 minus 1 by 0.1. Then when you work it out, you will be getting the value as 90 Newton. That mathematical part I am leaving to you. I come to the last step. Now only simple completing the answer. Answer is coming to be 90 Newton. 90 Newton is the answer. This is a fill up the blank question. So it is coming to be 90 Newton. Okay. So it's a direct question. Now, this is an arrangement of capacitors A, B, C. And we have to compare in which case effective capacitance will be more. Now, before filling dielectrics, so options are given. Before filling dielectrics, so we can go for a mathematical solution to it. We can mathematically work it out. Before filling dielectric, before filling dielectric. It was an it is an air capacitor. That capacitance I 0 Z0. It is epsilon 0 A by D. Here the plate length is L by 2. That means you can take the area as A. Area as A. Area is not given. I take the area as A. Correct. This is not given to you, but we take it for granted. That is before filling dielectric. When it was an air capacitor, the capacitance is epsilon 0 A by D. I call it as C0. Now, case 1A, I have three portions, three capacitance. This is one, this is one. I call it as this portion 1, this is 2, this is 3. So, CA1, CA1, a case A for the first portion, I call CA1. CA1 is epsilon 0, area is still A, separation is D by 2 into K1. It is filled with the dielectric K1. You can see. So when I considering that, aspect, it is coming to be epsilon 0 A by D into 2K1. I call it as 2C0 K1. Now second portion, CA2. Now I am writing quickly. Epsilon 0, area has become half, separation has become half, and filled with the dielectric K1. So 2 get cancelled. This is coming to be C0. 2 get cancelled, C0 K1. Okay. Similarly, CA3, that coming to be, that is filled with the dielectric K2, C0 K2. Now, I'm writing here A2 and A3. A2 and A3 are connected parallelly. A2 and A3 are connected parallelly. So, effective capacitance, I write CA23. I'm using the notation CA23. They are connected parallelly. Effective capacitance is coming to be C0 into K1 plus K2. And this is this CA1 and CA23 are in series. So I call CA, first one, CA. So parallel series combination, one is what? 2C0 K1, other is C0 into K1 plus K2. So using the formula for series combination, it will be 2C0 K1 into K1 plus K2 divided by what? Divided by denominator C0, I have taken out. It will be 2K1 plus K1 plus K2. That's, they are connected in series. So in series combination, C1, C2 divided by C1 plus C2. And numerator C1, C2 will be 2C0 K1 into K1 plus K2 and divided by 2K1 plus K1 plus K2 because I have taken C0 common out. Now I'm making a simplification arrangement. CA is equal to, I pull out 2K1. So it will be left over in the numerator K1 plus K2. I have pulled out, divided each term by 2K1. Denominator you have 2K1 plus 3K1. That is 3K1 plus K2. I divided by 2K1. So this is coming to be 3 by 2 plus what is, I'm dividing by 2 K1. So this is coming to be 3 by 2 plus K2 by 2 K1. This is result number 1. Now it is easy for me. In the similar manner, I can calculate CB. No explanation needed. Only one change happened. K1 and K2s are interchanged. K1 and K2s are interchanged. So I need not give an explanation. I can directly let CB is equal to same C0 K1 K2 divided by 3 by 2 plus K1 by K1 by 2K2. Same explanation. Now I come to the CC. So in CC, I can say CC1, that is the upper part, upper part. In upper part, you have what? What? Epsilon 0, A by 2, D by 2, K1. These two portions in the upper part are connected parallelly. So first portion is what? Epsilon 0, this portion, epsilon 0, A by 2 divided by D by 2 into K1 plus second portion, epsilon 0, A by 2 divided by D by 2 into KT. That comes to be CC1 is equal to this upper part 1, CC1, 2 get cancelled, epsilon 0 A by 2, that is our C0, what will be there? K1 plus K2. Now, similarly, CC2, lower portion, these two will be same arrangement, no difference at all. That is C0 into K1 plus K2. Then CC is the effective, then CC1 and CC2 are in series. They are identical. Then effective capacitance can be given by C0 by 2 into K1 plus K2. Yes. I have 3 expressions I got. For the first arrangement, I called CA, C0 K1 K2 divided by 3. Then second arrangement, C0 K1 K2 divided by 3 plus 2. Then third arrangement, C0 by 2 K1 K2. Now tell me, C0 K1 by K2 is common, isn't it? Now look, I'm going to come mathematically as well as logically. This portion I am rubbing out. This portion I am rubbing out. We got it. We got the result. This I am rubbing out. Yes, this much I am rubbing out. You know, then the portion in the denominator, this is C0 K1 by 2. Everywhere C0 by, so whatever may be the value of K1 or K2, whatever may be the value of K1 or K2, K1 either greater than K2 or less than K2, doesn't matter. That C0 into K1 plus K2 is common for all. Now, who will be deciding? Denominator. That is denominator. What is the denominator here? Will decide. Denominator is what? 3 by 2, either K2 by 2 K1 or K1 by 2 K2 will decide. Denominator in CA, you know, denominator in CA, here K1 greater than K2. So look at here, K1 greater than K2. So second term, then it means K2 by 2 K1. Look, K1 is greater than K2. K2 by K1 is less than, because K1 less than K2. So K2 by 2 K1, that is second term in denominator, this term in denominator is less than half. So its denominator will be, CA's denominator is what? Less than how much? 3 by 2 plus half, that is 2, less than 2. Therefore, denominator is less than 2, or CA, denominator is less than 2. CA is greater than CA by 2. Once again, all of you take. So I told you in all CA, CB, CC, everywhere this is common. C0 into K1 plus K2, here C0 into K1 plus K2, here C0 into K1 plus K2. Now, who will be deciding the denominator factor? Here denominator factor is C0, C3 by 2 into K2 by 2 K1. Here K1 is greater than K2, K2 by 2 K1 is less than half. Therefore, denominator is, that is, denominator is what? 3 by 2 plus K2 by 2 K1. This is less than half. Therefore, CA is more than C0 by 2. Correct? Now, CB, same explanation, just reverse. When K1 is greater than K2, this factor will be what? More than half. Denominator is more than 2. CB will be less than C0 by 2. Then what about CC? So CC's value, that is C0 by 2. That, barring the term what? Barring the term K1 plus K2. K1 plus K2 is common. Therefore, tell me, so in CA, that is C0 by 2 is great. CA is greater than C0 by 2. Here CB is less than C0 by 2. There is one more bracket, that is K1 plus K2. I didn't count that because that is common in every term. Now remaining is, in CA it is more than C0 by 2. CB is less than C0 by 2. In CC, whatever it may be, it is C0 by 2 itself. Now you can make a comparison. First diagram, it is more than C0 by 2 into K1 plus K2. Then in second diagram, it is less than C0 by 2 into K1 plus K2. Third diagram, it is equal to C0 by 2 into K1 plus K2. In what situation? K1 greater than K2. So when you make comparison, who is maximum? CA. CA is maximum, then CC, then CB. So fourth option is the correct option. Like that, we have a mathematical solution to it, some calculation involved, isn't it? Some logic involved. Okay, we can exactly verify which is greater and which is not great. Okay, so this way we have to go through it clearly, isn't it? First I calculate CA, CB, CC. CA got 2C0, C0 into 2K1 I have taken to denominator. C0 into K1 plus K2 by 3 by 2 plus. Similarly, here it's no difficulty at all. Just interchanging C0 into K1 plus K2 by 3 by 2 plus K1. And third one, two portions. Upper portion's capacitance is C0 into K1 plus K2. Lower portion is similar. They are in series, C0 by 2. Now in all the terms, K1 by K2 is common. Then denominator will decide the value. Here I put a logical argument. K1 is greater than K2. Second term, K2 by 2 K1 is less than half, or the whole denominator is less than 2, whole denominator. Therefore, capacitance is more than C0 by 2. And second one less than C0 by 2. Third one, whatever it may be, it is not going to be changed. It remains at C0 by 2. Now you can make a comparison to it. Okay, so answer is 4. Come on. Yes, we come to three charges, 2q, 3q, minus 4q, situated at the positions given there. We have a ready-made formula to be used. Normally, if you can make number of dipoles, we extract individual dipoles, Dipole is a vector. So we find the magnitude of individual dipole and its direction. Then we add the total dipole moment vectorially. We add total dipole moment vectorially. That is a usual practice we are having in calculating the dipole moments. But we have an easy way of calculation of dipole moment that will be easy in any situation. The total dipole moment can be given by sigma I is equal to 1 to n qi into the position vector of each term, because it's a vector quantity. So this will be easiest one. But so far we were dealing in another method. We calculate the dipole moment of each dipole, we find its magnitude, we find its direction, then we add it vectorially. But in such cases, this will be an easy arrangement. So how many charges are here? We have 3 charges are here, isn't it? And 3 positions are here. So we can find it out. Total dipole moment vector with the direction taken into consideration. First one, what? 2q into its position vector is what? 0 minus 3a. 0 minus 3a. So its position vector will be what? Its position vector will be minus 3aj. That's of q1 r1 for the first term. Its position vector is from origin, that is minus 3aj. This is on y-axis. Plus second term's q2 is what? q2 is 3q. 3q into what is the position vector? That is 2a into I, because only x coordinate, isn't it? In third charge, how much third charge? Minus 4q into, we have point lies on the x-axis, it will be minus 2a into I. So we have calculated q1 r1 plus q2 r2 plus q3 r3. That is, here it is q1 r1 plus q2 r2 plus q3 r3 with the directions taken into consideration. Directions are introduced by ijk. Now tell me, what is the first term? We have minus 6 QAJ. This is plus 6 QAI. This is minus and minus plus 14 QA into G. QA into I. Usually we write what term? I term first. So 14 QAI. 14 QA, not 14, 8 QAI. 8 QAI. A little bit hurry. 8 minus minus will become plus. 8 and 6 will become 14. So this is 14 QAI minus 6 QAJ. What I can take out? 14 and 6. I can take out 2 QA. I can take it out. When I take 2 QA, what is left over? 7I is left over minus 3J. This is the net dipole moment vector. 2 QA into 7I minus 3J with the direction. Yes, option is very much over there. Fourth option is there. We'll be getting fourth option correct. Yes. Come on. So this method will be able to work out quickly. Any situation we can apply this. That is, total dipole moment with the direction taken into consideration is equal to sigma qi ri vector. Ri vector. We have to consider the position vectors with the direction taken into consideration. Now we go to the next question. Yes. Come on. 3 concentric spherical shells ABC of radii, A, B, C respectively, and they are charged with Q1, Q2. So let me draw the circles. Yes, three concentric circle with charge the center at O, and I'm marking the this is A, this is B, this is C. Okay, this is A, this is B, this is C. That's now they are concentric spheres. This is ABC, radius also ABC. Now charges are given. Inner one Q1. This is Q2. Now tell me, even though they are mentioned conducting, so this charges now ultimately net charge on the innermost circle of radius A is Q1. After induction and everything, second one Q2, third one Q3. We have to calculate the potentials of the sphere ABC. So I write potential of A. Who will produce potential at the inner sphere of radius A? One charge on its surface. So I can take 1 by 4 pi epsilon 0 common. What is the charge on its surface? Q1. Radius A. So potential is produced by Q1 by A. Inner circle is inside the second sphere. So second sphere will be producing a potential same everywhere. Whatever potential it is having on its surface, that will be everywhere inside. So that potential is also availed by innermost sphere of radius A. So I can write plus Q2 by B. With same explanation, potential on the outermost sphere of radius C is everywhere, anywhere, that can be availed by the innermost sphere. That will be Q3 by C. That is potential of A. Now we come to the potential B. Potential B, again, I take the common term 1 by 4 pi epsilon 0. Now, B, you know, on the surface B, where is the this charge Q1, as far as an outside point, charge Q1 can be supposed to be at the center O, and I am calculating potential at a distance B. So this will be Q1 by B. Similarly, there is a charge Q2 on the surface of the sphere of radius B. So it will be producing Q2 by B. Both are B. Yes. It is inside the outermost sphere. So whatever potential on the outermost sphere, that is available on the second sphere. So it will be Q3 by C. Now, third one, outermost sphere. So potential is produced by charge. As far as outside point considered, charges can be supposed to be concentrated at the center. I can say Q1 is at the center, Q2 is at the center, even Q3 can be supposed to be at center, and from Q1 to the surface, third surface is distance C, Q2 to the third surface is C, Q3 to the third surface is C. Therefore, total potential will be 1 by 4 pi epsilon 0 into Q1 plus Q2 plus Q3 by C. So, what will be VA? 1 by 4 pi epsilon 0 Q1 by A plus Q2 by B plus Q3 by C. Second surface, Q1 plus Q, both common denominator is B. So Q1 plus Q2 by B plus Q3 by C. And third one, 1 by 4 pi epsilon 0 Q1, Q1 plus Q2 plus Q3 by C. So what will be the correct option? Yes, we can get this one. The second one. 1 by 4 pi epsilon 0 Q1 plus Q2 by B plus Q. Then Q1 plus Q2 by C. Yeah, this is from here it starts. Some displacement has happened. This is the second option. This is second option. So 1 by 4 pi epsilon 0 Q1 by A Q2 by, that is the correct. Q1 plus Q2 by B, this is correct. 1 by 4 pi epsilon 0. So second option is correct. Second option is correct. Okay. So easy thing. We have to use the concept. As far as two concepts are used. Any point inside of a sphere potentially same everywhere as on the surface. Number two, any point on the surface as well as outside is considered, whole charge can be supposed to be concentrated at the center. So we'll be getting this result. We go to the next question. Now, yes, eighth question. Electrostatic potential in a charged spherical is given by V is equal to ARQ plus B, where A and B are constant, total charge in the sphere. So we are using two concepts. Concept number one, electric field along the direction of R, because potential is given as a function of R. So we're getting along the direction of R. E is equal to minus dV by dr in the direction of R. And when you differentiate it, we are getting ER is equal to how much? Minus 3A R squared. Direction is R cap. Isn't it? 3A R squared. Now, tell me, we have to calculate the flux. Flux is given by ER, E dot, correctly speaking, E dot area. Here, direction of field is what? Direction of field is along the radial direction. It is given that we got ER is along the radial direction. And direction of sphere is also radial. Direction of surface is also radial. Both ER and AR in same direction. Both E and A are along the direction R. So this will become E into A. E into A is given by E is how much? Minus 3A AR squared into 4 pi R squared. That is coming to be minus 12A R to the power of 4. And we have to calculate the value of alpha. We have to calculate the value of alpha, isn't it? Value of alpha is given to be alpha. We have to given that for a unit radius. Therefore, according to the Gauss's law, flux is equal to Q enclosed divided by epsilon 0. And what is Q enclosed? Q enclosed is flux is given by minus 12 pi A R to the power of 0 by Q enclosed divided by epsilon 0. And here R is given to be 1. R is given to be 1. Therefore, we'll be getting Q enclosed is equal to minus 12 pi A epsilon 0. R to the power of 1 is 1. Now, it is given that this is given to be alpha pi A epsilon 0. It is given that. From that, we are getting alpha is equal to minus 12. So simple. So, one important thing, electric field will be along the direction of R, we are given a unit vector. Now, according to the flux is given by E dot A. E and A are in same direction along A. E dot A will become E into A. E is minus 3AR squared. A is 4 pi R squared minus 12AR to the power of. Then now Gauss's theorem. Total flux is equal to Q enclosed by epsilon 0. We have to calculate for R is equal to 1. So R to the power of 4 will become 1. You are getting alpha is equal to minus 12. Okay, answer is 2. We go to the next question. Question number 9. Two short dipoles, dipole A and dipole B. You know, due to the dipole A, I'm in that same diagram I'm using, electric field is in what direction? Yes, it is on axial line in this direction. This is the direction of electric field due to A. Electric field due to A. Now, due to B, electric field is anti-parallel to the dipole moment vector. So, because it is on equatorial line, the point P is on the axial line of dipole A and point P is on the equatorial line. I drawn in the diagram the directions of field I have clearly drawn. Directions of field clearly drawn. EA and EB. This is EA. Now, what is EA? What is EA? The point is on the axial line at a distance 40 centimeter. Therefore, EA is given by, yes, 1 by 4 pi, directly write 1 by 4 pi epsilon 0. That I can take it as 9 into 10 to the power of 9 into 2 into, because on axial line, 2 into dipole moment. Dipole moment is 2 into 10 to the power of minus 6 into 1 centimeter. Isn't it? 1 centimeter means 10 to the power of minus 3 meter. Into 1 centimeter means 10 to the power of minus. That comes to be dipole moment is 2 into 10 to the power of minus 8 coulomb meter. So I can write it as 2 into 2. Because it is on axial line, that 2 comes, then 2 into 10 to the power of minus 8 divided by R cube. R is given to be how much? 40 centimeter, 0.4. So 0.4 cube. 0.4 cube will be 4 into 4 into 4 into 10 to the power of minus 3. So when I work it out, this will be coming to be how much? 1 4 get cancelled here. Then this 1 4 get cancelled. 9 by 16. This will go to the numerator. This is 10 to the power of 12, 10 to the power of minus 8. This will be 10 to the power of 4. Correct? This one. Similarly, EB on equatorial line. I'm directly writing 9 into 10 to the power of 9. And dipole moment is on what line? Equatorial line. Only P by R cube. P is how much? 4 into, because dipole charge is how much? 2 microcoulomb and other is 4 microcoulomb. Each is 4 microcoulomb. So it will be 4 into 10 to the power of minus 8 divided by distance square is again 4 into 4 into. So both are equal. So this is also coming to be 9 by 16 into 10 to the power of plus 4, not minus 4, plus 4. Now look, I have already first explained EA and EB are mutually perpendicular. Therefore, resultant field is root of EA square plus EB square. Two equal vectors, equal in magnitude, acting at 90 degree. Resultant is 9 by 16 root 2 into 10 to the power of 4. Is the answer is there? 9 by, yes, third answer is there. Third answer. So question number 9's answer is third answer. Okay. Now we come to the next question. So quickly. Yes. Two charges, 7 microcoulombs, 2 microcoulombs placed at distance respectively in an external electric field E is equal to A by R squared R, where A is 9 10 to the power of A, considering potential at infinity is 0, then electrostatic potential energy. Electrostatic potential energy is equal to potential of the point, potential at the point into charge. Because no, we are moving how much charge? External field E into R. Two charges are placed at. So here total potential energy of the system of charges. First, Q1 is placed in the potential produced by external. This external field produces a potential at V1 plus Q2 is placed at the external field produced by 2 plus the self energy of the system of two charges, that is 1 by 4 pi epsilon 0 Q1 Q2 by R. So there will be three terms will be there. The two charges are placed in the external potential field produced by an external field. So what will be the potential at that point? Q1 into V1 plus Q2. V1 is a potential produced by this external field at the position of Q1. Similarly, V2 is the potential produced by external field, and this is the mutual self energy of the system of two particles. So we have to first we have to calculate V1. V1 is equal to how many? Minus, so integral E, because both E and R are in same direction. So integral E dr, E dot dr, E dr in same direction, isn't it? And from where potential 0 to, and we can directly 0 to the position where what percentage is there? It is minus 9, isn't it? So what will be the electric potential at that point P? Integral E. So that comes to be what? A divided by R. A divided by, because A will come out, R to the power of minus 2 on integration will become R to the power of minus 1 by 1. This 2 minus will cancel out. It will be A by R. Potential will be A by R. And this is equal to A by R will be, A is given to be how much? A is given to be 9 into 10 to the power of 5. Here I want the numerical value of R only, isn't it? R is how many? 9 centimeter, isn't it? Into 9. So 9 into 10 to the power of minus 2. So that comes to be 10 to the power of 7 volt. So potential at the point of 7 microcoulomb is what? That is V1 is, once again, integral infinity to that point, or minus E dot dr, that is A by R. Integrating will be getting A into minus, sign get cancelled, R to the power of minus 2 will become R to the power of minus 1. So we'll be getting A by R, and that is A is 9 into 10 to the power of 5. R is 9 into 10 to the power of minus 2. It is in centimeter. That comes to be 10 to the power. Similarly, V2. V2 is come to be, similarly, this is come to be A by R. That is what? 9 into 10 to the power of 5 divided by what? Same location, same distance. So it will be 9 into 10 to the power of minus 2. That coming to be 10 to the power of, not Newton, volt, 10 to the power of 4. So potential at V1 and V2 will be 10 to the power of 7. Now we have to calculate from this formula. Total potential energy will be Q1. Q1 is what charge? Plus charge. Kept where? 7 into 10 to the power of 7 into how many? 10 to the power of 7. 10 to the power of 7 into Q1. What is Q1? 7 into 10 to the power of minus 6. plus second term will be Q2 V2, that is 10 to the power of 7 into minus 2 into 10 to the power of minus 6, plus third term mutual potential energy. How much? 9 into 10 to the power of 9 into Q1 Q2. Q1 Q2 will be, it will be into 7 into minus 2 into 10 to the power of minus 12 divided by separation between them will be 18 centimeter. 18 into 10 to the power of minus 2. Okay. So what is coming to be, this is 9 into 2, that get cancelled. What is left over here? 10 to the power of 9, 10 to the power of minus 2, that is 10 to the power of 11, and this is 10 to the power. This is coming to be 0.7. This term is, so I'll write all the terms together. That is total potential energy of the system. First term will be, this is 10 to the power of 7, 10 to the power of minus 6, that is 10, that is 70. Second term minus 2 is minus char, this is coming to be minus 20. Third term is coming to be minus 0.7, this is coming to be 0.7. So this is 70, 49.3 joule. So answer is 3. Okay, so two charges are placed in the potential produced by an external field. We have three terms, Q1 V1 plus Q2 V2 plus self energy of the two charges, that is 1 by 4 pi epsilon 0 Q1 Q2 by R. This is the formula for that. We go to the next question. Yes, we have to find space between the parallel plate capacitor is C without any dielectric. So I can directly write without wasting time. C can be written as epsilon 0 A by D. Correct? Now we have to calculate filled with the dielectric slabs of dielectric constant. We have to calculate the new capacitance. So we have three ones. I can say C1, C2, C3. This I say C1. This is C2, this is C3. So I can directly write, we have done previous time that C1 is what? This one. Separation is half. So therefore, effective capacitance will be C into what? 2K1. Correct? C into 2K1. Then C2 will be epsilon 0 A by 2 divided by D by 2 into KT. That comes to be epsilon 0 A by D into K2. That is C K2. Now without any delay, I can directly add, what about C3? C3 will be C into K3. Now first C2 and C3 are in parallel. So I call C23 combined of the parallel effect. So one is CK2, other is CK3. This is coming to be, and whether values are given to you? Yes, values are given. So I can directly write, this will be, K1 is what? 2. This will be 2 into 2. This is 4C. And K2 is 3. This is 3C. And K3 is what? 5. This is 5C. Therefore, C2, 3 will be, they are in parallel. So it will be what? C2 plus C3. What is that? 3C plus 5C. That is coming to be 8C. Now, C1 and combined C23 are in series. Therefore, effective capacitance C dash I call, C dash is coming to be C1 into C2. So I am writing a formula, C1 into C23 divided by C1 plus 2C3. Okay, who is common there? C I have taken out common, then C is taken out common into C1. C1 is what? We got 4. C1 is 4. Isn't it? 4. 4 into C23 is what? C23 we got it as 8. C23 we got it as 8. Therefore, 4 into 8. Denominator 4 plus 8. So this is coming to be C into this 4 get cancelled 3. This is 8 by 3. And it is given to be n by 3c. So in place of n, we have 8. So simple combination. We have done in 2-3 problems we have done. Weightage is given to the capacitance problem is very good. Similar questions, 2-3 questions are asked. Okay, we got it? Come on. Next question. Okay, this is a very common problem. There are two charges, one placed at the corner of the cube, other placed at the base of the surface. So due to charge 2q, okay, quickly I will say, this is a very commonly asked question. Everybody knows that. 2q is placed at the corner of a cube. We cannot apply the Gauss's theorem. Gauss's theorem to be applied, charge must be kept either at inside or outside. Here it is at the corner of a cube. So to make it inside, we think of 8 such cubes, 4 on the bottom, 4 on the top, so that this charge 2q will be coming in the symmetric center of the big cube formed. So I can calculate the flux for the big cube. So flux for the big cube is equal to charge is 2q, that is at the symmetric center into epsilon 0. Therefore, flux through given cube, will be 2q epsilon 0 divided by 8, that is q by 4 pi epsilon 0. Now, due to charge q is kept at the center of one of the face. So make it inside. We have to imagine only 2 cubes just touching each other. So what will be happening? This charge q will be at the symmetric center. Flux will be what? Q by epsilon 0, whatever be the size, or doesn't matter. If 2 cubes club together, whatever it may be, total flux will be Q by epsilon 0, and that is claimed by 2 cubes. Therefore, the flux through the given cube will be Q by 2 epsilon 0. Both flux are merging out. Therefore, total flux will be how much? 2q by epsilon 0. No, 2, sorry. What is that? Q by 4 epsilon 0 plus Q by 2 epsilon 0. That is coming to be 3q by 4 epsilon 0. 3q, but this is the correct answer. So, similar questions we have done a number of occasions, you know that. Okay, we go to the next question. Capacitor of capacitance is fully charged with a potential difference of 6 volt and disconnected from the battery. So, I can say that charge stored in P, charge stored is equal to Q is equal to QP is equal to CV. Therefore, QP is coming to be, what is the capacitance? 10 to the power of 10 microfarad. That means 10 to the power of 5 farad into potentially 6. That comes to be 6 into 10 to the power of minus 5. Now we are connected parallel to another capacitor. It is uncharged. Therefore, total charge was Q is uncharged. Total charge available available for combination of P and Q, that is still 6 into 10 to the power of minus 1. And one connected parallelly, Q1 will be Q2. Charges will be QP divided by QQ. Charges will be arranged in the ratio of the capacitance. The ratio of the capacitance. They are connected parallelly. Ratio of charges. Ratio of the charges will be ratio of the charges. QP divided by QQ will be CP divided by CQ. CP is what? 10 into 10 to the power of minus 6 divided by other is 20 into 10 to the power of minus 6. That comes to be 1 by 2. Therefore, charges will be divided in the ratio of 1:2. I have to calculate the charge in what the charge in the capacitor Q. Therefore, QQ will be total charge available is 6 into 10 to the power of minus y. In what ratio? 1:2 ratio. That will be 2 by 3 because 1:2 ratio. Therefore, it will be 6 into 10 to the power of y into that comes to be how much? 4 into 10 to the power of minus y. And this is given to be alpha into 10 to the power of minus y. Therefore, alpha is coming to be 4. Alpha is coming to be 4. That is a fill up the blank question is there. So, alpha you have to get it. Alpha is coming to be, alpha value is, yes, alpha is coming to be 4. It's a correct answer. Alpha is simple. When capacitors are connected parallelly, charges will be distributed in the ratio of their capacitance. And initially only P was charged. The total charge in P will be distributed in both of them. Only one was charged. Total charge was 6 into 10 to the power of, and ratio of capacitance is 1:2. We have to divide in the ratio 1:2. That is QP by QQ, or QQ will be total charge into 2 by 3. Okay, we get it. We go to the next question. Yes, 14th question. 3 small identical bubbles after having same charge coalesce to form a big. So this is a very direct question. N charges combine together to form a big drop. Total charge of the big drop will be N times Q. Radius of big drop will be N to the power of 1 by 3. The radius of the small drop, N to the power of 1 by 3R. Capacitance will be N to the power of 1 by 3 of the capacitance of single drop. And potential will be N to the power of 2 by 3 of the each droplet. We have to find ratio of the potentials of one initial bubble. That is, we have to calculate V is to N to the power of 2 by 3V. That is 1:N. How many droplets? 3. Therefore, 3 to the power of 2 by 3. Answer is very direct question. So, but remember it, 4 things. When N charges combine together, total charge of the big drop will be N times. Radius will be N to the power of 1 by 3 times. Capacitance also N to the power of 1 by 3 times. Potential will be N to the power of 2 by 3 times of the single drop. Here N is 3, so it will be 3 by 3 to the power of 2 by 3. Ratio will be 1:3 to the power of 2 by 3. So we can go to the next question. Now, this is also an easy question. 5 identical charges, no need of any calculation. It is a symmetric center. Electric field will be 0. Electric field is 0. Yes, first option. Second, potential. Potential will be 5 times potential due to each charge. That is 1 by 4 pi epsilon 0 into Q by R. So field will be 0. Potential will be 5Q by 4 pi epsilon 0 into R. So answer is 2. Correct? Potential is this and field will be 0. It's a very direct question. We go to the next question. Yes. Now 6 point charges are kept. So circle of radius capital R as shown in the figure, net electric field. So again, you have to work out from mind. Everything, there is no meaning in going mathematically. Look, I take this pair, I just number the pair like this. 1 and 1, this is 1 and pair. This is 1 and 1, identical. Its field get cancelled. This is 2 and 2 pair. This field get cancelled. Correct? Now, field is produced by this pair. So, 3, 3 pair. So, field is produced by field is produced by 3, 3 pair. Isn't it? So, due to plus Q, due to plus Q, field is given by how much? Due to plus Q, field is given by 1 by 4 pi epsilon 0 Q by R squared. Correct? That is towards minus Q. Radially away. Field is radially away. And due to the minus Q also, field is radially inwards. So, due to minus Q, same field 1 by 4 pi epsilon 0 Q by R squared towards minus Q. So both the fields are in same direction. Therefore, net field E net, both the fields are in same direction. That will be 2Q divided by 4 pi epsilon 0 into R square. Now, I'm just drawing it. They're given x-axis and y-axis. This is x-axis and this is y-axis. This is our resultant field, E net. And you know, this angle is coming to be 30 degree. Both are 30. Yes, this is 30 degree. 30 degree with x-axis. Because correct. This is 30 degree with x-axis. Yes. Now, I want the x and y components. So, E net x will be, this is E net x, E net x will be along negative x direction. How much it will be? 2Q divided by 4 pi epsilon 0 E net is equal to minus along negative x direction. That is 2Q divided by 4 pi epsilon 0 into cos 30. Cos 30. That is root 3 by 2 get cancelled. It is coming to be minus Q root 3 4 pi epsilon 0. Then E net x, E net x minus along x direction. E net y, that is acting upward direction, this direction. That is E net y. That will be minus 2Q divided by 4 pi epsilon 0 sine 30. And that comes to not minus, no minus sign here, this is upward direction. No minus sign because along positive y direction. So this is coming to be sine 30 is half get cancelled, q divided by 4 pi epsilon 0, r squared is there, r squared is there, r squared along positive y direction. So we got E net x and we got E net y, isn't it? Along y direction. X direction is minus. So what will be the common we have to take out? Common, I can take out what? Q root 3 divided by 4 pi epsilon 0, we can r squared, we can take it out. What is left over there? Minus root 3i plus what? J. No, root 3, we cannot take it out. I'm writing net field. Common term is what? Q by 4 pi epsilon 0 minus root 3i plus j plus j. Yes, any mistake. 30 degree, these are 30, 30. E cos 30 is sine j plus. Where we made any mistake? Oh, correct. We have taken minus sign out. When you take minus sign out, E net will be is equal to minus Q by 4. Minus sign is taken out. So this will become plus and this will become minus. Root 3i minus j. Root 3i. So this will be the correct answer. Minus Q by 4 pi epsilon 0. This will be the correct answer. You got it? So once again, pairs 1 and 1 cancel out, symmetric. Pairs 2 and 2 cancel out. Pairs 3 and 3, there is a net force towards the minus Q. And that we calculated. And we found it X component, Y component separately. And we got the correct answer. Come on. Electric field in the region AXI plus BYJ, where A is 10, B is 5 volt. Electric potential at a point 10, 0 is 500 volt. So we can find that electric potential at the point P minus 0.0. We can write minus integral where to where we are taking. Yes, electric potential at the point. So we are bringing from infinity to the point P. Infinity to the point P. What? AXI plus BYJ dr dx dy. Okay, we can calculate it. So it is coming to be Vp minus V0 AXI. Integrating, we will be getting AX square. Minus is there. AX square by 2. AX square by 2. Isn't it? Then plus by square by 2. Then limits what? Infinity to the P. Infinity to the point P. P will be 10, 20. This is the potential difference. This is minus, minus integral E of R dot dr. That will give the potential difference. So potential at the point P minus potential at origin, that I call E not 0 but VO origin, that I have to calculate, is equal to minus integral AX square by 2 plus BY square by 2 infinity to 10, 20. So we have to work it out. Listen. Then minus AX, put the value X is equal to what? A is how much? 10. Therefore, X is 10. Therefore, 10 into 100, 10 into 100, 10 into 100 divided by 2 plus B is how much? 5 into Y is how much? Y is 20. That is 400 divided by 2 minus infinity means that will be 0. Therefore, once again integrating ax square by 2 plus by square by 2 limits infinity to 10, 20. For x I have to give 10 and y I have to give 20. Isn't it? Okay. Then a is 10. 10 into x square is what? 100 by 2. Yes. Plus b is 5 into 20 square is 400 by 2. That comes to be minus of, this is coming to be 500 plus this is coming to be 1000. This is 1000. Okay. This is 1000. Therefore, this is coming to be minus 1500. But it is given that potential at the point P is what? Electric potential at the point P is 500. We have to find the potential. So Vp is 500. 500 minus V at origin is minus 1500. So I write once again 500 minus potential at origin is minus 1500. That gives you potential at origin is equal to 500 plus 1500. That comes to be 2000 volt. Okay. Yes, 2000 volt is the answer. Okay. I think third or fourth problem is coming of finding the relationship between potential and field. Okay. Yes. We have to go to the next question. Now, a simple circuit is given. I'll show in the diagram itself, so there is no need of wastage of time. You know, this I can call diode 1, diode 2. Diode 1 is reverse bias, doesn't conduct. Diode 2 will be forward bias, it will be conducting. So first point you have to write, diode 2 will conduct. Diode 2 will conduct. Okay. So second point, R effective of the circuit. How much? We don't count the resistance in the capacitor branch. We don't count these two resistances are not to be counted. Not to be counted. This and this. Because it is reverse bias and there is no current in the capacitor. Effective resistance will be 4 plus how much? 1. That is 5 ohms. Number 3, main current will be 2.5 divided by 5. That is coming to be 0.5 ampere. Number 4, ED cross capacitor is equal to ED across 4 ohm resistor, because there is no potential difference across this PD across capacitor is equal to PD across 4 ohm resistor. That is equal to 4 into 0.5. That is coming to be 2 volt. Therefore, fifth one, we have to calculate what? Charge on the capacitor. Charge on the capacitor is equal to, Q is equal to C into V. C is coming to be 5, V is coming to be 2, that coming to be 10 volt, 10 volt, isn't it? This is 10, not 10 volt. We have to calculate the charge. That is equal to 10 microcoulomb. So this is coming to 10. Okay. Yes. Next question, we are going to next question. Consider two identical metallic spheres of radius r, each having a charge q and mass m. Their centers have an identical separation of r. Both spheres are given an initial speed of u towards each other, then minimum value of u. So this is a problem of energy conservation. First point, this is a problem of energy conservation. Now, initially, both the spheres are given initial speed of u. So its kinetic energy is half mu squared into 2. Two spheres are there. Plus mutual electrostatic potential energy. Both of charge, one q charge, and separation of how many initially? 4r. Therefore, potential will be 1 by 4 pi epsilon 0 q square by 4r plus gravitational potential energy, that is minus g m square, each of mass m, at a separation of 4r. This is initial energy. I can say, using energy conservation, initial energy. Then final energy, what you can say, they just touch each other. Just touch each other means the spheres will come to a halt. They will be losing its kinetic energy. They will be having electrostatic potential energy and magnetostatic potential energy. What will be electrostatic potential energy? They are just touching, like this. I am drawing the diagram. Just touching. Their centers to center distance will be 2r. Therefore, E final can be given by 1 by 4 pi epsilon 0 q squared by 2r plus minus g m square by 2r. Now we can equate initial energy and final energy. Both can be equated, isn't it? So half mu square plus 1 by 4 pi epsilon 0 q square by 4r minus g m square by 4r is equal to, here 1 by 4 pi epsilon 0 q square by 2r minus gm square by 2r. I want u, and I can cancel out m. So what is left over? Half u square is left over. U square is left over. Okay. Then dividing by m. Yes, this will go to the other side. This will go to the other side. So it will be coming to be m, let the m to remain over there, half mu square. This term will go over there. This will become q square by 2r minus q square by 4r. So it is coming to be 1 by 4 pi epsilon 0 q square by 4r. Subtracting will be getting it. This is q square, this will become 4. So gm by gm square by 4r minus gm, that will be minus gm square by 4r. This is the answer. Now m get cancelled. We can take out the 1 by 4 pi epsilon 0, we call it as k, isn't it? Then k I have taken out, divided with m. So you will be getting u square is equal to this, 2 will be going over here. We have taken out k, q square by r is taken out, isn't it? By, yes, by 2m. By 2m we have taken out. 2m we can take out. Yes. Into, yes, this 2 will go to the numerator. Okay, sorry. 2 will go to the numerator. So k q square by k, this is k q square by 2 go to that side. 2 go to that side. So it will be 2r squared. That I have taken out. What will be remaining? 1. 1 m is also taken out. According to the option, we have to frame out. So we are divided by m, u square will be, this 2 will go to the other side. So it will be, this is k, this is q square divided by 2mr squared. That I have taken out. 1 is left over here. Here, how much will be remaining? The 2 will go to the other side. Then that is coming to be g m square. It's not r squared, only r to be taken out. Oh, this is r to be 4r. So this is k q square divided by 2mr taken out. 1 minus, then 1m get cancelled. K will come in the denominator. It is coming to be minus gm divided by, and q square also coming out. Aq square is. So what is left over? Aq square by 2mr. We have taken out 2mr. We have to say 2mr. Oh, so many. So look, I'm getting u square is equal to m goes down, 2 goes here, k into u square divided by 2m 2mr. I have taken out. What will be remaining here? 1. Then m I have taken out, already I have taken out m. What will be remaining here? G will be remaining here. M square will be remaining here. Isn't it? Since 1, 2 have gone, 1, 2 will be remaining here. 2k q square. What will be the answer? Yes, kq square by 2mr into 1 minus 2m. So it's a long calculation we have. Okay. But basic idea behind the question is simple: total energy conservation. This is first case, this is second case, then we equated it, then simplification part only we took some time. Okay, doesn't matter. Now we go to the next question, question number 20. A parallel plate capacitor of capacitance G when vacuum, then parallel thickness D, a dielectric sheet of thickness 1 by 3 separation between and relative permittivity or dielectric constant K. We have a ready-made formula for C dash new capacitance is given by C divided by D minus T plus T by K. This is a ready-made result to be remembered when some space is filled with, some region is filled with of thickness T and dielectric constant K is filled in the space between the plates. The new capacitance can be given by C divided by D minus T plus T by K. Now, what is T? T is D by 3. K is K itself. That is plus D by 3K. This is coming to be what? D minus D by 3. This will be D, I have taken it out. This is coming. D by 3, I have taken it out. This is 2 plus 1 by K. Correct? So I'm taking 3 to the numerator. 3Z divided by D, 2K plus 1 into. So what about D? 3KC, correct? 3CK divided by 2K plus 1. E will not. Parallel plate capacitors. So 1 minute, we can go to the options. We have to replace C. So this will be Not C. This is, that is a mistake we made. This is epsilon 0 A, correct? This is epsilon 0 A. This is epsilon 0 A. Now, what will be happening? This is a formula, not C. Epsilon 0 A divided by epsilon 0 A divided by D minus epsilon 0 A D divided by D minus T plus D by K. This is D minus D by 3. So, epsilon 0 A by D, 3 will go to the numerator, LCM K will go to the numerator. This will be 2K plus 1. This is C. Therefore, C into 3K divided by 2K plus 1. It's a very simple direct question. Just a silly mistake happened. What is the mistake? It is not C. It is epsilon 0 A. Epsilon 0 A. Then if space between the capacitor is filled with a dielectric, some thickness, formula is epsilon 0, I'll write clearly. Formula is given by epsilon 0 A divided by D minus T plus T by K. Now here T is D by 3. So you simplifying, we are getting epsilon 0 A by D. That is given to be C. That is given to be C. It will be C into 3K divided by 2K plus 1. So we have the correct answer. 2 is the correct answer. Okay. I think one more question is there. No, one more? No. 20 question is good. So 20 is, this is same question. Now, yes, a point charge 10 to the power of minus 8 coulomb, that is Q given to be 10 to the power of minus. Work done in moving a charge from 2 microcoulomb charge from A to the B. So we have to calculate potential at the A due to the charge microcoulomb, potential at A. So what will be that? 1 by 4 pi epsilon 0, correct? Then Q divided by distance, that is a RA. 1 by 4 pi epsilon 0 is 9 into 10 to the power of 9 into charge is 10 to the power of minus 8. This is root of 4 square plus 4 square plus 4. This is in meter. That is 36, 36. This is coming to be 90 divided by 6. That is 15 volt. Then VB, second point, same explanation, 9 into 10 to the power of 9 into 10 to the power of minus 8 divided by distance of that point. Second point is 2 square plus 2 square plus 1 square. That is coming to be 90 divided by root 9. Root 9 is 3. That is 30 volt. Now we have to calculate the work done. Work done in taking from A to B is equal to potential of B minus potential of A into charge we have taken. Potential of A is 30, potential of B is 15 into charge we have taken is how many? 2 microcoulomb. 2 into 10 to the power of minus 6. That comes to be 15 into 2, 30. 30 into 10 to the power of minus 6. Answer is coming in joule. The answer is this, 30 into 10 to the. So very simple question, last question. Work done is difference of one mathematical information you need is that its position coordinates are given. Therefore, position vector of the point is given by root of 4 square plus 4 square plus 2 square. That is coming to be root 36, that is 6, and potential is coming to be 15 volt. Similarly, second point B, that is 30 volt. We are taking from A to B. Work done is difference of potential between A and B, VB minus VA into charge taken, that is 30 minus 15 into charge taken is 2 microcoulomb. That comes to be 30 microjoules energy. Okay, so I think that's all about the questions. Yes, all the questions are over. Okay, so comparatively very good weightage is given to the electrostatics chapter, and especially we have same questions are repeated, that capacitance combinations questions are 3-4 questions are asked, then relationship between field and potential questions are asked a number of times, so you can have an information regarding the nature of questions asked. Okay, we are discussing current electricity. More or less good weightage of questions has come from this chapter also, just like in electrostatics. Current entering here and distributed, whatever resistance arrangement is available at A, exactly same resistance arrangement is available at B also. So in transmission, power wasted is given by I squared into R, that is 32 hours. How much power is reaching our destination, that is 1000, and that we call output. And during this transmission, how much wasted, that we calculated as I squared into R. Power wasted is I squared into R. Today we are discussing current electricity. More or less good weightage of questions has come from this chapter also, just like in electrostatics. Question number 1. Yes, an arrangement of 4 resistors are given. Initially, it is given that R1 is equal to R2 is equal to R3 is equal to R4. Okay. Then one of them is heated. R3 is heated, so that resistance increases by 10%. Potential difference between the points A and B. Okay. Now, first case, when the resistances are equally divided, so therefore assume the 20 volt okay, that the bridge is balanced, R3 increases means R3 becomes 1.1 R. R3 becomes 1.1 R. Okay. In the second case, R3 becomes 1.1 R. Now, in this case, this will be, suppose I say this is R, this is R, this is R, this will be 1.1 R, this will be R. So, tell me across the points, suppose across this point C and D, potential difference is 40 volt, we call it as V, let it be V. Therefore, potential of A will be 40 into V divided by what? R2 by R1 plus R2. That is given to be R by 2R, that is 0.5 V. But here it will be divided in the ratio of 1.1 R to R. Therefore, VB is coming to be V into R4 by R3 dash. This is R3 dash. R3 dash is 1.1 R. So this is coming to be V into 1 by 2.1. Isn't it? Earlier, both of them were V by 2, V by 2. Now, R3 has changed to 1.1 R. As a result, potential difference, potential of the point B can be given by total potential into what? Total potential into R4 divided by R3 plus R3, R4 by R3 dash plus R4. That is coming to be V into 1 by 0.21. Then we have to find the difference between them, VA by VB. So it is coming to be V into 0.05 by 21, and V's value is 40 volt. Value of V is 40 volt. So we will be able to calculate it as 0.95 volt. 0.95 volt. Okay. Yes. Answer in the options is first option. Now come to the next question. Now here we didn't give any printed explanation, so we are giving you a detailed explanation of it. Now, first of all, this is not a balanced bridge because here R1 by R2 is 2. Here R1 by R3 by R4 is 1 by 2. So it is not a balanced bridge. Hence, we have to solve it out here. Now, let the current entering at A, that we call I, and the current through this is I1, this is I2. Current is distributed. So we can first find that I is equal to I1 plus I2, equation number 1. Now, current entering here and distributed, whatever resistance arrangement is available at A, exactly same resistance arrangement is available at B also. At what way? Current is entered at A and distributed. Exactly same resistance arrangement is available at B. Hence, whatever manner the current has entered at what? A, same manner the current will leave. Here, same current I or I1 plus I2 will leave. So this is 6 ohms, this is 6 ohms, therefore current should be I1. This is 3 ohms, this is 3 ohms, this will be I2. So mere symmetry of arrangement of resistance. Whatever manner current is entered at A and distributed, same manner current is reaching at B and leaving. Due to the symmetry, this branch, 6 ohm branch current is I1, here 6 ohm branch current is I1. Here I2, here I2. So what about this current? This current will be I1 minus I2. Now, using Kirchhoff's law, potential difference between A and B, I go this manner. A, suppose I make C O. ACDB, if this manner I go, VAB is equal to, we can find that VAB is equal to I1 of I1 into 6 plus I1 minus I2 into 3 plus I1 into 6. Okay. So VAB is coming to be 6I1 plus 6I1 plus 3I1. So 15I1 minus 3I2. Equation number 2. That is 6I1 plus 6I1, 12I1 plus 3I1. That is 15I1 minus 3I2. Now we go this way. In the path A, C, suppose I make it E. Oh. In the path A, C, E, B. In the path A, C, B. Tell me, again using the Kirchhoff's law, I will be getting potential difference between A and B. We can find that 6I1 plus 3I2. That is equation number 3. So already we got I is equal to I1 by I2 and VAB is equal to 15I1 minus 3I2. This VAB is equal to 6I1 plus 3I2. So equating this, we will be getting 15I1 minus 3I2 is equal to 6I1 plus 3I2. Therefore, this is coming to be 9I1 is equal to 6I2. This gives you I2 is equal to 9I1. 9I1 is equal to 6I2. I2 is equal to 3 by 2I1. Equation number 4. Okay. Now, consider the whole arrangement. How much current is entering? I current is entering. And we can find that potential difference between A and B can be also considered as current entering into the network into effective resistance of the combination. Into effective resistance of the combination. I into R effective. Isn't it? That is also VAB. Now tell me, we have I2 is equal to 3 by 2 R2. So putting in the equation number 3, putting in equation number 3, we will be getting VAB is equal to 6I1 plus 3I2. I2 will be 3 by 2I1. From equation number 3, we will be getting VAB is equal to 6I1 already there. Instead of I2, what we can write? 3 by 2I1. Therefore, VAB is coming to be how many? This is 3 into 3 by 2. That comes to be 9. That is 6 plus 9 by 2. 12, 21 by 2. Correct? That is 9 by 2. 3 into I2 is equal to how much? I2 we got 3 by I1. Therefore, VAB is coming to be 21 by 2 I1. Okay. Now, we can go back to equation number 5. So, VAB is coming to be I. So, this is also VAB. I into R effective is equal to here 21 by 2 into I1. But I is equal to I1 plus I2 into R effective is equal to 21 by 2 I1. Again, we have to replace this I2 as what? 3 by 2. This will be equal to I1 plus 3 by 2 I1 into R effective is equal to 21 by 2 into I1. This is coming to be how much? 5 R effective. Oh. This is coming to be I1 plus 3 by 2 I1. That comes to be 5 by 2 I1 into R effective is equal to 21 by 2 I1. I1 also get cancelled. 2 get cancelled. R effective is coming to be 21 by 5. And the question asked you, it is x by 5, then x is coming to be 21. X is coming to be 21. Okay. So, somewhat lengthy calculations. We have taken 2 branches. First branch, ACDB branch. We have calculated, applied the Kirchhoff's law. Then we have taken ACEB branch. We have calculated, we have written it. From that, we solved these equations. We got I2 is equal to 3 by 2 I1. Then consider the whole network together. Its effective resistance we have to calculate, that is RAV. Therefore, potential difference between the points A and B is given by current entering the junction, that is I, into R effective. But we know I is equal to I1 plus I2, I1 plus I2, I1 plus I2. Now, again coming back to equation 3, we are getting VAB is equal to 21 by 2I1. Then equating this equation with 5, we will be getting I into R effective is equal to 21 by 2I1. Then solving, we are getting R effective is equal to 21 by 5. It is given R effective is X by 5. Who comes in place of X? This will be coming. Okay. Now next question, in a potentiometer experiment, when the cell is secondary circuit is shunt with 4 ohm resistance, the balance obtained is 120 centimeter. Now when the same cell is shunt with 12 ohm resistance, then balancing is shifted to a length of 180 centimeter. Now, in potentiometer experiment, this is a method to calculate the internal resistance of the cell. Basically, we have to calculate the internal resistance of the cell. So, the cell is shunt with a resistance. As a result, now balancing is done not with the, normally if it is not shunt, when balancing is attained, the balancing is done with the EMF of the cell. But when we have connected and shunt resistance, there will be a current flow. A current flow takes place. Current flow takes place through the external resistor. As a result, we are not balancing with the EMF of the cell. We are balancing with the terminal potential difference. Terminal potential difference. So first case, that terminal potential difference is V into what? E into R by R plus R. Terminal potential difference will be, that is a potential difference across R. That will be EMF by current is E by R plus E by R plus R into R. This is the terminal potential difference. And we know current is balancing length is proportional to the terminal potential difference. So L is proportional to R by R plus R. And here L is coming to be how many centimeter? L is coming to be 1 centimeter. Now same thing is repeated with another resistance in the accession, that is coming to be R2. That is coming to be R2. And again, second case, L is proportional to R2 divided by R2 plus R. So, dividing L1 by L2, first case effective resistance is R1 by R1 plus R. Second case R2 by R2 plus R. Balancing length is 120 by 180. And solving, we are getting the value of small r is equal to 4 ohms. Okay, we will be getting it. So, the mathematical steps of finding out the R is given here. So, one thing here, we are balancing not with the EMF of the cell, that is the terminal PD across the cell. And formula for terminal PD is given here, ER by R plus R. Therefore, balancing length is proportional to terminal PD. In first case, the shunt resistance is R1. Therefore, L1 is proportional to R1 by R1 plus R. Second case, L2 is proportional to R2 by R2 plus R. Then L1 by L2 will be what? 4 by 4 plus R. First case, it was 4 ohms. Second case, it is 12 ohms. And solving, we are getting value of R is equal to 4 ohms. Okay, clear. Now, two cells of EMF E, internal resistance R, current passing through it is external resistance 6 ohm. When both cells are connected in either in parallel or in series. When cells are connected in parallel, effective resistance, first in series. When cells are connected in series, effective EMF will be 2E and internal resistance will be 2R. Therefore, current drawn will be 2E divided by R plus 2R, where R is external resistance, that is going to be 6 ohms. We have to calculate the value of internal resistance. Now, when they are connected in parallel, if cells are identical and cells are connected in parallel, whatever the number of cells may be, effective EMF will be E itself, provided all the cells are identical. Here we have 2 cells, all are identical, both are identical. Therefore, effective EMF will be E itself, but internal resistance will be R by 2. Therefore, current is second case will be E divided by R plus R by 2. It is mentioned that current in series combination and current in parallel combinations are equal. So we equated these two. 2E by R plus 2R and E second case E by R plus R by 2. Then only mathematical steps on solving it, we are going to get small r is equal to capital R. And small r is given as 6 ohms. Therefore, capital R is given as 6 ohms. Therefore, internal resistance will be equal to 6 ohms. Okay? Come on. Go to the next question. In a meter bridge experiment, to determine the value of unknown resistance, first two resistors are 3 ohms, or 2 and 3 ohms are connected in the left and right gaps. Null point is obtained as L. Then when unknown resistance X is connected parallel to the 3 ohm resistance. So first case, when balancing is attained, what is the principle? R1 by R2 is equal to L by 100 minus L. R1 by R2 is equal to 2 by 3 and L by 100 minus L. And L by, therefore, L is coming to be 40 centimeter. Because equating 2 by 3 is equal to L by 100 minus L and solving, we got balancing length in first case is equal to 40 centimeter. Now what we have done, connected parallel with 3 ohm resistance. So now the new resistance in place of 3 ohm will be parallel connection 3x divided by 3 by R. And balancing length is shifted by 10 centimeter. Surely balancing length increases. So new balancing length will be 40 plus 10, 50 centimeter. Now in the new situation, again, we have to calculate what the value of X you have to calculate. The 3 ohm resistance has become what? R dash. What is R dash? 3x divided by 3 plus. Again, using the principle, 2 by R dash is equal to 50 by that is equal to 1. Okay, because balancing length is 50 means R 2 by R dash is 50 or R dash is equal to 2. But R dash, you know, it is what? 3x divided by 3 plus x is equal to 2. Or 3x is equal to 6 plus 2x, and solving, we will be getting x is equal to 6 ohms. Okay. Next question. Regular hexagon is formed, 6 wires, each of resistance R ohms, and corners are joined to the center by means of the resistance. The current enters in one corner and leaves the opposite corner, equivalent resistance of the hexagon will be. So it is better to draw a diagram, and we are drawing a diagram. So hexagon diagram is not here. Okay, we'll make out a hexagon. Yes, and ends are joined, and this is the center. So current is entering at the one junction and leaves through. This is the arrangement given, and all segments are of resistance R, 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 R. For convenience, let us put this is A, current entering at A, leaving through B. This is C, this is D, this is E, this is F, this is O. Now, same explanation I given earlier. Whatever the manner current is entered at A and distributed, same resistance arrangement is available at, same resistance arrangement is available at what? The B, whatever manner the current entered at A and distributed, same manner current will reach at B and leave it. Suppose current is coming, one current going through this branch is I1. Due to symmetry, current through this branch is also I1. Symmetrical arrangement. Whatever the distribution is given in the upper segment, same arrangement, same segment. Now, let this, I call it as some I2. Now look, whatever manner current is entered at A and same resistance arrangement is available at the end B, the current should reach here in the same manner. So this will be I1, this will be I1, this will be I2. Okay. So we have distributed the current based on the symmetry arrangement. Only when it is symmetry, they are different resistance, this solution is not at all possible. This is possible because of the reason that there is a symmetry arrangement. So I use the logic of symmetry to arrange it like that. Now look at here. How much current is entering at O? I2. And same current should leave this as I2. Okay. So it means that there should not be any branching of current at O. There should not be any branching of current at O. Therefore, there is no meaning in connecting here. If the connection is there or not, doesn't matter. Isn't it? So, I2 current is reaching at O and I2 current should leave. So, there is no meaning in the join there. Therefore, there is no branching of current. There is no branching of current at O. So, tell me, this in the configuration COD, it is, I told you it's not join, just detach, because there is no meaning in joining. Due to the joining, no current change is happening because I2 current has reached at O, I2 current has to leave, so there is no meaning in joining, so we disjointed it. So in COD configuration, this R and R, same current is passing through it, that is, and these two resistors are in series, 2R and R are in parallel. Therefore, this will be is equal to, effective resistance is equal to 2 by 3R. Okay. Now, in the upper segment, effective resistance will be R plus 2 by 3R plus R. This R, this combination is 2 by 3R, this R. That is coming to be 8 by 3R. And whatever the arrangement of resistance is there in the upper segment, same arrangement is in the lower segment also. So in lower segment, how much? 8 by 3R. And one more branch is there, AOE branch, AOB, direct AOB branch. I told you, I2 current is entering at O, I2 current is leaving. So these two resistors are in series. Effective will be 2R. Effective will be 2R. So now upper branch, lower branch, AOB, all are in series. Then 1 by R effective is equal to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by R1 and 1 by R2. How much it will be? 3 by 8R plus 3 by 8R plus 1 by 2R. Isn't it? And now we are solving it. You will be getting R effective is equal to 4 by 5R. Now simple mathematics. This is 1 by 8, 3 by 8R, 1 by R effective is equal to 3 by 8R plus 3 by 8R plus 1 by 2R, and that is coming to be 4 by 5R. So, second problem we are using logic of symmetry. Only we can do this method clearly. Okay? Yes. So, once again that I am highlighting the point. Current entering at A from A is I2. Current going from O to B is I2. There is no current branching. So, there is no meaning in these segments joining with O. Either you join it or you don't join it, doesn't matter. So, we not joining it. So, this COD branch is a separate branch. Bottom EOF branch is a separate branch. And that branch resistance is coming to be 2 by 3R. Okay. Now come to the upper segment. AC, COD and DB. That coming to be, all are in series, R plus 2 by 3R plus R. That comes to be 8 by 3R. Lower segment 8 by 3R. And one more segment directly AOB, that is 2R. All the three segments are connected in parallel. So we'll be getting this. We go to the next question. Now, resistors 2 ohms and 3 ohms in the gaps are shown in the figure. Null point is obtained. So, same question, only difference with question number 5. Question number 5. There, null point shifted by 22.5. Here, null point is shifting by how much? 22.5. There it is 10 centimeter. Same explanation as we have done in the question number 5. No difference at all. And you can find that the value of resistance of unknown resistor is coming to be 2 ohms. So I am not explaining because only one difference. There the balancing point is shifted by 10 centimeter. Here balancing point is shifted by 22.5 centimeter. Isn't it? And that is the only difference. Here resistance, when an unknown resistor is connected with a 3 ohm resistor. That's only. Okay. Same arrangement of problem. Now, next, resistor of 100 ohms each are connected in series with 9-volt battery, and the voltmeter of 400 ohms is connected to measure the voltage. Look, this is the arrangement we have made. Both are 100 ohms. This is 9 volt. Now, if it is an ideal voltmeter is supposed to be of infinite resistance. So, if in ideal volt, instead of this 400 ohm voltmeter, if I connect an ideal voltmeter of very high resistance in comparison with 100, we can find that the total voltage will be divided in the ratio of what? The resistances. Both are equal resistances. Therefore, your answer will be 4.5 volt. If it were an ideal voltmeter, means its resistance should be very, very high in comparison with the resistance across which the voltmeter is coming. But here, comparing with the 100 ohm, this is not very high, only 400 ohms. So now we have to find out how much effective resistance for the voltmeter combination, that is R equivalent. And R equivalent is coming to be 400 and 100 are connected parallelly. Effective resistance is given by 100 into 400 plus 100 plus 400, that is 80 ohms. Now, I'm going to make a third diagram in which after connecting voltmeter, this is 9 volt, after connecting voltmeter, R effective, considering the resistance of voltmeter, R effective is coming to be 80 ohms and this is still 100 ohms. We have to calculate the voltmeter reading. Voltmeter reading is potential difference across R effective, and in series combination of resistances, potential difference will be in the ratio of resistances. Therefore, we can find that the voltmeter reading will be total 9 into, what is the ratio of resistance? First I will write ratio of resistances. What resistance? R effective and 100. Ratio of resistances. Is equal to 80 is to 100. That comes to be 4 is to 5. So, the total 9 volt will be divided in the ratio of resistance. Ratio of resistance is what? 4 is to 5. Therefore, what will be the potential difference across voltmeter? Will be total 9 volt into 4 divided by 4 plus 5. That is 9 into 4 by 9. That comes to be 4 volt. So that will be the easy. We can, in mind, we can work it out. One more method is given here. They calculated the current and current into resistance they calculated. But this is easiest one because after connecting voltmeter, that's effective resistance has become 80 ohms. 80 ohms and 100 ohms are connected in series. In series connection, potential difference will be divided in the ratio of the resistance. 80 is to 100, 4 is to 5. Total 9 volt is to be divided in the ratio 4 is to 5. That comes to be that. Next question, very direct question. We know in comparison of EMF due to potentiometer, E1 by E2 is equal to L1 by L2. Then using the principle of error calculation in division, error in delta R by R is delta L1 by L1 plus delta L2 by L2. Delta L1, that is the least count of the scale, that is 1 centimeter. Therefore, delta L1 will be 1 and length measured is how much? 200, yes. Second, same scale we are using, again delta L2 in second case will be 1, but length measured is 150. Then using the principle of so this is coming to be 7 by 600. Then percentage error is 7 by 600 into 100. That comes to be how much? That comes to be 1.17 percentage. 1.17 percentage. In the options, it is coming to be second option. Okay. Very simple question, direct question. Next one. Now tell me here, resistance per length is given by lambda ohms per meter. And we have to calculate the effective resistance between A and B. We have three segments. One is, I call it as this one. ACB segment, AOB segment, and ADB segment. We have to calculate the equivalent resistance between A and B. So we have three branches. First are resistance of ACB branch, resistance of AOB branch, resistance of ADB branch. Resistance is proportional to length. So here it is mentioned AB means AOB branch. That is coming to be, its length is pi r by 2. Therefore, its resistance is coming to be pi r by 2 into lambda. pi r by 2 into lambda. Second one, ROB length is R plus R, 2R, 2R. So second segment resistance will be 2R, then it will be, that is R, they have taken 3, this third one. So I'll change the order, This is first one. Second one they have taken is RADB. RADB is, and third one is what? RAOB. AOB is 2R, it will be 2R lambda. And third one, how much length? Length is coming to be 3 pi R by 2. Therefore, its resistance is 3 pi R by 2 into lambda. So, RACB, RAOB and RADB, they are connected in parallel. Then, so you got everything clearly. R1 means that segment I told. R2 is second segment and R3 is third segment. 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. And solving, we are getting R equivalent is equal to 6 pi lambda R divided by 3 pi plus 16. Answer option given is C. Okay, we go to the next question. Here, a cylindrical cubical conductor of length L, area of cross section, carries a current, and when ends are connected to 2-volt battery, mobility of electrons is given by alpha in 10 to the power of -3. We have to find the value of alpha. Now look, there's a problem of mobility involved. Two ideas are to be mixed together. One, mobility is given by drift velocity by E. So instead of drift velocity, we can write mu into E. That is one problem. Then second one, electric field is given by V by L. Therefore, instead of drift velocity, what you can write? Mu into V by L. And second thing we are using is what? Current is given by NEAVD. NE, so I'll write here I is equal to NAVD into E. NEA, instead of drift velocity, we are substituted from here. Okay? Therefore, this is the equation. From this equation, we have to pull out the value of mu. So, mu is equal to IL divided by NE by V. From here, we come here. Then substituting. I given, current given, length given, current density is given as this. Charge of electron we know. Then area of cross section is 0.2 millimeter is given as this. And into what? V. V is 2 volt. So, solving this, we are getting 1 into 10 to the power of -3 meters square per volt, and here it is given to be alpha into 1.3. So this makes alpha is equal to 1. Okay. We go to the next question. Now, electric power line having a total resistance of 2 ohms delivers. Now tell me the output power, that is the power available. How much power available we are giving, because our task is the power output. We have to transmit a power of how much? 1 kilowatt, that is 1000 watts, that is given. That is our output. Now, EMF is 250 volt. Then I will be power output by voltage, that is 1000 by 250. The current to the circuit is 4 ampere. Then power wasted will be I squared R, that is how much? 32 watts. So in transmission, power wasted is given by I squared into R, that is 32 watts. How much power is reaching our destination? That is 1000. And that we call output. And during this transmission, how much wasted? That we calculated as I squared into R. Power wasted is I squared into R. That is series resistance of the cable. That is coming to be 32. Then Input power is output power per power loss, that is given to be 1000 plus 32, that is 1032. Now, any efficiency is given by power output, power input into 100, that's percentage output, that is coming to be nearly 96.9% output. Now come to the next question. Tell me, a meter bridge resistance R1 and R2 as shown in the figure. Null point is P, null point is change. Same problem we have done question number 5 and question number 7, question number 13. All are same arrangement, only differences. In question number 10, what we have done, the balancing length is shifted by 10. Second case, balancing length is 20, shifted by 22.2. Here, when 16 ohm resistance is connected parallel to R2, so balancing length is shifted to what point? 50 centimeters. Same arrangement, same calculation. So we can follow the steps. First case R1 by R2 is coming to be, R1 is 2 by 3 R2 from the first case. Now, new equivalent resistance we call R2 dash. R2 dash is R2 and 16 parallel. This is R2 dash. Now, new balancing length is what? 50. 50 by 50, that is 1. Therefore, R1 is equal to R2 dash, isn't it? Then, on solving, we are getting the value of R1 is equal to 2 by 3 R, and this is 16 by 3 ohms. That is 16 by 3 ohms, and R2 is coming to be 8 ohms, and R1 is coming to be 16 by 3. Same arrangement. Next one, total length of a potentiometer wire AB is 50 centimeter. Arrangement that's shown in the figure. P is a point where the galvanometer shows. So this important point, galvanometer shows zero deflection. That means this, I make the point here, it is C and P. Therefore, potential difference across C and P is 0. Potential difference across C and P is equal to 0. So this is, even though we are using a potentiometer wire, we are using as a potentiometer wire, but this works like a balanced Wheatstone bridge. This works like balanced Wheatstone bridge. So what you can write, 6 by 4 is equal to AP divided by P. Because it shows, galvanometer shows zero deflection, no current through the galvanometer. So even though we are using a potentiometer wire, a resistance wire, arrangement works like a galvanometer. What do you have to calculate here? We have to find the length AP. 6 by 4 is equal to AP by PB. What is PB? PB is, this is how many centimeter? 50 centimeter long. AB is 50 centimeter long. Therefore, AP by PB will be 50 by AP. Okay. Total length is not, this is not a meter bridge wire. I told you, potentiometer wire works like a meter bridge wire. So it will be 50 centimeter length only. So this is coming to be 3 by 2 is equal to AP divided by 50 minus AP. Now it comes to be 150 minus 3 AP is equal to 2 AP. That means 150 is equal to 5 AP. Therefore, AP is coming to be 30 centimeter. Okay, AP is coming to be 30 centimeter. Now we go to the next question. Tell me, battery EMF E and N resistance R is connected across the resistance, then power consumption will be maximum. This is a very basic information. In any other arrangement like this, when a cell is connected to an external resistor, we are connecting a cell of EMF E and internal resistance R. When connected to an external resistance R, we can find that this is a very basic result. Everybody remembers it, isn't it? Maximum power available in the resistor. This is also called maximum power transfer theorem. Maximum power transfer theorem. According to maximum power transfer theorem, maximum power will be transmitted if capital R is equal to small r. So any proof is not required. It's very basic result under the name maximum power transfer theorem. So we don't need for any calculation. Okay, we go to the next question. Tell me here the known resistance of 6 ohms and 2 ohms, one unknown and resistance. Tell me equivalent resistance between the points A and B is very direct question. Look, 2R and X are connected in series. Equivalent resistance is also X. Therefore, tell me first 2R and X in series. That resistance I call R 2R plus X. Okay, 2R plus X and R are in parallel. So effective resistance will be R into 2R plus X divided by R plus 2R plus X, and equivalent resistance is coming to be X. So once again, upper branch, this upper branch, the whole resistance is coming to be 2R plus X. Lower, this combination's resistance is what? R into 2R plus X divided by R plus 2R plus X. And this is equal to X. So we'll solve it, cross multiplying, arranging, we are getting a quadratic equation, and solving the quadratic equation, we are getting value of X is equal to root 3 minus 1 into R. It's a very simple question. Next question, heat generated in 1 minute between the points A and B. Between the points A and B means heat generated in the network when a battery of 9 volt with internal resistance of 1 ohm is connected. First of all, very clear, it is a balanced Wheatstone bridge problem. In balanced Wheatstone bridge, no current passing through this 1 ohm resistance. We don't consider it. Therefore, 1 and 2 ohms are in threes. We'll be getting effective resistance of the combination is coming to be 2 ohms because 1 and 2 are in series 3, 2 and 4 are in series 6, 6 and 3 are in parallel. Effective resistance calculated would be 2 ohms. Now, what will be the current drawn? EMF divided by effective resistance plus internal resistance. EMF is 9 volt, effective resistance is 2 ohms, internal resistance is given to be 1 ohm, total resistance will be 3, current will be 3 ampere. Then heat generated will be, heat generator is I squared into R, that's power into time. Effective resistance of the combination that we got to be how many? In the combination effective resistance is coming to, that is 2 ohms, but current is given to be 3 ampere. Then power will be 3 square into 2, and we want to calculate the heat liberated for 1 minute. Therefore, we have to calculate the power multiplied by time. That comes to be 1080 joules. Okay, that's all about the questions. So, next time onwards, we will be bringing the explanation on the board. So, you don't waste much time in watching this videos. So, you can save time. But you should understand very clearly how we are explaining along with the questions answered on the board. We are giving proper explanation with the help of these two. You can save time and you get clear idea about it. Okay? By the student. Bye. Decreasing inversely is rectangular hyperbola. Therefore, field is maximum on the surface as told by the equation as well as told by the graph. Your answer is coming to be what? Options is coming to be second option, that is becomes paramagnetic. Okay, so in that point of view, at higher temperature, preferably above Curie temperature, ferromagnetic feature will be lost. They lose domain feature. So that statement is also correct. Both the fields are in what direction? Both the fields are in same direction. Therefore, opposite direction. One is towards P, other is towards Q. We have to calculate net. Net will be 3 mu 0 I 4 root 2 R Good morning, all of you. In today's discussion, we included 3 chapters. The questions asked in JEE Mains 2026 January session. The chapters included are magnetic effect of current, magnetism, and electromagnetic induction. Okay? Listen. Now, question number 1. A long cylindrical large cross-section carries electric current distributed uniformly over its cross-section. Magnetic field due to this current. Listen, so I told you yesterday that to make our explanations of taking less time, the explanations are coming on the board. Explanations are given. I just explain it, that's all. Look, magnetic field due to a thick conductor. Thin conductor, you know, mu 0 I by 2 pi r. This is a thick conductor. We have 3 cases. At any point inside, mu 0 I r by 2 pi r squared. So in first one, we can say that magnetic field inside is proportional to r, linearly varying with r. This makes that the magnetic field is 0 on the axis because r is equal to 0. R is equal to 0 on the axis, magnetic field is 0. Then we come to the surface, it will be mu 0 I by 2 pi r, because better to say capital R, because capital R is equal to small r is equal to capital R. And for any point, this is outside current. Outside point, it is inversely proportional to R. Okay, and at surface, small r is equal to capital R. Therefore, B on surface will be mu 0 I by 2 pi r. Okay, and it can be even given in a better manner if you draw a graph of it. Magnetic field on y-axis, radial distance from axis on x-axis. This is periphery, r is equal to r. Inside field varies linearly. Outside field is decreasing inversely. It's rectangular hyperbola. Therefore, field is maximum on the surface as told by the equation as well as told by the graph. Your answer is coming to be what? Options is coming to be second option. That is correct answer is D only, minimum on the axis. That is correctly 0 on the axis. Now we come into the next question. Tell me, magnetic field at the center of a current carrying circular loop is R, 16 microtesla. Then magnetic field at a distance. So we have a ready-made formula, we are using it. Again, come to the explanation. You know, at the center of circular coil, mu 0 I by 2 pi r, and at any point on the axis, distant x is this. We have to put x is equal to root 3 by r. When you substituting it, we are getting the value on the axis is equal to mu 0 I by 16 r. Or, you know, on surface it is what? Mu 0 I by 2 r. This is 1 by 8 into mu 0 by 2 r. 1 by 8 into field at the center, 16 by 8. That is equal to 2 microtesla. Answer is 3. Okay? Answer is 3. Now, it is better for you to remember, you make a relation. What relation you are making? B at any point on the axis. I'm going to write it as, look the formula, mu 0 I capital R squared divided by 2 into R squared plus X squared whole to the power of 3 by 2. You can do one thing. You can pull out R squared out of the bracket. So it is coming to be mu 0 I capital R squared into R squared will come out of the bracket as R cube 1 plus x square by R square whole to the power of 3 by 2. And simplifying, mu 0 I by 2R will come, mu 0 I by 2R. And what is mu 0 I by 2R? Mu 0 I 1 R squared get cancelled, R cube there, it will be mu 0 I by 2R, that is B at the center divided by 1 plus x square by R square whole to the power of 3 by 2. If you can remember this formula, it will be very convenient for you. Once again, magnetic field at any point on the axis is equal to magnetic field at the center of circular coil divided by 1 plus x square by R square whole to the power of 3 by 2. Here x square is root 3R. So root 3 square will be 3R squared, isn't it? Therefore, this will be 1 plus 3, 1 plus 3, 4. 4 to the power of 3 by 2. 4 to the power of 3 by 2 means root of 4 cube, root of 64. That is coming to be BC by 8. BC by 8. So your answer is, how much it is coming? 16, BC 16 microtesla, 16 by 8 it will be 2. You can get the answer in a further easy manner. Okay. Now come to the question. Here I'm not going to the explanation. Explanation is not given with mathematical support in the question. We can do it. Now tell me P and Q, separation between them. Force per length or force between any two current carrying conductors is given by mu 0 I1 I2 2 pi R into length under consideration. Now force between P and Q, currents are in opposite direction. The force will be a repulsion. Force will be repulsion. Force is given by mu 0 is 4 pi into 10 to the power of minus 7 into 1, 3 into 1 into 3 into 1. I1 is 3, I2 is 10 to the power of minus 7. 3 into 1 divided by 2 pi. R is 3 centimeter. And you know, in numerator there is an L coming. If L and R are taken in same unit, that doesn't make any change in the actual value. So don't convert it into meter. The separation R I am taking in centimeter, length also I can take in centimeter. So I take 15. Now this get cancelled. Now tell me, this 3 get cancelled. What is left over? Force will be 3 into 10 to the power of minus 6. And this is repulsion. So this will be towards, force will be repulsion means towards the side of Q. Or towards R. That is towards Q means towards R. Because on the other side there's 2 because we have given in terms of R. R and P. So better towards R. Okay. Force between P and Q. Similarly, force between Q and R. Same manner, 4 pi into 10 to the power of minus 7 into 1 into 2 divided by 2 into 15. That comes to be same result, isn't it? This 2 get cancelled. This is 15. 2 pi into 2. Separation is 2. 2 pi, 4 pi get cancelled. Again, this is also coming to be 3 into 10 to the power of minus 6 Tesla. Here both are in same direction. Current is again attraction. So force on Q by R, that is an attraction. That will be also towards R. Okay. Attraction means I am talking about the force on Q. First case, force on Q by P was repulsion. P will push the Q away from it, that is towards R. Second case, current in Q and R are in same direction, they will attract. So when I'm talking about Q, Q will be attracted by R, force will be towards R. So both the forces are equal in magnitude. How much? 3 into 10 to the power of minus 6 Tesla, and both are towards R. The total will be 3 plus 3, 6 into 10 to the power of minus 12 Newton, minus 6 Newton towards R. Okay? So that will be the better explanation. Okay? Yes. So they are given just formula only, they didn't go for the calculation part. Now we go to the question number 4. Two identical circular coils carrying current, and one thing, a person looking from O, current in P is clockwise, similarly current in Q also clockwise. Okay, that is further I am telling. Current in P is I and current in Q is 4I. Looking from O, currents are in clockwise direction. Now, better to go to the explanations, we can save time. Now, we have seen that formula for force, we have already told, mu 0 IR squared. Yes, separation between them is given to be R. So, force is coming to be mu 0 I 4 2R. Isn't it? 4 2R. And, you know, as far as point O is considered, from looking from point O, the current is in clockwise, magnetic field is getting into it, that is towards P, that I am marking here. Magnetic field, because looking from O, current in Q is clockwise, and when you calculate it, instead of small r we are putting, instead of x we are putting small r, that comes to be mu 0 I by 4 root 2R, and this is towards P. Now, same explanation here, it will be again looking into it, magnetic field is getting into the coil Q, that field is towards right, that is towards the direction of Q. These are the direction. Now, only one thing, in second coil, in the coil Q, only one difference is that current in coil P was I, current in coil Q is 4I. Only difference is that current, others are same, distance is same, everything is same. So, two aspects. One, current looking from O is clockwise, magnetic field is getting into the coil Q, that will be towards right, that is towards Q, number one. Number two, current is 4 times, so the field will be 4 times 4 mu 0 I by 2R. Now, both the fields are in what direction? Both the fields are in same direction. Therefore, opposite direction. One is towards P, other is towards Q. We have to calculate net. Net will be 3 mu 0 I 4 root 2R, and that is towards Q, because field due to Q is more in magnitude, because current is more. So, answer is coming to be 3 mu 0 I 4 root 2R. So, again, second problem coming based upon the magnetic field acting on the axis of a coil. But here, one thing, not only remembering the formula, one more aspect was very important here. What aspect was very important here? The important here it is that direction of current flow. Here we are using the clock rule. From O, looking into the coil P, current is clockwise, magnetic field is getting into it, that is towards P. But second case, current magnetic field is towards Q, and it is 4 times bigger. Then when I take the net field, I have to take the difference of it, Q will be dominating, and that comes to be 3 mu 0 I by 4 root 2R. Then answer is coming to be first one. We go to the next question. Look, a moving coil galvanometer of resistance 100 ohms, full scale deflection. Yes, again, they are regularly maintaining the question based upon ammeter and voltmeter. Look here, let us go to the explanation, that will be better saving time. You know, here full deflection current is 1 milliampere. We call it by the name IG. IG is 1 milliampere. Okay. IG is 1 milliampere. Correct? Yes. Now we have to read up to how much current? 5 milliampere. So if 5 milliampere current is coming, better I draw a diagram. This is the shunt resistance. This is galvanometer resistance. Galvanometer resistance is given to be how many? Is 100 ohms. And full deflection current permitted is 1 milliampere. Current coming is 5 milliampere. Therefore, current should be bypassed through the shunt will be 4 milliampere. And in galvanometer converting ammeter problems, we don't remember any special formula. Only one thing we have to remember, shunt and galvanometer are in parallel. So potential difference across shunt is equal to potential difference across galvanometer. Potential difference across galvanometer is Ig, Rg. Potential difference across shunt is I minus Ig. That we know Ig is 1, Rg is 100, and 1 into 100 is equal to 4 into S. S is coming to be 25 ohms, and the answer is coming to be 3. Answer is coming to be 3. Yes. Now, come to the next question. Next question. Come on. A short magnet is placed at an angle 30 degree with external field of 800 Gauss. Experiences a torque of 0.036 Newton meter. Work done in moving it from most stable state to most unstable state. Okay, we can go to the explanation. It is clearly given to you. Yes, look, the torque experienced by the magnetic dipole formula is mb sine theta, and that is given to be 0.016 Newton, and 0.016 is mb sine 30. We are getting mb as 0.032 joules. From this calculation, sine 30 is half, 0.5, you will be getting mb as 0.03. So here we don't require magnetic field value and you don't require magnetic moment value because you are directly getting mb. mb we got it as 0.032. Now work done in this is a ready-made formula. Actually, instead of this much explanation, there is a ready-made formula. Work done in rotating a dipole from what is mentioned here, most stable position, that is an equilibrium position, to most unstable state, it is in 180 degree. There is a ready-made formula, mb into cos theta 1 minus cos theta 2. Cos theta 1 is cos 01, cos theta 2 is 180, cos 180 is minus 1. So minus or minus will become what? 2. It will be 2 mb. 2 mb. Answer will be 2 mb, isn't it? And 2 mb is given to be how much? 60.064 is the value of mb. So it will be 2 into 0.032. That is coming to be 0.064. 64 into 10 to the power of minus 3 joules. Your question is alpha into 10 to the power of minus 3 joules. So is coming in place of alpha. 64 is coming. Here they have taken, here I have written same thing, no difference at all. Here they have taken the minus sign inside. So minus or minus will become plus. So it will become, this is a ready-made formula everybody remembers. From most stable state to unstable state, work done is, or another explanation I can give, the magnet is already in what position? Equilibrium position. It is turned through 180 degree. That is also basic formula to remember. The work done is given by 2 mb. 2 mb, that is the basic result. Or we can remember the formula mb into cos theta 1 minus cos theta 2. Theta 1 is initial position, theta 2 is initial position. We go to the next question. Come on. A current passing loop is contained in the form of an equilateral triangle of side 4√3 centimeter. Side is given to you 4√3 centimeter and current is 2 ampere. Magnetic field at the centroid is. This is a very common. Many even remember the answer. Many even remember the answer. So better you to derive it out now, or if you are good enough in memorizing, it will be very good. Equilateral triangle center point, what will be the magnetic field? Look, what explanation we are giving. We go to the explanation for doing of this thing. It will be, look, equilateral triangle side, you know, magnetic field due to a one finite conductor, this is equilateral triangle, due to one side, this distance we call d here, and this is distance from side to the centroid of an equilateral triangle. There is a ready-made formula, d is a by 2 root 3. A is the side of the equilateral triangle. Side of equilateral triangle is given to be 4 root 3. This is 4 root 3 by 2 root 3. That is 2 centimeter or 0.02 meter. Then formula is given by mu 0 I by d for sine 60, because equilateral triangle to the center, these angles are phi. This is phi 1, this is phi 2. And this separation is, I will draw it in a bigger one. This is an equilateral triangle. We want to find the field at the centroid. Oh, yes. This is the perpendicular distance. This is d. This is 60 degree. This is 60 degree. And dB worked out to be how much? 0.02 meter. Then what is the formula? Mu 0 I by 4 pi d sine 60 plus sine 60. This comes to be 10 to the power of minus 5 into root 3. And better to remember, yes, very good, due to one segment. And you know, we have to get the contribution of 3 segments. Don't verify whether field due to different segments are adding up or whatever happening, and make it into a point. If you take a point inside a loop, inside a current carrying loop, magnetic field due to the all the parts of the that loop will be in same direction. Either equilateral triangle, square, whatever it may be, within a point, field contribution due to each segment will be added up. And here all the segments are symmetric, all of same length. How much? 4 root 3. So magnetic field due to each segment will be same. Total field will be 3 times B1, that is 3 root 3 into 10 to the power of minus Tesla. And question it is asked that it is mu 0. Question is alpha into 10 to the power of minus 3. So who is in place of alpha? 3 root 3. 3 root 3 in place of alpha. Your answer is second in the option. Okay. We go to the next question regarding the 2 statements. First statement, you can go to the explanation. Explanation. Look, you know, consider a ferromagnetic material. Assertion says individual atoms in the ferromagnetic material possesses magnetic dipole moment and interact with one another in such a way that spontaneously align themselves, forming domains. So, you know, this is a reason for domain formation. The ferromagnetic atoms have 2 and more unpaired electrons, or iron has got 4 unpaired electrons. As a result, magnetic moment of each ferromagnetic atom is much more than magnetic moment of a paramagnetic atom due to the presence of more number of unpaired electrons. And as each individual atom has more magnetic moment, they make their own treaty among them. They make some adjustment, and few of the atoms align in the same direction, forming a region of very large magnetic moment called as domain. In a ferromagnetic atom, a domain contains near about 10 to the power of 11 atoms. 10 to the power of 11 atoms are there. Means region of domain has got very large magnetic moment. And this is responsible for very large magnetic properties of ferromagnetic materials, high permeability. That is the assertion. Then what is the second statement? At high temperature, as temperature increases, the atoms in domains are looped up, And when temperature becomes above a temperature called Curie temperature, what happens? This domain feature will be lost. Domain feature will be lost. As a result, it will be losing almost not fully, almost all its magnetic property, because it becomes paramagnetic. Okay. So, in that point of view, at higher temperature, preferably above Curie temperature, ferromagnetic feature will be lost. They lose domain feature. So that statement is also correct. But one thing, it is not supporting what the first statement. First statement is telling that it has how an ferromagnetic material possesses high magnetic permeability. It explains how domain formation takes place. That's correct statement. But second statement is not supporting why it is gaining magnet. It is not supporting that. It is telling something else. That is, it may lose domain feature. That aspect is telling. It is not in tune with explaining the first assertion, first statement. So, assertion correct, reason correct, and it is not supporting, that is statement. Option 1 is correct one. We go to the next one. Look here, diagram is complete. Look here, a current carrying loop with a small discontinuity, and is it answer? Yes, answer part has got a diagram. Look, tell me, we have to calculate the magnetic field at O, at the center of magnetic field, at the center of what? The O, center O. Now tell me, magnetic field at the center is caused by this straight wire, long straight wire. Almost we can treat like an infinite long wire. At a point distant R, then, directions are given. Exact y-axis is along, y and z-axis is in the plane of the loop, and x-axis is getting out of it, getting out of the plane of the loop. X-axis is getting out of the plane of the loop. Now, due to the straight portion, first field, that is due to straight portion, I say B1, B straight portion, that is mu 0 I divided by due to straight portion, mu 0 I divided by 2R, and using this is getting out of what? Getting out of the magnetic field region. Getting out means along positive x direction. Okay, B1, mu 0 I by 2 pi R, sorry. Straight portion, mu 0 I by 2 pi R. Mu 0 I divided by 2 pi R. Getting out of the plane of the paper means along positive direction. Now, second one, semicircular loop. Look, when you look into the loop, we are telling it third time. Looking into the loop, current is in clockwise direction. Magnetic field is getting into it, and magnetic field is along negative x direction. Therefore, B2 will be mu 0 I divided by 2R circular portion and along negative x-axis. And one thing is clear, B2 is greater than B1 because B2 contains no pi in the denominator. B1 contains an additional term, additional factor pi in that. So B2 is greater than. So who will be dominating? B2 will be dominating. Getting into field will be dominating. Therefore, resultant field can be given by what? Mu 0 minus mu 0 I by 2R due to the circular loop, and this is plus mu 0 I by what? So it is coming to be, I have taken out mu 0 I by 2 pi R common, pi minus 1I, because it is along negative, because minus is there. I have taken out minus mu 0 I by 2 pi r is taken out. Pi is left over here, pi minus 1. So the correct option will be mu 0 I by 2 pi r, pi minus 1, negative sign is indicating it is getting into the plane of the paper. So option will be 2 according to your calculation. We go to the next one. A current carrying solenoid is placed vertically of mass and charge Q is released from rest. Particle moves along the axis of the solenoid. Note down it. Now, you know, if due to the coming of the particle, if there is some magnetic force acting on it, it will not be having a free fall. It will not be having a free fall. So acceleration will not be G. Let us go to the explanation part, is very clearly given. Look, so magnetic field inside solenoid is along the axis. A charged particle is also released. It is moves down along the axis. As a result, no magnetic force Q is equal to V cross B. V and B are along the axis. V and B are in same direction. Therefore, net force on the charged particle will be 0. So due to the magnetic process, since the charged particle is coming along the axis, coming along the direction of magnetic field produced by the solenoid, there will be any magnetic force acting on it. So it is still have a free fall. So its acceleration will be how much? G only. G only. So in the your options you can see in the paper. No. What is asked? Yes, options are there. Acceleration is G. That is second one. 2 ampere current is reaching at A. 2 ampere current is reaching at A. Now I told you there are two branches. One is ACD branch. One another is AB branch directly. Both ACD branch and AB branch are having same resistance. So as it comes down, its velocity will increase. Now go to the explanation part quickly. We have, velocity of a body coming down is given by current is in clockwise direction. So if somebody looking from O1 will find that there is a south pole here. Somebody looking on C1 from the center O2, current is in anti-clockwise direction. We come to the next question. This question is coming from electromagnetic induction and related paper. Okay, come on. Now, yes, there is a circuit given to you. Circuit contains inductor, capacitor, no inductor is there. Now, here source of EMF, there is a network. We have a clear explanation. Let's go to this step. Now, here source is a DC source. And when a DC source is introduced in the network, inductor behaves as a what? Perfect conductor. At steady state we're talking about is exactly steady state, inductor behaves exactly as a what? Connecting wire. It doesn't offer any resistance. It is open, what we can say, not open circuit, as a short circuit, because no resistance, zero resistance, correct. But as far as capacitor is considered, capacitor offers infinite resistance. Or in other words, at steady state, in a branch, a capacitor is coming, capacitor will not permit any current, and there will be no current passing through the branch in which who is coming, capacitor is coming. No current passing through the branch in which a capacitor is coming. Now tell me, look, current will pass through this, current will be distributed. So these two 8 ohms are in parallel, effective will be 4, 4 and 4 will be in series, that will be 8. So this section between these sections, I can say, if I say A, B, C, D. Between A, C, D, no current passing through the branch D, I can say. So these two will be in parallel, 4 ohms, 4 and 4 are what? So in the ACD branch, effective resistance is 8 ohms. Then directly AB branch, directly 8 ohms. So what is effective resistance? 8 and 8 parallel. So net effective resistance of the combination will be 8 and 8 parallel for 4 plus 1, that is 5 ohm resistance. The whole network of resistance, effective resistance will be what? 5 ohms. Therefore, main current, I say main current will be EMF is 10, effective resistance is what? 2 ampere current. 2 ampere current is reaching at A. 2 ampere current is reaching at A. Now I told you there are two branches. One is ACD branch, one another is AB branch directly. Both ACD branch and AB branch are having same resistance. So what will be happening? Current will be equally how much entering at A? 2 ampere. So 1 ampere will be passing through this and 1 ampere will be passing through this branch. So tell me, the current coming through the ACD branch will also pass through the ammeter. So current through ammeter will be 1 ampere. So your answer is 1 ampere, option 1. We go to the next question. Look, a long solenoid 100 centimeter long of radius 2 centimeter having 500 turns carries a current 100 omega is 100 circular conducting loop of radius 1 centimeter coaxially glided through the solenoid at a speed of 1 meter centimeter. The RMS current in the loop when the coil is inserted 10 centimeter inside it is alpha by root 2 microampere. We have to find the value of alpha. We go to the explanation. Tell me, magnetic field inside solenoid, you know B0 is equal to B0 Ni, correct? That is coming to be 5,000 because number of turns you have to calculate. Number of turns per N will be is equal to number of turns per unit length. How many turns you are having? 500. Per how many length? 1 meter. So this is 500. 500 by 1, 500. N 500, 10 sin omega t. That is 5,000 mu0 sin omega t. Now, flux linked will be, in the coil will be 5,000 sin omega t into area, pi into 0.01, we got it. 0.5 pi mu0 sin omega t. Then induced EMF is minus d sin omega t minus 5 mu0 omega cos omega t. Got it? Differentiating simple. It will be multiplied with omega, isn't it? It will become cos omega t. And peak value of amplitude of EMF is what? Mu0 pi, that is 0.5 pi. Mu0's value is substituted into what? Into omega. Omega is coming to be, which omega's value 1000. Got it? So this is coming to be 19.7 into 10 to the power of minus 4 volt. Then current, RMS value of current will be, RMS value of voltage will be E0 by root 2. Then RMS current will be ERMS divided by resistance. Resistance is given in the last just 10 ohms. This is 19.C 10 to the power of minus 3 into 10 root 2. That is coming to be 197 by root 2 microampere. And it is given that the RMS value of current is given by alpha divided by root 2 microampere. Alpha divided by root 2 microampere. And here we got 197 by root 2 microampere. So who is in place of that alpha? 197. In your question option, I will go to the question to make it clear. Yes, 197 is the B option. Correct. Now coming to the next question. Now, circular loop of radius ends place in a uniform magnetic field directed perpendicular to the loop. The loop is converted into a square loop. EMF induced. Tell me, we can go to the explanations. Again, it is everything is clear in black and white. Now tell me here, what is the reason for the change of flux? The reason for change of flux is change of area, because flux linked is given by BA cos theta. Flux may change Either B changes or A changes or orientation changes. Here area is changing. What is the reason for area change? Reason for area change is it changes from a circular loop to a square loop. Now radius is given to be how much? 7 centimeter means 0.07. Area, initial area is given by pi r square 22 by 7 into 0.07. That comes to be, when you work it out, 0.0154 in meter square. Okay. Now when you come into the square loop, first you have to get the side of the square. The circumference of a circle, circular loop of perimeter 2 pi r is changed into a square loop of perimeter 4a. Circular loop of perimeter 2 pi r changed into a square loop of perimeter 4a. So what we have done, we have equated it to find that is A is equal to 2 pi r. 2 pi r is coming to be 0.44 divided by 4, that is 0.11 meter. We got the side. Then area is equal to A square, 0.1 square, that is in meter square, it is coming to be 0.01 into 2 meter square. Then it was 0.0154 meter squared. Now it is 0.0121 meter squared. So there is a change in magnetic flux. What is that? B into change in area. B we got it as given to be how much? 0.2. So 0.2 into change of area. Change of area is coming to be 0.0033. That is 0.0066 Weber. Then induced EMF is change of flux by time, 0.00066 by 0.5. That is 0.00132 volt. That is coming to be 1.32 millivolt. 1.3. That is induced EMF is given by 1.32 millivolt. Now go to the options. Options. No, we have to fill up the blanks. Here in the bracket we have to write how many? 132 millivolt. 132 millivolt. Okay. Yes, 132 millivolt is there. Okay. Yes. Next question. Pendulum is made up of mass 10 gram and metallic wire of length 10 centimeter suspended vertically in uniform magnetic field. Magnetic field direction is perpendicular to the plane of the loop. Oscillations of the pendulum. Pendulum is released from an angle. So I'll draw a diagram here. Better here. Yes. This is the initial position of the pendulum, making an angle 60 degree. The pendulum will keep a circular path, and this is equilibrium position. At equilibrium position, when it reaches its tangential speed is maximum. Tangential speed is maximum. Okay. Then when you get tangential speed, okay. Now let us calculate the tangential speed. How are you going to calculate the tangential speed? From this diagram, we can find that the pendulum has come down through a depth h. And we have ready-made formula for the depth h came down is, here it is given, length of the pendulum in 1 minus cos 60, that is 1 minus 0.5, that is coming to be, this is the depth it came down. And here it has got potential energy, is converted into kinetic energy, velocity maximum at the equilibrium position now is root 2gh, that is coming to be 1 meter per second. Okay, so when pendulum bob reaches the equilibrium position, many occasions we are doing this conversion. Pendulum's height is L into 1 minus cos theta. Height it has been converted into kinetic energy, that is velocity is given by 1 meter per second. Now, you know, velocity of the pendulum string at different points will be what? Different. Maximum at the bottommost point and when it reaches equilibrium position. But you know, at any point on the pendulum string, what will be happening? Angular speed is same. Angular speed is same. So, angular speed at the bottom is same as that of angular speed everywhere. Angular speed, how we calculate? Maximum by length, 1 by 0.1, 10 radians per second. Because length was 0.1, Pendulum's length is given to be how much? 10 centimeter means 0.1. And velocity, we got it as 10, therefore 1 meter per second, therefore we got it as 10 radians per second. Now, as it moving, there is a magnetic field getting into the plane of the magnetic field. In the case of a rod rotating about one end, that is magnetic field, magnetic EMF induced is given by half B omega L square, and half into B is given to be how much? 2 Tesla, omega we got 10, L square is 0.01, 2 get cancelled, this is coming to be 0.1 volt or 100 millivolt. So fill up the blanks, answer here it is, fill up the, yes, option is, it is coming to be how much? We got 100 millivolt. So answer is coming to be, what you have to calculate when it reaches induced EMF after distance of, okay, options, let me check the question paper. This is correct. We have to fill up the blanks only, no options given. This is coming to be 100 millivolt, 100 millivolt. That's correct. Next question, this is another question. 20 meter long uniform copper wire is held horizontally, allowed to fall under gravity. Then magnetic field of 0.55 goes perpendicular to the length of the wire. Induced EMF across the wire when it travels a vertical distance. So as it comes down, its velocity will increase. Now go to the explanation part quickly. We have, velocity of a body coming down is given by root 2gh. That is, it has come down by 200 meters. That is coming to be root of 4,000. That is 20 root meter per second. And this is a BLV problem. Induced EMF across the rod is given by what? BLV. B is 0.1 Gauss. 1 Gauss means 10 to the power of minus 4. So this is coming to be 0.5 into 10 to the power of minus Tesla. Induced EMF is equal to BLV. B is 0.5, 10 to the power of length is how many? Velocity is 20 root 10. Length of the rod is 20. That comes to be 20. When you work it out, this is coming to be 20 into root 10 millivolt. 20 into root 2 millivolt. So this is ordinary. But here it is that as it comes down, speed is increasing. The potential difference across the rod will be increasing. Here it is asked at the moment when it has come down. So we should get velocity at that instant. Your answer is coming according to the question paper is 20 root 2 millivolt. Yes, we go to the next question. And a conducting circular loop is placed about a diameter at a constant angular speed of 100 radians per second in the magnetic field perpendicular to it. When the loop is rotated through an angle 30 degree from the horizontal position, induced EMF will be, okay. Then let us go to the question directly. We can go to the question directly. Yes. Come on. Flux in the coil rotating, we have to think that how we are rotating the coil. We are rotating the coil like this. I think you can see that, rotating the coil. So there are some occasions the plane of the coil will be perpendicular to it, flux linked will be maximum. Some occasions plane of the coil will be parallel to that, flux linked will be 0. As a result, as you are rotating, the flux linked to the coil will be continuously changing, and this is the case of an AC generator happening. Now, let us equation for the flux at any moment. T is angle turned is coming to be omega t. Therefore, BA cos theta, P omega t. Induced EMF is given by BA omega sin omega t, because cos omega will become omega minus omega t minus get cancelled. Then when it is loop is turned through 30 degree, normal to the plane of the coil will also turn through 30 degree. Here we take in that manner, from initial position it is turned to 30 degree. So other option we don't require it. Then we will be getting what will be the induced EMF, that is B. B is given to be how much? 0.5 Tesla. B is coming to, induced EMF is 0.5 Tesla into 22/7 R squared into 100 into sine 30. Its value is given to be how much? 15.4 millivolt. This is already given 15.4. So this 15.5, 4 into 10 to the power of minus 3 can equate to 25 into 2277 by R squared. Simplifying, we are getting 550/7 R squared. Solving, value of R squared is given to be 196 into 10 to the power of, separate rule, we'll be getting 196 into 10 to the power of minus 3. Its root will be 14 into 10 to the power of minus 3, or 14 millimeter. Radius will be 14 millimeter. So very direct question, isn't it? Question of AC generator. We can directly use the formula for induced EMF is what? BAN sin omega t. We can also directly use it, BAN sin omega t, isn't it? Okay, then everything is given to you. Next figure contains 3 resistance, 9 ohms each, inductors 4 millihenry each. Reading of the ammeter, we have to calculate it. Okay, look again, when circuit is switched on, so we can go to the explanation, so you can get the idea. Immediately after circuit is switched on, that is at the instant t. I told you earlier, just after switching on, inductor offers infinite resistance. Just after switching on, inductor current is abruptly increasing in a short interval of time. That causes in very large infinite back EMF. It will offer infinite impedance to the current flow. So just after switching on, no current will pass through the inductor branch. So we can find inductor acts as an open circuit, means no current will be passing through it. It offers infinite resistance. No current flows through that branch. So no current flows through this branch just after switching on. No current will pass through this branch. So it has become a very simple branch. 9-volt source, ammeter, this 9 ohm resistance, and key is switched on in a simple circuit of how much EMF, 9 volt, how much current, how much resistance, 9 ohms, current will be 1 ampere. Just after switching off. And another possibility is that after a very long time, we say steady state is reached. That is not asked, but if it is asked, so what will be happening? Inductor will be acting like a conductor. It will offer no resistance. There will be a 9 ohm resistance here. Because after a very long time, this is asked just after switching on. But after a very long time, each inductor will have no role to play. It will conduct current like a conductor. So we will be getting 3 resistances in parallel. 9 ohm, 9 ohm, 9 ohm in parallel. Effective will be 3 ohms. Then current will be 3 ampere. When, if it is asked after a long time, but here it is asked just after switching on. Inductors will offer infinite resistance. Okay, answer is 1 ampere. We go to the next question. Tell me, inductor's coil of 10 to the power of turns 10 millihenry is connected to a source of EMF. Internal resistance of 10 ohms. Energy density in the inductor when the current becomes 1 by E of it. And here, you don't worry about the value of E. Answer is also given in terms of alpha pi into 1 by. You have to calculate the value of what? E, we have to calculate it. Isn't it? We have to find the value of that. Okay, come on. Now, we're going to go to the explanation. Look, first of all, it is a DC source. Okay? And we know in the inductor, there will be a magnetic field produced, and energy is, magnetic field is given by mu 0 and I, and energy density is given by B square by 2 mu 0. Okay? B is mu 0. So it will be coming to be, instead of B, I can substitute mu 0 and I. So mu 0 square, n square, I square, 1 mu 0 in the bottom get cancelled. You are getting what? Energy density we have to calculate is 1 by 2 mu 0 n square I square. N is number of turns per unit length. How much turns are there? 10 to the power of 4 turns. And length is how much? A coil of 10 to the power of turns, 10 Henry, is connected to DC source. Okay, 10 to the power of 4 turns, isn't it? So, this is coming to be, yes, 10 to the power of 4 turns. A coil with 10 to the power of turns is connected to DC source. So, one thing they are missing, they have to give number of turns per meter. Number of turns per meter should be given. Okay? Yes. So, it will be 10 to the power of 4 per meter. So, we got the value of this. Now, maximum current can flow, in a DC source connected to inductor. Maximum current means at steady state. At steady state, maximum current, who has no role to play? Inductor has no role to play. I told you at steady state, inductor will behave like it, resistive part will work. So the maximum current is possible, V by R. Resistance is coming to be how much? 10 ohm. 10 by 10, 1 ampere current. Is it so? And it is told that current has become I by E, or maximum by E. That is, I is 1 ampere, 1 by E. So we want to calculate what? The energy density corresponding to current is 1 by E, 1 by E. So what is the formula for it? Half mu 0 value 4 pi 10 to the power of minus 7, number of turns 10 to the power of 4 whole square into 1 by E whole square. This is coming to be 20 pi into 1 by E square. And question is given, this is given to be alpha pi into 1 by E square joule per meter square. Comparing 1 by E square, pi, who is in place of alpha? Alpha is coming to be 20. Alpha is coming to be 20. Okay. So here we don't require the value of B. 10 millihenry field is not required here. Isn't it? Okay. Come on. Because it is told to be inductance coil, we can take it as, it's not specifically mentioned, we can take it as an what coil? Circular coil. We have taken it like that. Now, there is a frame, vertical smooth long plane, resistance R, Px is parallel to Qi. These are parallel frames, these are parallel, so it is a rectangular frame, that's the meaning of it. And separation between them is L, and rod of length capital L, L is given to be greater than 5, is made to slide down. Now tell me, when it is sliding down, this is a case of what? BLV problem. BLV problem. And magnetic field, so I'll go to the explanation part, that will be better. That will be, explanation part will be better. Yes. Look, we can find that induced EMF will be BLV. Remember, length of the rod is capital L, but length of the rod within the frame, within the frame, what do you take? That is small L only. That is the separation between rods PX and PY. So note that length of the rod is given to be capital L, but whole L is not in the region of magnetic field, so it will be only small length, so BVL, correct? Now current through, because it's a conducting wire, current is given by BVL by R. And you know that when a current is passing, there will be a magnetic Lorentz force acting given by BAL, that is B square L square V by R. This much force will be acting on the rod. And you know, as it is coming down, who pulls it down? Mg is pulling it down. Mg is pulling it down. So as it comes down, Mg is pulling it down. Then force will be acting in upwards direction. So as it comes down, the force is given by B square L square R, B square L square V by R. B is constant, L is constant, R is constant. But as it comes down, it is coming down and down, speed increases, therefore force will be increasing. Force is acting in upward direction and Mg is pulling it down. So what will be happening? A stage will be reaching, net force on the rod will become zero. Just like we have studied in spherical object is coming down through a viscous liquid. When net force on the spherical object becomes zero, it attains a constant speed, terminal speed. It will maintain a steady speed further. After that, it will not be. Same case happening here. Here it is not due to viscous force. Here it is due to the two forces. One is magnetic force and the other is Mg. So what we can write, this B square VL square by R is equal to Mg, or V is coming to be Mgr divided by B square L square, and according to the question, Mgr by B square L square, and that is first option. Mgr by B square L square will be the velocity, isn't it? Next question. Look, C1, C2, C3 are closely placed such that they share common axis. C2 is exactly midway between. C1 carries a current I in anti-clockwise direction. C3 carries a current I in the clockwise direction. And induced current C2 will be in clockwise direction. I'm not going to the explanation part. I think it may be there, but that is not, I think, complete or not clear. So it is a better simple way we can explain it. Let me draw the diagram first. Look. So better I use the so they have common axis. And C1, C3, C2. Instead of mentioning by drawing the clockwise anti, better I write it. Current in, this is midway between point they told. Here it is anti-clockwise. Here it is clockwise. Induced one. This is already having, not induced one. Clockwise. Now, you know, if I looking from this point O, center of the middle one, current is in clockwise direction. So when you look into the coil, there is the clock rule, we say clock rule. When you look into the current is in clockwise direction, that magnetic field is getting into it. That side should be a south pole. And if it is in anti-clockwise direction, if you look into that, current is in anti-clockwise direction, that will be north pole. Okay. Now look, we look from O. This is center of this O, O2. This is O1. This is O3. When you look from O2, O2, better I write suffix. O1, O2. You know, current is in anti-clockwise direction, they told. So that side will be appearing as in north pole using clock rule because current is in anti-clockwise direction. Now, what is happening? Due to the current, varying current, what will be happening? An induced current is developed in C2. Induced current is in clockwise direction. So, if Q1, if somebody is looking from O1 to the coil C2, current is in what direction? Current is in clockwise direction. So, somebody looking from O1 will find that there is a south pole here. Somebody looking on C1 from the center O2, current is in anti-clockwise direction. The person at O2 will say that that side of the coil facing him will be a north pole. Now it is mentioned that due to the currents, there is an induced EMF, induced current developed in the C2. That current is in clockwise. So somebody looking from O1 into the coil C2, current is in clockwise direction. So he will feel that a south pole. Now go to the other side. Somebody looking from O3, looking into the coil, current is in clockwise. He will feel that that is a south pole. Similarly, somebody in O2 looking to the coil C3, current is in clockwise, again he will feel a south pole. So what we find, person at C3 looking at the coil 2, induced current is in clockwise, so he will feel a south pole facing him. Somebody at O2 looking at coil C3, current is in clockwise, he will find a south pole. Now look at the situation. For the persons at O1 and O2, one is north pole, another is south pole, they will be attracting. So, what is the reason for that? C1 will be moving towards C2 because north pole and south pole, C1 will be moving towards C2. As a result, what will be happening? The induced current is in clockwise direction. Come on. Now, looking here, C3 and C2. For C3 and C2, what do they find that? They find that the current, they are attracting each other. So, it means C3 will be moving towards C2. That causes current in the coil will be acting. They will be repelling each other. So C3 will be moving away from it. They are repelling each other. C3 will be moving because due to the development of induced current in C2, the in between C1 and C2, one side north pole, other side south pole, they will be attracting, moving towards each other. Between C2 and C3, both sides are south pole. What will be happening? That will be attracting, repelling each other. So this will be happening. C1 moves towards C2 and C3 moves away from C2. Next, that way explanation I have avoided. Come on, a conducting circular loop of area 1.3 is placed in a perpendicular magnetic field which varies. Alternating EMF is there, okay. The resistance of the loop is 100 ohms. Then average thermal energy dissipated in one period. Okay, let us go to the explanation. Explanation is clearly given. Now look, flux developed in the coil. How much? B into A. A is 100 sin omega t. That is sin 100 t. Induced EMF minus d phi by dt. Because it is varying current, varying field, flux is changing. That is minus 100 cos 100 t. Then instantaneous power is given by E squared by R. E squared by R will be 100 squared cos square 100 t divided by R is 100. 100 get cancelled, we are getting 100 cos square 100 t. That is instantaneous power. Then how to get average power? So I'll write that calculation of average power separately. Power instantaneous is given by 100 cos square 100 t. Average power, 100 is a constant, I will take it out. Average of cos square 100 t. In alternating current chapter, NCERT has introduced this idea of average power. If it is a sine function or cos function, averaging or one period will become 0. But cos square term, basically it is integration only, but for easy way of calculation, average power over sine square term will be half. So this will be half. Therefore, 100 into half, that comes to be 50 watts. Isn't it? Then average power is given by 50 watt. Now, time period is 2 pi by omega. Omega is given to be how much? Sine 100 t. Omega is 100. So pi by 5 seconds. And average power into time period will be the heat liberated. I have to calculate average heat liberated. That is average power into time. Time is one period. Average power we got is 50 watts. Average power is coming to be 50 watts. So it will be 50 into time is pi by 50. 50 get cancelled. It is coming to be pi joules. It is coming to be pi joules. So your answer is option 4. Option 4. Okay. Now we go to the last question, I think so. Look, diagram given. A 1 meter long wire AB completes a circuit that's on. There is a frame, complete circle. Area of perpendicular to the magnetic field is getting into it. Magnetic field, I will write here, is how much? 0.1 Tesla. Then the resistance of the circuit is 2 ohms. Whole network's resistance is coming to be 2 ohms. The force needed to move the rod is moving with the speed. V of the speed is 1.5 meter per second. Let us go to the explanation. We can easily get it. Options you keep in mind. Options you keep in mind. Yes. Look, tell me, this is the rod moving, BLV problem, induced EMF is BLV, and induced current is E by R, that is BLV by R, induced current. We have done it earlier. As a result, there will be a force acting on the rod, pulling it backwards. If you are pulling the rod towards right, there will be a force acting towards the left, and force is given by BIL. I is got it as BLV by R. Force is given to be B square V by L square. We are doing it second or third time. When a rod is moving, force is acting by B square V L square. Now, tell me, look, we are moving at a constant speed. So B is fixed, V is fixed, L is fixed, R is fixed. So it's a constant force will be developed on it. Constant force will be developed on it. Isn't it? Because who is pulling it back? This much force. So we have to, question is asked you, the force needed to, how much force pulling it back? Force pulling it back is B square V L square by R. So in order to maintain the steady speed, what we have to do is that we have to pull the rod with this force equal to B square V L square by R. So we can maintain it, isn't it? If force is more, speed will increase. Force is less, speed will decrease. Okay. Now you have to simply substitute B given to be 0.1, B square is L, sorry, V is 1.5, L is 1 meter. Simple calculation, this is coming to be 0.0075 or 7.5 into 10 to the power of minus 3 Tesla. Let us look into the option. This is coming to be third option. Okay. So this is all about. Okay. So we have gone through this method explanation coming on the board, because you are getting clear explanation and we are supporting it, so we can save a lot of time. That's why we have gone for that. Okay, then all the best. Your JEE mains examinations are approaching. All the best for that. Okay, bye. We define RMS current is like that. RMS current is that DC current which liberates same heat in a given resistor as given by a alternating current or varying current, LC oscillations. Capacitor is fully charged and connected across an inductor. Capacitor gets discharged, current in the inductor increases, and when capacitor is fully discharged, current in the conductor is maximum. Then capacitor charged with opposite polarity. Then when capacitor is fully charged, reversal happen in the opposite direction. So charge in the capacitor will be decreasing and increasing. Current in the inductor will be oscillating. Very good morning, all of you. Our discussion of JEE Mains 2026 January session continues. Today we have two chapters under discussion. First one, alternating current, and second one, electromagnetic waves. Okay, so these are the chapters having relatively large weightage. Okay, so let us start. Question number 1. Inductor stores energy 16 joules in a magnetic field energy and dissipates 32 watts of thermal energy due to the resistance. AC circuit of current 2 ampere, frequency 50 hertz. Then ratio of inductive reactance to capacitive reactance. As I told, let us go through the discussion given in the screen, so it will be saving time. Come on, heat thermal energy radiated only in resistor. Okay, then thermal power dissipated is given. In inductor energy is given, while in energy they use the word thermal energy, but we are calculating the power 32 watts, and power is I squared into R, that is 33. That gives you calculation, simple calculation, current is 2 amperes, R is equal to 8 ohms. First we got it. Now energy stored in inductor, everybody knows half Li square, half into L into current is 2 square, that comes to be 16. Again L comes to be 8. Okay. Now ratio of inductive reactance is L omega. We want L omega by R. L omega by R. Okay. L omega by R. L omega. L is 8. Omega is 2 pi into frequency. How much is given? Frequency is given here. Frequency is 50 hertz. Therefore 2 pi into 50 divided by R is 8. 8 get cancelled. 100 pi. Here 100 pi is 314. So your answer is 314. Okay. The gap is 314. Come on. We go to the next question. Next question, electric current is given by I is equal to I0 T by T, the RMS current for a period of T to 0 to T second. The way we define RMS current, let us go to the explanation. The way we go to the RMS current, We define RMS current is like that. RMS current is that DC current which liberates same heat in a given resistor as given by a alternating current or varying current. Whatever heat liberated in a DC circuit in a resistor, if that heat generated is equal to heat generated by a varying current or an alternating current, then that current, DC current, we call RMS current. Now tell me, from this relations coming to be, look, I RMS square into R into T is coming to be heat liberated by the varying current, integral 0 to T I squared dt. So by definition, this expression comes, then T to go to the left, right hand side, that's why it comes to be. Now, I is given to be I0 into T, we substitute for that. So this is I0 is a constant, T square is coming outside, integral 0 to 2 T square dt, I0 square by T cube into T cube by 3 giving limits. We are getting that is equal to I0 squared by 3. IRMS squared is I0 by 3. Therefore, IRMS is I0 by root 3. I0 by root 3. That's why we get it. Answer coming to be 1. Okay. So, this is the basic definition of, I repeat it. This comes from this explanation. Whatever heat liberated by a direct current is equal to heat liberated by a varying current. And for a DC current, what is the heat liberated? Current square into R into T. That current we call IRMS. And what is the formula for liberated by that? I square dt current. dt. I square dt. Okay. Now we substitute for I. It may be a varying current like this. Here, what is the current? 0 I0 into T I small by small t. It can be a varying current, it can be an alternating current, whatever it may be. This is the method of calculation. From this, we come to the statement, substitute for I, and we get the answer. We go to the next question. Now, an alternating circuit is given, LCR circuit is given. We have to calculate power factor. Let us go to the explanation quickly. Power factor is given by R by Z. R is the resistance, Z is impedance, root of R squared plus XL minus XL. Everything clear, very clearly given, isn't it? Tell me, XL minus XC is coming to be, or XC minus XL, whatever it may be, is coming to be 80. Then R is 60, root of 80 square plus 60 square. Therefore, impedance is coming to be, net impedance is coming to be 100. And R is coming to be 60. Therefore, R by Z will be 60 by 100, 6 by 10. And we are getting, the answer question is given to be, the value of power factor is alpha by 10. We got here 6 by 10. So in place of alpha, who is coming? 6 is coming. So very easy question. So this root of 150 minus 70 whole square, that is 80 square plus 60 square, that is 60. Correct? Then inductive reactance, resistance is given to be 60. So 60 by 100, 6 by 10. And this is alpha by 10. So alpha is 6. Okay, we go to the next question. Come on. Again in a AC circuit, given as maximum current measured is 50 milliampere. Then V is given by 5 sine 100t. Value of L and R shown in the figure. The capacitance of the circuit. First, let us calculate the impedance. So let us go to the explanation side. Tell me, how do you calculate impedance? impedance is calculated to be maximum voltage, that is 5 divided by current 50 milliampere, that comes to be 100 ohms. First thing, what is that? Impedance is coming to be 100 ohms. And resistance is also coming to be how many? 100 ohms. So here we get impedance is equal to resistance. Impedance we got is 100 ohms. Resistance is given to be 100 ohms. This is a case of resonance. This is a case of resonance. Okay. This is a case of resonance. Now, in resonance, we can find L omega is equal to 1 upon omega C, or C is equal to 1 upon omega square L. And working out, we are getting capacitance is equal to 5. So, direct question. C is equal to 1 by omega square L. Omega is given in the equation. In the equation, what is omega? 100. Omega square is 10 to the power of 4. L is 2 Henry. And solving, you are getting is equal to 50 microfarad. So your answer is 50 microfarad. Isn't it? Okay. Fill up the blanks is 50 microfarad. Next question, we go to the capacitor is charged fully with potential difference of V0, disconnected from it, and the charge capacitor is connected across an inductor like this. Let us do in the next page. Yes, capacitor is fully charged by Q0 and connected across an inductor. Okay, yes. Now, this will lead to the case of LC oscillations. Capacitor is fully charged and connected across an inductor. Capacitor gets discharged, current in the inductor increases, and when capacitor is fully discharged, current in the conductor is maximum. Then capacitor charged with opposite polarity. Then when capacitor is fully charged, reverse will happen in the opposite direction. So charge in the capacitor will be decreasing and increasing. Current in the inductor will be oscillating. Energy will be oscillating. So this leads to the LC oscillation. And in LC oscillations, we know that the angular frequency is equal to 1 by root LC. That's given. That is LC oscillations. Okay. Now, initially, capacitor was fully charged. How much energy is there? Half Q0. Initially, when it is connected, at that time, capacitor is fully charged. Now, after that, 25% energy is lost. Remaining energy is 75%. So, 75% means 3/4 of this. Okay? Isn't it? 3/4 of this. So, tell me what happened to the charge. Charge has become, Q has become, energy has become this 3/4. The charge has become root 3 by 2 Q0. Root 3 by 2 Q0. And you know, in LC oscillation, initially capacitor is fully charged and the charge start oscillating just like in simple harmonic variation. Here also, the charge in the capacitor will varying. Why it is coming a cost function? Initially, capacitor was fully charged. Initially. Therefore, equation will be Q0 cos omega t. Q0 cos omega t comes to be root 3 by 2 Q0. Q0 get cancel. Cos omega t is root 3 by 2. Omega t is pi by 6. Okay. Then omega is what? Root LC. Root LC into T is coming to be pi by 6. This gives you T is equal to pi divided by 6 root LC. Pi divided by 6 root LC. So this multiple option, pi into root LC. No. What is that? Omega T is given by pi by 6. Omega is 1 by root LC, not root LC, 1 by root LC. That's a mistake we made. Look, omega is 1 by, as I written there. So instead of omega t, we have to write omega t is how much? Pi by 6. Omega is 1 by root LC into T is equal to pi by 6. T is equal to pi root LC. LC will go to the numerator. Simple mathematics. Pi into root LC by 6. Okay, that is the value here. Pi into root LC. After this much time, the energy stored in the capacitor will be 1/4 will be lost, or it will be 3/4 will be remaining. Okay. Now we go to the questions from, we have to calculate, so we got the magnitude. Now we have to get the direction of it. In electromagnetic wave, direction of electromagnetic wave, E unit vector along E cross unit vector along B, is it unit vector along? And what we got here, I by A. What is I by A? I by A is current density, On your right hand side, epsilon in d by t, and that is equal to current by area, current density. So automatically unit will be coming to be ampere meter square. Due to the inertial transition, inertial means having more and more energy. Inertial electrons moving from higher energy level to the lower energy level. So we can find D matching with 3. Electromagnetic waves. Electromagnetic wave is moving in free space, and this electric field is given by E. Electric field amplitude is 50. So we can go to the explanation quickly. What is electric field amplitude? Electric field amplitude is given to be 54 from the equation. Okay. Wave is propagating along what direction? Z direction. Electric field is along Y direction. Electric field, because electric field equation is J, electric field is along Y direction, wave is propagating along Z direction, electric field amplitude is so. First we calculate magnetic field amplitude by the formula E0 by C, that comes to be 1.8 into 10 to the power of minus 6. Now we have to calculate, so we got the magnitude. Now we have to get the direction of it. In electromagnetic wave, direction of electromagnetic wave, E unit vector along E cross unit vector along B, is it unit vector along? Unit vector along E is coming to be J cross, we want to find the unit vector along B is equal to unit vector along wave propagation, that is the direction, that is K. And you know, J cross, which will give you K. You know, I cross J is K. Therefore, J cross minus I will be the K. J cross minus I will be the K. Therefore, magnetic field will be along negative x-axis. Magnitude is 1.08 10 to the power of minus 7. Then magnetic field variation will be minus 1.8 into 10 to the power of sine. Still wave is going along what direction? X minus what? Omega t. Direction is along negative x-axis. So answer is coming to be what? Answer is coming to be second one. Second one is the answer coming. Okay. Which of the next question? We'll go to the next question. Which of the following is not a measurable quantity? Displacement current is, in the case of capacitor charging, displacement current, we have the formula to calculate it, epsilon 0 into d phi by dt. So we have the formula to calculate it. We have the method to measure it. Also, it is equal to the conduction current. So if you measure the conduction current, you are in effect measuring displacement current, you can measure it. And voltage or potential. You know, we can talk about the potential of a point with respect to a reference point. A voltmeter measures potential difference, voltmeter measures potential, not directly the potential. And if you measure the potential difference and you know the potential of one of the point, we can measure the potential of other point. But we are not directly measuring the potential of a point. We are measuring only the potential difference. So in that point of view, logically saying, we are not measuring the voltage, we are not measuring the potential. Resistance, we have so many devices to measure Wheatstone bridge, Carey Foster bridge, so many bridges are there. All bridges will measure what? The resistance. Voltage difference, potentiometer. Yes, we have instrument, direct voltage measuring devices are there, hot wire voltmeters are there, so we have the instrument. So logically speaking, the one we cannot directly measure is potential or voltage. So our question's answer is what? 3. Okay. We go explanations I already given. Now come to the next question. Electric field of electromagnetic wave traveling through a medium. This wave is traveling through a medium. Yes, traveling through a medium. Yes. Then this is given to you. Refractive index of the medium is. Look, first, just like any wave equation, from wave equation, speed of the wave in that medium, is given by coefficient of t, that is omega, divided by coefficient of k. That is speed of the wave in the electromagnetic medium. Speed of wave, not in electromagnetic wave, even a mechanical wave. In the wave equation, speed is given by coefficient of t by coefficient of x, omega by k. In our problem, omega is given to be 2.5 10 to the power of 15. That's the coefficient of t. Coefficient of x is 10 to the power of 7. Then omega by will be coefficient of t divided by coefficient of x, that coming to be. That is the velocity in medium. We call it by 2.0 into 10 to the power of 8. Velocity in air, we usually say c, that is 3.0 into 10 to the power of 8. Then refractive index is given by velocity in medium divided by velocity in air. Refractive index is given by velocity in air by velocity in medium. That is coming to be 3 into 10 to the power of 8 by 2 into 10 to the power of 8. That is coming to be 1.5. Your answer is 1.5. Answer is 4 in the question. Now go to the next question. Come on. Look here in column 1, electromagnetic waves are given. Then column number 2, the method of generating is. First one is radio wave, A. Radio waves are produced due to the rapid acceleration of electron, A matching with 4. A studied due to the acceleration of electrons, basically within a conductor, not necessarily rapid acceleration of electrons will produce radio waves. So A is matching with 4. Come on. Yes. Now microwaves. Microwaves are produced by, when studied in theory, what is that? Magnetron, gun diode, etc. Klystron, not keltron, klystron, magnetron, and gun diodes. These are the devices for measuring what microwaves. So microwaves are measured by magnetron or klystron or gun diode, one matching with one. Infrared radiations. Infrared radiation due to the vibrations of the atoms or molecules. So infrared wave, that is C matching with 2. And X-ray, that is X-rays when electrons are knocked out from in the atomic configuration of a heavy target, that vacancy is created, is occupied by electrons jumping from higher levels. So transition of electron. So due to the inertial transition, inertial means having more energy. Inertial electrons moving from higher energy level to the lower energy level. So we can find D matching with 3. Very direct question, direct pick from NCERT book, theory book. A matching with 4, B matching with 1, C matching with 2, D matching with 3. Clearly answer is what? 1. Answer is 1. So explanation also given. Okay, come on. Next one, ratio of speeds of electromagnetic waves and in a medium having dielectric constant K is equal to 3 and permeability is equal to 2 mu 0. Okay, we can go to the explanation. Simple. Velocity in free space C is root of mu 0 by. Then velocity in medium, 1 by, we can say this formula comes like this. 1 by root of mu into epsilon. Instead of mu, you can write what? Mu is given to be 2 mu 0, given that. And this epsilon is equal to K into epsilon 0. K is coming to be what? 3. K is coming to be 3. Therefore, 1 by root of 2 mu 0 into 3 epsilon 0, that is 1 by, this is coming to be 1 by, this is coming to be 1 by root of 6 into mu 0 epsilon 0, that is 1 by root 6 into 1 by roots of mu 0 epsilon 0. This is C, that is C by root 6. Therefore, ratio of the speeds in vacuum to the medium. Vacuum it is C, this is C by root 6, then ratio is coming to be root 6. Root 6 is to 1. Root 6 is to 1. So direct question. Come on. Now coming to the next question. Equation of electric field is given by root 377 sine 6.27 10 to the power of 3, 2.09 10 to the power of minus 6. Average power of electromagnetic wave is given by 1 by alpha. You have to find the value of alpha. It is given that root of mu 0 by epsilon 0 is 377. Now tell me, let us go to the explanation. You have to look one thing here. What is that? They've used the word average power, but you see the unit in watts per meter square. Even though they have asked the word intensity, but unit says that we have to calculate. Instead they have asked about the word power, but unit coming to be watts per meter squared. So we need intensity, not power. Even though they asked about the word power, we want to calculate the intensity because unit is like that. And we have a ready-made formula for intensity. Okay. Yes. We can come to this by this calculation. Intensity is coming to be half epsilon 0 electric field amplitude square into C. Then we have to calculate what? We have to calculate the intensity. So better I will do the calculation in an easy manner. I is equal to half epsilon 0, yes, come on, into, instead of C, we can write 1 by root of mu 0 epsilon 0. This, instead of going this method, this will be easier. Same thing, intensity can be given by half epsilon 0 E0 square into C. I replace C by 1 by root of mu 0. So my equation comes to be, I will come over here. My equation comes to be intensity is equal to half E0 in the numerator, root of E0 denominator. So this will become root of epsilon 0, not E0, divided by mu 0 into E0 square, E0 square. I have replaced what? C. Now come to the question. Intensity I have to calculate half. Tell me, root of mu 0 by epsilon 0 is coming to be 377. Root of mu 0 by epsilon 0. But here it is root of epsilon 0. So it will be 1 by 377. Okay. This is given. Mu 0 by epsilon 0 is 377. I want root of epsilon 0 by mu 0. That comes to be 1 by 377 into epsilon 0 square. E0 square. E0 is coming to be root of 377. E0 square will be 377. Okay. So this is the easiest way of calculating. Simple. Start from this is a basic formula. Intensity. Now I replace C by, why I replace C? Because it is given in your question paper that we have to make use of this information, root of mu 0 by epsilon 0. To bring that, I replace C by root of mu 0 epsilon 0. Now the equation comes to be in this form. We know root of mu 0 by epsilon 0 is 377. Therefore, reciprocal will be 1 by 377. E0 square from the equation is what? Root 377 square will be 377. 377 get cancelled. I is coming to be 1 by 2. It is given that I is equal to 1 by alpha. So, who is in place of alpha? In place of alpha, you have 2. In place of alpha, you have 2. Okay. Now, go to the next question. Come on. A laser beam has an intensity 4 × 10 to the power of 4. Amplitude of magnetic field associated with the beam is. Okay, again, same problem. Instead of electric field, they go to the explanation. Tell me, yes, intensity will be given by half, either it is, I write both, either epsilon 0 E0 squared into C, or 1 by 2 B0 squared by mu 0 into C. Both are same, isn't it? We want the magnetic field maximum, we want the what amplitude, we want the B0, so we prefer this formula. Yes, okay. Now we are replacing the mu 0 by how much? 1 by C0, because C is equal to C square is 1 by mu 0 epsilon 0. Instead of mu 0, we can write 1 by epsilon 0 is square. Okay. Now our equation becomes half epsilon 0. So I am writing here intensity comes to be half epsilon 0 C cube B0 square. Okay. Now we are going to make some easy mathematical calculation. What mathematical calculation we are making? So we want B0 square. What mathematical calculation we are making is, isn't it? They have told, yeah, epsilon 0's value is given to you. B0 will be coming to be root of 2i divided by epsilon 0 into C cube. So substitute the values of 2i intensity is given to be 4 into 10 to the power of 5 is given. Epsilon 0 8.5 into 10 to the power of minus 12. Okay, this is C is 3 into 10 to the power of 28 whole cube. Simplifying, we'll be getting nearly 1.83 Tesla we are getting. Tesla we are getting nearly. Okay, coming to the next question. Now, epsilon ET represent free space permittivity electric field. Now, I want to find epsilon E, the quantity indicated by epsilon 0 E by T. Okay. Now, you have the formula for displacement current. What is that? Epsilon or epsilon 0, whatever it may be, epsilon into d phi by dt. Everybody knows that? Epsilon or epsilon 0 into d phi by dt, correct? then phi is given by E into A, isn't it? So I can write I is equal to epsilon into d by dt of E into A. So I is a constant, I take it out. I by A is coming to be epsilon into d by dt. And when you talk dimensionally, I want talk about dimensional or its unit. When you talk about dimension or unit, d by dt and E by t have same unit. So from a familiar representation, I came to our required. What is the required effect? Epsilon into E by T. We want epsilon into E by T. We want epsilon or epsilon 0, whatever it may be. Here it is given epsilon, epsilon. Not mathematically, but unit wise or dimension wise. And what we got here, I by A. What is I by A? I by A is current density, current density. On your right hand side, epsilon into E by T, and that is equal to current by area, current density. So automatically unit will be coming to be ampere meter squared. So how this comes? So in such cases, we have a direct method. What is the direct method we have to follow? We have to substitute for what? Epsilon. We have to make it out. We don't remember any special case. E we know that you write. T we know. Okay. So, but think about some familiar quantities coming. One familiar quantity coming is I displacement current is equal to epsilon into d phi by dt. Phi is electric flux. That is E into A. Everything based on the unit system or dimension system. So I got d by dt of electric field into A. I take it out. A will go to the other side. ID by A is equal to epsilon into dE by dt. Dimensionally, that is same as that of epsilon into E by t. I want this quantity. I want epsilon into E by t. Epsilon into E by t is just look into the left hand side. That is coming to be displacement current by area, displacement current density, ampere per meter square. So explanation given in a more elaborate manner than given in the question paper. So I go to the next question. Electromagnetic plane wave traveling in unknown non-magnetic. I underline it. What's meaning I will tell you. It's not magnetic. Non-magnetic means its permeability will be very, very small. Permeability will be very, very small. Very, very small. Isn't it? Nearly 1. We cannot take less than 1 because it will become a diamagnetic. Isn't it? So non-magnetic means permeability is relative permeability, not permeability. Relative permeability is nearly equal to 1. That's the meaning I can say. Relative permeability. Or what mu r? Mu r is, let us go to the explanation, that's better. I'll go to the explanation. Yes, here relative permeability we can take it as 1. I will write here relative permeability, I can take it as 1. Okay, now this is the medium. So we can calculate the speed in the medium. We are using second time coefficient of t by coefficient of x, omega by k. That comes to be 1.5 into 10 to the power. We got from the wave equation, we can calculate the speed of electromagnetic waves in that medium is coming to be omega by k. That comes to be 1.5 into 10 to the power of 8 meter per second. And you know, refractive index of the medium is given by, or 3 into 10 to the power of 8, velocity in air by velocity in medium, that comes to be 2. And we know that 2 is equal to, we know that mu r is nearly 1. Therefore, mu will be coming to be root of epsilon or mu r relative permeability is coming to be 1. Therefore, mu r is coming to be root of epsilon r. That is coming to be mu square, that is coming to be 4. Refractive index is coming to be 2. Mu square is coming to be 4. Therefore, your answer is coming to be 4. Okay, come on. Next question. Electromagnetic wave, frequency is 100 megahertz, propagates through a medium of conductivity 10 ohms per meter, ratio of maximum conduction current density to maximum displacement current density. Yes. Go to the explanation. Look, you know, according to the Ohm's law, we do it like that. V is equal to IR. V is equal to I into R. R will be rho into L by A. Okay. V by L is equal to I by A into rho. V by L is electric field E. I by A is conduction current density and rho. Therefore, conduction current density is given by 1 by rho into A, or we can take it as sigma into E. Therefore, conduction current maximum is equal to sigma into maximum electric field. Got it? Okay. That is given here. That is sigma into E. So maximum means maximum value. And displacement current density we have written just now. What is that? Displacement current density, we got it as how much? Epsilon 0 into d by dt. Correct? So this you remember it, but I derived it out how this comes. Electric field is going to be the conduction current density into rho, or conduction current density is 1 by rho into E, that is sigma into E. Then maximum value, the maximum value of electric field. Here also maximum value of current, maximum value of electric field. Now we have to calculate what? The ratio between them. Ratio between them. Isn't it? Ratio between them. Tell me the J displacement current is epsilon 0 into electric field. Electric field is electromagnetic wave sinusoidally varying. It is d by dt of, because we E0 into sine omega t. Correct? E0 into sine omega t. Therefore, displacement current maximum, displacement current first, right? Epsilon 0 E into omega into cos omega t. Isn't it? Therefore, displacement current maximum is equal to epsilon 0 electric field maximum into omega. So, once again, we got conduction current maximum as what? Sigma into E0. Displacement current maximum as epsilon 0. This is the displacement current. Its maximum value will be JE0 into omega when cos omega t becomes 1. Okay. Now I want the ratio between them. Ratio between them. What is that? Ratio between the displacement, conduction current maximum by displacement current maximum, sigma into E0, epsilon 0, E omega into E0. E0 get cancelled. Sigma by omega, sigma by epsilon 0 into omega. Omega is coming to be 2 pi into 10 to the power of 8. You make a substitution. What is that? Multiplied by 4 pi and divided by 4 pi. So this equation becomes sigma into 4 pi divided by 4 pi epsilon 0 into omega. Correct? 4 pi epsilon 0 into omega. E0 could cancel. Make it easiness. I multiplied by 4 pi and divided by 4 pi. Now tell me what is coming. Sigma is coming to be 10 into 4 pi, correct? Divided by, what is the value of 1 by 4 pi epsilon 0? that is 9 into 10 to the power of 9. That will go to the numerator. 9 into 10 to the power of 9. Divided by omega. Omega is given to be, how much we got omega? Omega is given to be 2 pi into 10 to the power of 8. Then 2 pi and 4 pi get cancelled. 2, 10 to the power of, so this is coming to be 18 into 100. This is, when you work it out, this is coming to be 180 into 10 or 1800. Okay. So all the questions have come from this year's alternating current and electromagnetic waves chapter. Okay. So that's all about. Not calculating the magnification. Magnification, you know, magnification of first image, because object kept at 2f, image will be formed at 2f on the other side. So I write in the first case, this is first case, we have ready-made formula for refractive index, sine of a plus minimum deviation by 2 sine a by 2. Here it is given that angle of minimum deviation is equal to a. So when you substitute it, you are getting, that is sine a, we have split it as sine a by 2 cos a by 2 by sine a by 2. This is coming to be 2 cos a by 2. JEE Main's answer key published. They deleted the question. I think there was some in the original paper came, I think it was I1 greater than 25 degree. I think so. Very good afternoon, everybody. Today, our JEE discussion paper, January 26, JEE Mains paper, ray optics is the paper. Ray optics is the paper. Okay. Let us come to the first question. Here diagram is given. The two plano-convex lenses of details given. First one, refractive index 1.5, radius of curvature of curved surfaces 15, other is 1.2 and 12 centimeter are kept in contact. And when an object is placed at a distance of 30 centimeter from the combination, the combined one, what will be the magnification produced? So let us treat the first part, first lens, first plano-convex lens of refractive index 1.5. We can directly use, even without writing the formula, 1 by f is equal to mu minus 1 into 1 by r1. 1 by r1. Yes. And that is coming to be, focal length of first lens is coming to be, yes, we can find it out. I will find it out here. That better to find out here. 1 by f1 is equal to mu minus 1 is 0.5 into how much? 1 by 15. 1 by 15. Therefore, because plane surface is 15, that comes to be f1 is equal to 15 by 0.5, that is equal to 30 centimeter. Second one, 1 by f2 is equal to, that will be minus, because it is a, it's correct. That will be coming to be, we can again treat it as 0.2 into 1 by 12. That is also a plano convex lens. That comes to be 0.2, that is coming to be, f2 is coming to be 60 centimeter. Okay. Now they are kept in contact. Both are plano-convex lenses. Both will behave like a, one is of focal length, and here we have calculated the effective focal length as 1 by f is equal to 1 by f1 plus 1 by f2. We can easily work it out, it as f is equal to f1, f2 divided by F1 plus F2, that is 60 into 30 divided by 90, and that is coming to be 20 centimeter. We got it. Effective focal length is 20 centimeter. Now, again, I'm going to use, because we know many occasions we have used that for a lens, magnification is given by the formula F divided by F plus U. That will be a convenient formula. Here what we have done, we have calculated V, then V by U, they have calculated what? Magnification. But we can directly calculate M is equal to F divided by F plus U. F is combinations focal length. Combinations focal length is coming to be, we got it as how many? Combinations focal length, we got it as 20 centimeter. Okay, here we got 20 centimeter. Then F is a convex lens, it is 30 divided by, not 30, 20. Combinations focal length is 20. That is 20 divided by 20. While putting the value of U, object is kept at a distance of how many? 30 centimeter in front of the combination. So U shine should be minus 30. So this is coming to be 20. That comes to be minus 2. Magnification is coming to be minus 2. Okay. So we can use relatively easy steps. Okay. First, for the plano convex lens, we have direct formula. What is that? Mu minus 1 into 1 by R. Second one, mu minus 1 into 1 by R. So one is 30 and other is 60. Combination focal length we have quickly calculated as 20. Then object is kept at 30 centimeter. Magnification also we can calculate using this. So answer is minus 2. Okay. Next one, a transparent prism, angle of minimum deviation. So minimum deviations value. So let us go to the explanation, that will be better. Yes, we have ready-made formula for refractive index, sine of A plus minimum deviation by 2 sine A by 2. Here it is given that angle of minimum deviation is equal to A. So when you substitute it, you are getting, that is sine A, we have split it as sine A by 2 cos A by 2 by sine A by 2. This is coming to be 2 cos A by 2. If you are not calculating the numerical value, we have the refractive index coming to be A cos A by 2. But we have to, the options given are, what are the possible values of n? A range of values are given. So we have to calculate it. Now tell me, angle of prism speaking, practically speaking, minimum value of angle of prism possible is 0. When angle of prism is 0, A is 0, A by 2 is 0, then refractive index is coming to be 2. So one extent refractive index is 2. Other possibility, A is coming to be 90. If A comes to 90, A by 2 is 45. 2 cos 45 will be root 2. Therefore, minimum value of refractive index possible is root 2. Maximum value of refractive index is possible is what? 2. So your option is 1, root in between root 2 and 2. In between root 2 and 2. We go to the next question. Come on. The convex lens of refractive index 1.5, focal length 1 point, immersed in water. So here I'm going to the explanation, but no need of going for this much calculation. Tell me, when the basic result we are using a lens of refractive index, material refractive index mu 1.5, and immersed in water of, that is mu glass, refractive index of mu water is 4 by 3. We have a basic formula that focal length will increase exactly by 4 times. So we have three cases we can remember. One, if a lens is immersed in any transparent medium, focal length will increase. If that transparent medium is water of refractive index 4/3, lens material mu g is 1.5. Here we have calculated it. Without calculation, we can say the focal length becomes 18, 4 times. Focal length becomes 4 times, isn't it? Then answer is that question is asked you the difference in focal length. First time focal length is f, second time focal length is 4f, f is 18, first focal length is 18 centimeter, second focal length is 4 into 18, that is coming to be 72 times or 72 centimeter, or simply we can say the focal length becomes, then change difference in focal length is 54. F2 minus F1 is 54. 54 means 3 times the initial value. So without any calculation we can find it. That, but we have to ensure that lens material is of refractive index 3/2, immersed in water of refractive index 4/3. We can take it as granted that focal length will be increased 4 times. So that itself is sufficient. No need of calculating F1 and F2. Directly we can find that focal length becomes 4 times. Change is 3F. So change is 3 times F. 3 times F. Okay. Answer is alpha is 3. We go to the next question. Magnitudes of power of biconvex lens of refractive index 1.5 and that of plano-concave lens is 1.7. Curvature of the concave lens exactly matching with curvature of the back surface of biconvex lens. Then ratio of the radius of curvature of front and back sides of biconvex lens. Isn't it? Biconvex. First is a biconvex lens. So I'll draw in the next page, in the explanation page, that will be better. Yes, this is the biconvex lens. It is told that the curvature of the plano-convex lens exactly matches with the curvature. So this is the arrangement. So for this lens, R1, R2. For a convex lens, biconvex lens, curvatures are R1 and R2, and plano-concave lens, curvature is R2. And magnitudes of the power. So first one, it is given that power of the convex lens will be 0.5 because refractive index is 1.5. 0.5 into 1 by R1 plus 1 by R2. Okay, this is the power of biconvex lens. And power of that convex lens is mu minus 1 is 0.7 into 1 by R2. And we are equating only the magnitudes. It is a negative sign. This is minus 0.7 into 1 by R2. And we are equating the powers. Power of convex lens and power of plano-concave lens are equal. Powers numerical values. So power of biconvex lens, we got it as 0.5 into 1 by R1 plus 1 by R2. And this one is 0.7 by R2. Then simplifying, we will be getting R1 by R2 is equal to 5/2. Okay. So again, we are using the lens maker formula. For a biconvex lens, we have mu minus 1 is 0.5 into 1 by R1 plus 1 by R2. For a plano-concave lens, it is minus, because it is a concave lens, plano-concave lens, minus 0.7 into 1 by R2. Numerical values, magnitudes are equated in. And we have to rearrange it, simplifying. We have to get the value of R1 by R2. R1 by R2 is coming to be 5 by 2. That is, ratio of the R1 by R2 is coming to be 5 by 2. Yes. So answer for the question number 4 is 1. 5 is to 2. Now we go to the next question. Now here P1, P2, P3, P4, P5 recorded. The pair of object distance and image UV pairs are given. Object distance and image distance are given. There are 5 cases, P1, P2, P3, P4 respectively. Then we have to get plus 5 power. So I'm not going to explanation page, I use this. Power is equal to plus 5. Means it is a what? Convex lens having a power plus 5D. Isn't it? This means it's one image using same, all the cases power is plus 5 by 2. Then what are the possible values of object distance and image using same convex lens? Look, so it is a convex lens of power point plus 5. So this gives you first information. What is the first information? Focal length is 1 by P, 1 by 0.5. That is 0.2 meter, or focal length is 20 centimeter. That's the first information you make. From the power plus 5 diopter means focal length is plus, because it's a convex lens, not especially mentioning, it is 20 centimeter. Now come, we have to check. And what about 2F? 40 centimeter. Okay. First case, object distance is 25. First case, object distance is 25. U is greater than F. And you know, if U is greater than F, V should be greater than 2F. 2F is what? 40 centimeter. Therefore, V should be more than 80. So, U is greater than F, V is greater than 2F, that is, V is greater than 40 centimeter. V is greater than 40 centimeter. Let us check, is it coming correct? U is greater than F, 25, correct? And V is greater than 40 centimeter. This is a possible option. Case 2, let us check. U 30, U is greater than F because F is this thing. Therefore, V should be again greater than 2F. Here, what is the value of V is given to be 62. Again, it is correct. V is more than 40 centimeter. V is 60 centimeter, greater than 40. So, this is correct possibility. Third option, U is greater than F because U is what? 35, greater than F. Therefore, V should be greater than 2F, isn't it? So, V should be greater than 40. V is greater than 2F, or V should be greater than 40 centimeter. But here, V is given to be 37 centimeter. So, the case P3 is not possible. Case P3 is, because in case P3, object distance is more than 2F because it is 35 centimeter, F is 20 centimeter more than F, image should be more than 2F, it should be more than 40 centimeter. So this case is not possible. Then we can easily go through it. What about this case 4, P4? Here U is greater than 2F, U is greater than 2F, V should be greater than F. Yes, or V should be greater than 20 centimeter. Let us check. Yes, This is 45 and greater than F. U is greater than 40, therefore V is greater than 20. Is correct. V is greater than 20. This is the correct option. The second case, again, fifth case. In fifth case, U is greater than 2F because 2F is 40. Here it is given 50 centimeter. Therefore, V should be greater than F or V should be greater than 20. Here it is given, V is given to be 32. So this is matching. So according to the given informations of U and V, P1 case possible, P2 case possible, P4 case possible, P5 case possible, P3 case not possible. I explain once again P3 case. In P3 case, object distance is given to be 30. That is more than F, more than 20. Therefore, according to the image formation, we should be greater than 2F. We should be more than 2F. We should be more than 40 centimeter, but it is less than 40 centimeter. So this case is not possible. So what is the answer? That reading P3 cannot be or incorrect. Reading P3 cannot be possible. It is incorrect. So our option is 4. Our option is 4. Next, we are going to the fifth question. 5%. So okay, we have done it. Explanation is over. We go to the next question. Distance between object and 3 times magnified image is 40 centimeter. The focal length of the mirror used is. Let us go to explanation quickly. Here, magnification is coming to be -3. Okay, because real image, magnified image. So here it is given that magnitude of V minus magnitude of U. Numerical value only. Distance, we have to take numerical values. So magnitude of V minus magnitude of U is magnitude of 3U minus U, that is 2U. And the distance is coming to be 40 centimeter, that U is coming to be 20 centimeter. Therefore, object distance is coming to be 20 centimeter. Okay. Now, we have to calculate what? We have to calculate the focal length of the lens. Again, I told you this is a mirror. For a mirror, the magnification formula is given by F divided by F minus U. Lens it is F divided by F plus U. It is F divided by F minus U. Magnification is given to be magnification is given to be -3 real image. Yes, we have to calculate the focal length. So I don't give the sign of focal length. F minus U is given to be how many? 20 centimeter. Minus of minus 20. And we are getting -3 is equal to F divided by F plus 20. Multiplying -3F minus 60 is equal to F. So that comes to be 4F is equal to minus 60. F is equal to minus 15. F is equal to minus 15. So your answer is minus 15. Question number 6. Answer is minus 15. That is option 2. Option 2. We go to the next question. Tell me, microscope tube length is 10 centimeter and convex lens are arranged with focal length of 2 centimeter and 5 centimeter. Magnified, the magnification of the system or the microscope is given to be 5 to the power of K. We have to calculate the values. It's a very simple question. Explanation is very clearly given. We have the ready-made formula for L into D divided by FO into FE. L is length of microscope, D is least distance of distinction, that is 25. When you work it out, this is coming to be 5 into 5, that is coming to be 5 square. Or here it is 5 square is equal to 5 to the power of K. Value of K is coming to be 2. Value of K is coming to be 2. So your answer is coming to be 4. Answer is coming to be 4. So we go to the next question. Come on. The exit surface of a prism of refractive index N is coated with a material having refractive index N by 2. When this prism is set for minimum angle of deviation, exactly it meets the condition for critical angle. Yes. So let us better to draw a diagram. Yes. This is being coated with a material of refractive index. It is coated with the material of refractive index n by 2. And here it is n. You know, a light ray, yes. Tell me, this is R1, this is R2. So first of all, since it is undergoing the minimum deviation condition, we can find R1 is equal to R2 is equal to A by 2. The first condition we have written. R1 is equal to R2 is equal to A by 2. Then second condition, it meets the condition for critical angle, meets the condition for the critical angle. So we can find that here this is 90 degree, this angle of refraction is 90 degree. So we can using the condition that coming from a medium n into sine R2 is equal to n into, because here it is angle of refraction is 90, here angle of n1 mu1 is equal to n2 mu2, n into sine R2 is equal to n by 2 into sine 90. When you solve it out, sine R2 is coming to be half, or R2 is coming to be 30 degree. Therefore, we have to calculate the angle of prism. Angle of prism is R1 is equal to R2 is equal to A by 2. That is A by 2 is 30 degree, or A is equal to 30 into 2, 60 degree. So answer for the question is 60 degree. Answer option is 3. Go to the next question. Size of an image of an object found by a thin equal to an object placed at two different positions of 8 centimeter and 25 centimeter from the lens. Focal length of the lens is two different positions. One is a magnified image and other is a diminished image, isn't it? Okay, so tell me the size of the images, So here, what is the size of the image or magnifications? F divided by F plus U. That is coming to be F divided by F minus A. For the second case, F divided by F minus 4. But this is our image, real image, this is minus, this is a virtual image plus. And now simplifying, F get cancelled, F minus 24 is equal to minus of minus F by 2, and we are getting F is equal to 16 centimeter. F is coming to be 16 centimeter. So in question number 9, the gap missing is 16 centimeter. Simple problem. We are here, magnitudes are equal, but when you equate it, if you cannot equate the magnitudes, if magnitudes are equating, there is no meaning in the expression. So we have to expect real situation. This is a virtual image F divided by F minus 8, because object is kept within focal length. This is object is kept beyond F. Therefore, this is a real image, magnification is minor. So I equate for the formula of magnification. Then numerators are equal, so denominators can be equated. F minus 24 is minus of F minus 8. Then we'll be getting the answer. We go to the next question. Okay. Now, prism of 75 degree and refractive index root 3 is coated with a film of refractive index 1.5 at the back surface to have total internal reflection at the back X surface. Then incident angle must be. Let us go to the, so what were things given to you? Refractive index move, angle of prism 75 degree, back side is coated with the material of refractive index 1.5, and total internal reflection takes place there. So let us go to the explanation. This is, tell me at the back surface, and these informations are also given to you. At the total internal reflection at the back surface, there angle of refraction at second surface R2 must be greater than or equal to critical angle. R2 is greater than sine inverse mu film by mu prism. That is the, because light coming not from air to the film, coming from prism material to film material. So R2 should be greater than sine inverse mu film. And that you work it out, this is coming to be greater than or equal to 60 degree. Better I draw the diagram. This is 75 degree. This undergoes total internal reflection, isn't it? So this is greater than, this is R2 is greater than or equal to critical angle. This is R1. Tell me, R2 we got how many? 60 degree. Therefore, R1 plus R2 is how much? A. Therefore, R1 is A minus R2. A is 75 degree. 75 minus 60. That is how many? 15 degree. But we have to put a condition. What is the condition we are putting? R2 is greater than what? That's better. R2 is greater than 60 degree. And you know what is R1? R1 is A minus R2. If R2 is greater than 60 degree, R1 will be less than what? 15 degree. If R2 is 60 degree, R1 will be 15. But here it is given that for total reflection to happen, R2 should be greater than 60 degree. Therefore, R1 should be less than 50 degree. Then here we have to calculate the angle of incidence. Okay. So angle of incidence we can calculate. Here it is given that sine I is equal to root 3 sine R1, and that is coming to be root 3 is 1.C3, that is 0.58. This is coming to be 0.5. Therefore, sine I is coming to be 0.44, nearly 0.44. Isn't it? Okay. And sine I is 0.44. I will be given to be sine inverse. I is given to be sine inverse 0.44. That value is also given to here. 0.43 or 44. Nearly this is coming to be 25 degree or 26 degree. Okay. So now look here. Mu is sin I by sin R. In the first surface, mu is sin I by sin R1. So if R1 is less than 15, automatically I1 should be less than, how much I1 I got? 25 degree. I1 should be 25 or 26 degree. Okay. And the option in the JEE Mains answer key published, they deleted the question. I think there was some in the original paper came, I think it was I1 greater than 25 degree. I think so. I'm not sure about it. I think so. So that's why when the key correction came, that question was deleted. But now, according to the option given to your question paper, now I go back to the question paper. According to the option given to the question paper, here options are less than 26 degree or less than 25 degree. So here, accordingly, option 3 is correct. But in the question paper at the time of examination on January, this paper, this option was, I think, wrongly printed. That's why they have deleted it. Okay. Chaithanya Classes. Madam, class madam. Yes. Now, a thin prism of angle 5 degree refractive index 1.72 is combined with another prism of refractive index 1.9 to produce dispersion without deviation. So very simple question. Explanation is very clearly here produces dispersion without deviation. Therefore, simple calculation, the deviations formula is A into mu minus 1. Deviation of first prism is equal to deviation of second prism. Here, A1 given, mu1 given, mu2 given, A2 you have to calculate. So, using this values of A1, mu1, mu2, we are getting A2 is equal to 4 degree. We are getting A2 is equal to 4 degree. Very direct substitution. Deviation due to mirror number 1, sorry, present number 1 is equal to deviation due to the present number 2 without deviation. So deviations we equated. We go to the next question. Consider a light traveling from a medium A to medium B in a plane reference. The light undergoes total internal reflection, travel from medium A to B. The speed of light in medium A to medium B is 2.4 respectively. Then value of the critical angle, You know, here speed in medium A, VA is coming to be 2.4 into 10 to the power of 8. VB is coming to be 2.7 into 10 to the power of 8. Therefore, B is a rarer medium. Speed of wave is more, speed of light is more. Therefore, B is a rarer medium. B is a rarer medium. Yes, B is a rarer medium. Okay, first information. Now, here it is given that light coming from A is a denser medium. Light coming from A to B, light coming from denser to rarer medium. First condition for total reflection has taken place. Now, here, what do you have to calculate? Critical angle we have to calculate. So, sine of critical angle is given by 1 by normal mu. What is normal mu? Light goes from rarer to denser. Light going from rarer to denser, isn't it? Light going from rarer to denser. So what will be that? That will be refractive index of A mu B, because we have to consider normal mu, light going from rarer to denser medium. So A is a denser medium, B is a rarer medium, sorry. We have to write it as what? B mu A. And we know the B A mu A is equal to mu A by mu B. Therefore, sin C is equal to 1 by mu A by mu B. That comes to be mu B by what? Mu A. Mu B by mu A. Oh, is equal to mu B, mu A by mu B. The sin C is equal to mu B by mu A. Refractive index of mu B. Refractive index of mu B will be what? Velocity in air divided by velocity in B divided by velocity in air divided by velocity in A. That comes to be velocity in air get cancelled, velocity in A in velocity in B. That is sin C. And A is a denser medium where velocity is less. And what is that less velocity? 2.4 into 10 to the power of 8. Similarly, divided by velocity in B, rarer medium, speed is more. Speed is coming to be 2.7 into 10 to the power of 8. This is coming to be 2.4 by 2.7. That comes to be 8. This is 3. No. This is 8 by 9. Isn't it? Therefore, we are getting sin C is coming to be 8 by 9. Now look into the option, whether any answer coming. Sin inverse 9 by 8 is there, but that is not possible. We want sin 8 by 9. So we have to look into other options. So let us find out other angles we can make. Let us mark C here. This is C. C is opposite side by hypotenuse. Opposite side by hypotenuse. So opposite side is 8, hypotenuse is 9. This will be root of 9 square. 9 square is 81 minus 64. That is root of 17. So one option is that, what about tan C? Tan C will be equal to 8 by root 7. That is possible. We can make tan C is equal to 8 by root 17, or C is equal to tan inverse 8 by root 17. That option is there, isn't it? So first calculation, first attempt, we are getting what value? We are getting the value sin C is equal to 8 by 9. But that value is not over there. So we try for other angles. We have to make a right angle triangle. From that we find out tan C or cos C, whatever require. Here tan C is matching, so we'll be getting its answer is coming to be 1. Next one, so its explanations I have given separately. Now come on, wavelength of light in passing through water is 540 nanometer. Refractive index of water is 4 by 3. Wavelength of same light when passing through, again I'll give an easy explanation. Let us go to the explanation part whether any. Yes, it is very simple. Wavelength in a medium into mu m is equal to wavelength in water into mu w. This is it. So lambda in medium into 3 by 2 is equal to wavelength in air is given to be 540. Wavelength in water. Wavelength in passing through water is 540. What for 540 into 4 by 3, and other is what? Light while passing through water is 540. Refractive index of water is 4 by 3. Wavelength of the same light when passing through another medium, that's 3 by 2. So solving it, we'll be getting what? Lambda m is equal to 480 meter. Which is easy question, direct question. Okay. Let us go to the other one. A parallax method determines focal length of a concave mirror. So in parallax method, what do? We keep an object, either a pin or a light source. We get a real image formed on a screen. So here object and images are real image you are getting. Real image you are getting. For getting a real image, object should be placed beyond focus. Once again, this is a case of image formation by parallax method by a concave mirror. For a concave mirror to give a real image, because we are getting images formed on a screen in parallax method. Images formed on a screen in parallax method, it should be real image. For real images to be formed, focal length should be more than, object distance should be more than focal length. Therefore, object should be placed at any point beyond the focus. So answer is 3. Let us go to the next question. So explanation is given. I go to the next question. Tell me, a thin convex lens of focal length 5 centimeter and thin concave lens of focal length 4 centimeter are combined together without any. So yes, first case, two lenses are kept in contact. One is a convex lens of focal length, other is a concave lens of focal length. Yes. This is F1, 5 centimeter. This is F2, minus 4 centimeter. Now, in first case, an object is kept placed at 10 centimeter before the convex lens, and it is easy for you because focal length is 5 centimeter. We are keeping the object at 10 centimeter. So image will be formed. First case, image will be formed at this is object. Image will be formed. This is 10 centimeter means 2F. Image will be formed 2F on other side, 10 centimeter. Okay, we got it, isn't it? Then when the image is placed 6 centimeter before the convex lens, keeping the position of, so here, tell me, M1 is the magnification of what? The combination of lenses. So we can consider like that. The convex lens forms an intermediate image, and that intermediate image is 10 centimeter. That is going to form an object for the concave lens and forms the final image. Final image. So tell me, I am not calculating the magnification. Magnification, you know, magnification of first image, because object kept at 2f, image will be formed at 2f on the other side. So I write in the first case, this is first case, when the two lenses were kept in contact, object is kept at 10 centimeter, that is at the 2f of convex lens, image will be formed on the 2x on the other side. So magnification will be -1. Okay, so we got it. Then, you know, second case, second lens, that is, I told you, magnification in the first case, M11. That is in the first case due to the first lens. First case due to the first lens is M11. Then M12. M12, we can calculate what? First case due to the second lens, you know, where the magnifications you can directly get f2 divided by f2 plus u. Look, f2 is what? F2 is focal length of the concave lens, that is -4, divided by -4. And here the intermediate image I acts as an object for what? The second lens. So second lens object distance is what? 10 centimeter behind the lens. So we can take it as what? +10. We can write it as +10. So magnification in second case will be how much? -4 divided by +6. Isn't it? That comes to be minus 6. So -2/3. -2/3. Therefore, tell me, so we got the magnification as so. Let us go to the other one. We have to calculate. Understand the gap of 1 centimeter. Okay. Second case, M12 is equal to F2 divided by F2 plus U. F2 is -4. Then F2 plus -4 plus 10. Because intermediate image is formed at centimeter. This is coming to be 2/3. Therefore, in the first case, combinations effective magnification is M12, its numerical value we want. M12 into M11 into M12. That comes to be -1 into -2/3. That is coming to be 2/3. Now, in the second case, again, what arrangement they made is that concave lens is moved through a distance 1 centimeter. Other things remaining same. Isn't it? Object is kept here at 10 centimeter. This is F1, 5 centimeter. This is F2. And due to the first one, intermediate image will be formed in the first case, M1. Oh, here I will write. Okay, here I will write. Second case, magnification due to first lens, that I write M1 in second case, M1 2. Again, object is kept at 2F, image will be formed at 2F, therefore it will be -1 as in the previous case. Then for second case, it is 1 centimeter advance. This is 1 centimeter advance. Now distance from intermediate image to the lens, this is coming to be 9 centimeter only. 9 centimeter. First case, they were in contact. Intermediate image was formed at I at 10 centimeter. Distance from intermediate image to the concave lens was 10 centimeter. I calculated the magnification using this formula. I got it as -2/3 and overall magnification is 2/3. Now, in second case, I am calculating the magnification due to the second lens. In second case will be minus f divided by f2 plus 1, that is -4 divided by -4 plus 9, that comes to be -4 divided by 5, -4 divided by 5, isn't it? -4 divided by 5. Okay, yes. Then combinations focal length in second case, -4 divided by -4 plus 9, and that comes to be, this is 5 -4 by 9. Then M22 will be -1 into -4 by 5, that comes to be 4 by 5. So combinations, first case combinations magnifications value, that is coming to be 2/3. Second case magnifications value coming to be how much? 4 by 5. Is it coming to be 4 by 5? Then ratio will be M1 by M2 will be 2/3 into 5 by 4. That is coming to be 5:6. 5:6. Question number 15. The answer is coming to be 5:6. Option number 1 is the correct answer. Okay. Yes. So some lengthy arrangement is that, but we can simplify the calculations. Okay. Because as far as first case and second case is there, intermediate image is formed at same location, same image, no change for that. So it is formed at a distance 10 centimeter from the combination, from the convex lens, and magnification is -1 because it is a image formed at 2F. Then we have to calculate magnification in first case and second case, and that we got 2/3 and 4 by 5. Then we will be getting the answer. We go to the next question. Come on. The answer is 5/6. Come on. A parallel beam of light traveling in air, refractive index 1, incident on a convex spherical glass surface of radius of curvature 50 centimeter, refractive index of glass is 1.5. Rays converge to a point distance x from the center. Okay, yes. Let us draw the diagram. Yes, a light beam traveling from air is incident on a convex spherical glass surface, convex surface. Yes, this is O, but the object is kept parallel beam. Yes, and it is converging to a point here. Okay, this is the center of curvature. This is the image. We have to calculate the distance. The rays converge at a point distant x from the center of curvature. So we want to calculate distance from R to I, that is our x. Distance R to 1 is x. So we have to calculate what? The value of x. Now, refraction at a single surface, mu2 by v minus mu1 by u, or mu2 minus mu1, substituting for that, object is infinity, therefore u is at infinity. Working out, we are getting v is coming to be 150 centimeter. V is from O to I. O to I is 150 centimeter. But we know that radius of curvature is given to be how many centimeter? 50 centimeter. This is coming to be 50 centimeter. Therefore, we want x. X is equal to OI minus OR. OX we got it as 150 centimeter. OI we got it as 50 centimeter. Therefore, x is coming to be 100 centimeter. X is coming to be 100 centimeter. In question number 16, your answer is coming to be 100 centimeter. Okay, come on. We go to the next question. Equilateral prism of refractive index √2 ray of light is incident on its one of the surface. Critical angle I and emerge ray is found to graze along the surface. Then angle of refraction of the incident ray is close to, referent ray is close to. So refracting this √2 ray of incident at one of the surface at certain angle I, and it is going grazing from second surface. Okay. Yes, it is incident here, then it goes like that. So, come on. Here, the angle of incidence I, we have to calculate the angle of refraction. Here, we have to calculate it. This is I, this is R1, this is R2. Refractive index is √2. This is going, this will be 90 degree. This gives you R2 is equal to critical angle is equal to 1 by mu, that is coming to be 1 by √2. Therefore, R2 is C is coming to be, R2 is coming to be C is equal to 45 degree. Isn't it? Sin C, not C. R2 is equal to sin C is equal to 1 by mu is equal to 1 by √2. Therefore, R2 is equal to C is equal to 40 degree. Now, this is an equilateral prism. Therefore, this is what? 60 degree. Therefore, we know R1 plus R2 is equal to what? 60 degree. R1 plus R2 is equal to 60 degree. Therefore, R1 will be is equal to 60 minus 45. That is, R1 is coming to be 15 degree. Isn't it? R1 is coming to be 15 degree. Now, we have to calculate what the angle of refraction, that is R1. Angle of refraction at first surface is R1. So it's very clearly R1 is equal to what? 50 degree. Very simple combination. Light ray coming here, going like that. Second surface, it undergoes grazing. That means this is 90 degree. So this is critical angle. Critical angle, we got it as what? 45 degree. Critical angle is your R2. And for prism, R1 plus R2 is equal to A. Here A is 60 degree. R1 plus R2 is 60 degree. R1 is equal to 60 minus 45. That is 15 degree. So easy calculation. We go to the next question. Okay. Now, tell me here, I'll do here, I'm not going to the explanations, I'm not clear in explanations. Look, I'll draw it in a better manner. It is told that here I draw the normal. Here I draw the normal. This is given to be 45 degree. This is given to be theta. If refractive index of the material of the prism is √2, and here emerged ray is grazing, So this angle is grazing along second surface. This is 90 degree. As in the previous problem, this is coming to be 45 degree because critical angle is 45 degree, R2 is 45 degree. Come on. Now, it is given that incident ray is parallel to the base. This is the base, parallel to the base. So, using law and transverse angle, this will be 45. So, this will be 45 degree. This is normal. This will be 45 degree. This will be 45 degree because these two angles are alternate angles. Therefore, this is 45. This will be 45. This will be 45. Therefore, this is normal. This will be 45 degree. And this is R1. This is R1. Now tell me, at the first surface, mu is equal to root 2 is equal to sine I1 divided by sine 45. It's a very common thing. We can get I1 is 30 degree. I1 is this is 30 degree. I1, not I1. R1 is 30 degree. Sorry, when I made a mistake. Mu is equal to root 2 is equal to sine I divided by sine R1. Sine I is sine 45, that is 1 by root 2. Then this is sine R1, and working we will be getting R1 is equal to 30 degree. Now again third or fourth time we are using angle of prism is equal to R1 plus R2. That is coming to be angle of prism is equal to R1 is how much you got it? 30 degree plus R2 is 45 degree. This is coming to be 75 degree. So angle of prism is coming to be 75 degree. Is coming to be 75 degree. Now, tell me, in a triangle, sum of all the three interior angles are how much? 180 degree. What are the angles? 45 degree plus angle of prism is 75 degree plus theta. That comes to be 180 degree. Therefore, theta is coming to be 180 minus 45 plus 75. That comes to be, theta is coming to be 180 minus 120. That comes to be 60 degree. So, using the same concept, R1 plus R2 is to A, and critical angle is equal to the angle of refraction. This idea is coming in 3-4 problems it has come. So, many things repeated that manner. Okay, your answer is coming to be fourth, and fourth is the correct option here. Now, we go to the next question. A collimated beam of light of diameter 2 millimeter is propagating along x-axis. Diameter of the lens. The beam is required to expand in a collimated beam of diameter 14 millimeter using a system of two convex lenses. The first lens has a focal length of 40 centimeter, then focal length of the second lens. Okay. Now, come on, I'll draw that. Parallel beam of light is coming, and collimated beam means a parallel beam, and emerged beam is also collimated. So, I can draw the diagram. A parallel beam of light rays are coming, okay? Yes. A parallel beam of light rays are coming, and we know they will be converging to their focus. And again they are forming on the second lens. From second lens, they go parallel. Coming as a collimated beam, going as a collimated beam. Okay. So, when light rays are coming parallel, they will be meeting at their focus. That is focus of first lens. And for the light ray to go parallel, according to the definition, this is the second focus of first lens. It becomes first focus of the second lens. So light rays will go parallel, or we say use the word collimated beam. So this distance is coming to be F1 and F1 and F2 is coinciding. F1 is coming to be how much? Using two convex first lengths of focal length, this is 40 centimeter. Okay, 40 millimeter. Okay, 40 millimeter. Now, this is also the focus of first focus of second lens. So, this distance should be equal to focal length of the second lens. You have to calculate the focal length of second lens f2. Now, tell me if this angle is alpha, this is alpha. Okay, vertically opposite. Or this is also alpha. This is also alpha. For first triangle, tell me for first triangle, this is we have to draw it in the here we have to draw it. This we have to draw it. Actually, we have to draw it here. So diameter is how much? 2 millimeter. So this is coming to be 1 millimeter. Here diameter is 14 millimeter. So this is coming to be what? 7 millimeter. Okay. Yes. What about here? Tan alpha. Tan alpha is equal to 1 divided by how much? 40. This is 40. Second case, tan alpha is equal to 7 divided by f2. First case, tan alpha is 1 divided by 40 because this is 40, this is 1 millimeter. Second case, f2 we have to calculate, this is 7 millimeter. Now, equating it, 1 by 40 is equal to 7 by f2. Therefore, f2 is equal to 7 into 40, that is equal to 280 millimeter. Your answer is 280 millimeter. Answer is coming to be, let us check the correct in the answer sheet given. Yes, it is 280 millimeters, correctly given. Now we go to the last question. Microscope focal length having f4 is 2 centimeter, eye lens having focal length 4 centimeter, tube length is 32 centimeter, magnification produced by the microscope. The easiest problem of this question paper, direct problem, but 2 or 3 questions have come from microscope. We have direct formula for magnifying power, L by FO into D by FE. L is length of the tube that is given to be 32, FO is 2, D is 25 centimeter. This is coming to be 16 into 6.25, that is coming to be 100. Okay. Now, all the questions, okay. Some questions have given repetition 2-3 times. So take care of that questions. Okay. Bye.
Repetition of the earlier problem that we did. Only earlier problem mu is asked. You know the formula? T into mu minus 1. We did. Is equal to number of bands by which is shifted. M. M is given here. There is 20 micrometer something. Here it is shifted by 0.2 centimeter. 0.2 into 10 raised to minus 2 by, if this is polarizing angle and this is a theta is equal to y. If angle of incidence is polarizing angle, you know I plus R is equal to 90 degree. N1 bright forms here. And second one is lambda 2. And this N2. And 2th bright forms there. Since the location is the same, we can say the path difference from here and there for both the wavelengths must be same. And hence we can write N1 lambda 1 as far as this point is concerned. N1 lambda 1 is equal to N2 lambda. Welcome, my friends. This is Professor P. C. Thomas and Chaithanya Classes. And in this video, we are going to discuss the last session questions from the optics, semiconductor, and experimental technique. We start with the very first question is there on the board. A beam of light consists of wavelength 650 nano and 550 nano illuminated the Young's double slit experiment with the separation of 2 millimeter, that the interference fringes are formed on the screen, placed at a distance 1.2 meter from the slit. The least distance of point of the central maxima, where the bright fringe due to both the wavelength coincide, is given by. Now this is the experimental setup, and this is the screen, and it is illuminated by two wavelengths, so that it is said that there on a point on the screen, suppose this is the point on the screen, these two wavelengths forms their respective maxima. Say the first wavelength of lambda 1 and is n1, n1th bright forms here, and second one is lambda 2 and is n2, and 2th bright forms there. Since the location is the same, we can say the path difference from here and there for both the wavelength must be same. And hence we can write n1 lambda 1 as far as this point is concerned. n1 lambda 1 is equal to n2 lambda 2. Next, the one which has got wavelength larger, the order is small. Therefore, n1 into the first wavelength is given is equal to 650. Therefore, 650 equal to n2 into 550. From this, n1 by n2 is equal to 550 by 650 is equal to 11 by 13. From this, 13 n1 is equal to 13. That is 13th bright of lambda 1 happens here. Or, I'm wrong. 11th, n1 is 11. The 11th central maxima of bright fringes forms here. Or, for lambda 2 is 13th bright forms there. And hence what is, now the question is, the least distance from the point of central maximum. This distance is how much? Question is that, what is that distance? This distance. This occupies 11 bright fringe bands of lambda 1 or 13 bright fringe of bands of lambda 2. Or now we can say, therefore, what is this distance? This distance, suppose I say y is equal to either 11 beta of lambda 1, that is equal to d by d lambda 1, or it is same as 13 d by d lambda 2. Both are same. Suppose here we are using this relation 11 into capital D distance from here to here. It is given in the problem 1.2 distance 1.2 meter. This is 1.2 is equal to 1.2. The lambda 1, that is equal to 650 nano, 50 into 10 raised to minus 9 by D, the distance between the slits, that is the 2 millimeter, separation 2 millimeter, 2 into 10 raised to minus 3. This value on computation is equal to 429 into 10 raised to 5. Minus 5. So it's equal to, here the answer is equal to 429. Okay. Now we shall go to our next question. Given below two statements, a plane wave after passing through a prism remain as plane wave, but passing through the small pinhole may become a spherical wave. Statement is correct because when it passes through a prism, only deviation take place. A wave coming here go like this, plane wave. So there is a bending towards the base. Second base, if it is a very small slit, it acts as a point source. From point source, spherical wavefront emerges out by Huygens theory. And this statement is correct. Now come to second statement, curvature. Curvature is the reciprocal radius of curvature. Curvature of a spherical wave emerging from a slit. And you know beta is equal to d by a lambda by diffraction. Now from this, if A increase in the slit width, when A increases, beta value decreases. Beta value decreases, beta becomes more flatter. And therefore, because curvature spherical wave emerging from slit increase, it becomes more flatter, my radius of curvature increases, curvature decreases. But here said that it increases. Therefore, this statement is wrong. And correspondingly, the answer 3. Okay, next question. In young double slit experiment, the intensity produced by each wave of individual slit is I0. Single slit intensity is I0. The distance between two slits is 2 millimeter. The distance of the screen from the slit is 10 meter. The wavelength of light is 6000 angstrom. The intensity of light on the screen in front of one of the slit. Now we can say, suppose these are the two slits. And this is the screen. And this is the point in front of one of the slit. Now intensity from here is I0, from here is also I0. It is set. Now the question is the intensity of light at this point. Now distance, suppose x is equal to, suppose this is d and this is d by 2 and this is capital T. Capital T. Now we have to find the intensity there. Before that we have to find the path difference. Now path difference from here and here on reaching here to a point that it is x from the equidistant point. You know the general formula there, path difference is given by d by dx. So the base formula for path difference. So that on calculation is equal to, so here x is equal to d by 2. So it's equal to d into d by 2 by d into d square by 2. This is the path difference. Now convert that into phase difference. Now corresponding phase difference phi equal to 2 by lambda into path difference d square by 2d. You will cancel out. It's equal to pi d square by lambda d. 2 pi by lambda into x. This is given by this distance. It's given by d square by 2d. And this is the phase difference. Now you calculate the phase difference here. It's equal to pi into small d, the distance between the slits. It is given to 2 millimeter. 2 into 10 raised to minus 3 by lambda. The wavelength of the light used is given there 6000. 6000 into 10 raised to minus 10 into capital D, distance from the slit to the screen, 10 meter. 10. This value on calculation is given by 2 pi by 3 or 120 degree. That is the phase difference. Then what is the intensity there? At any point on the screen where the phase difference is pi, intensity is given by formula I am writing 4a square or 0, not this I0, not this I0. 0 cos squared pi by 2. This is the formula. So in our answer, I equal to I0, the maximum intensity due to superposition 4a square, that is equal to 4 I0. Instead of this I0, in our expression it is 4 I0 into cos squared 120 by 2. 120 by 2 means cos 60. Cos 60 is equal to 1 by 2, square is 1 by 4. This will cancel out and therefore intensity become iso. Therefore the option is equal to pi square. Okay, next question. An unpolarized light is incident at an interface of two dilated media having refractive indices 2 and incident medium and 2 root 2 medium respectively to satisfy the condition that reflected and refracted rays are perpendicular to each other, angle of incidence. Now this is the first medium, refractive index is 2, and whereas this is the denser medium 2 root 2 refractive index. Now a ray that incident here, and it is that the reflected and refracted rays must be 90 degree, mean the incident angle must be polarizing angle. This angle means angle of polarization, Bragg-Brewster's law. Now angle of incidence is asked. Now if theta is the angle of incidence, then tan theta, the relative refractive index is given by n2 by n1 is equal to root 3. And therefore theta is equal to 60 degree. So option is equal to. Okay. Next question comes to, when unpolarized light fall on a particular angle on a glass plate placed in air, it's observed that the reflected beam is linearly polarized. The reflected beam is fully polarized. The angle of refracted beam with respect to the normal is. Now, again, as we discussed in the last problem, reflected light is fully plane polarized, means angle of incidence is polarizing angle. And if angle of incidence is polarizing angle, like this. If this is polarizing angle and this is R, theta is equal to Y. If angle of incidence is polarizing angle, you know I plus R is equal to 90 degree. In our problem, I plus R is equal to 90 degree and I is given to you. $57. 57.7 plus R is equal to 90. This finds the value of R. The value of R is equal to 32.3. Okay. Two separate young double slit experiments set up. And two monochromatic light sources of different wavelength are used to get fringes of equal width. The ratio of the slit separation and that of the wavelength of light used 2:1 and 1:2 respectively. Then the corresponding ratio of the distance between the slit respective sources d1 by d2. Now it is given that equal width, fringes are of equal width. Beta is equal to beta, or beta 1 is equal to beta 2. What is the form d1 beta? D by d lambda is equal to d2 by d2 lambda 2. They are the same. And the question is d1 by d2. So d1 by d2 from here is equal to d1 by small d1 by d2 into lambda 2 by lambda 1. Now the ratios are given to you. The ratio of the slit separation, that is d1 by d2, is equal to 2 by 1 into wavelength ratio used is equal to 1 by 2, again 2 by 1. One reciprocal is equal to 2 by 4. And hence the answer here is equal to 1 by d2. Which are the following true for a single slit diffraction? Now width of central maxima. Now what is the width of central maxima when diffraction take place through a small hole is this one is equal to 2 into d by a lambda, where a is the width of the slit. Now, width of the central maximum increases with the increase of wavelength. Definitely, you can say when lambda increases, width increases. When lambda increases, width of the central maxima increases. So, width of the central maxima increases with the increase of wavelength. Width of the slit constant. No. Keeping when lambda increases, bandwidth increases. So, this statement is correct. Width of the central maxima increases with the decrease of wavelength. That statement is wrong. Width of the central maxima increase with the decrease in slit at a constant wavelength. When lambda constant, when slit width with the decrease of slit width, when slit width decreases, the numerator decreases, bandwidth increases. Therefore, bandwidth increases. Here, what is when slit central maxima with the decrease in slit width, central maxima increase with the decrease of slit width. So that is true. When this decreases, beta value increases. So this is true. Width of central maxima increase with the increase in slit width. That statement is wrong. Brightness of central maxima increase or decrease in wavelength of the slit width. When brightness of central maxima increase, now brightness, the intensity allowed through this A depend on that width. When that decreases, intensity decreases. But when A decreases, bandwidth increases. And therefore, this intensity allowed through this must spread over larger area and our brightness decreases. So brightness of central maxima increase or decrease of wavelength at a constant width. That statement is definitely wrong. Reason, when this decreases, central maxima increase for decrease in wavelength. Oh, sorry, our statement is wrong. Brightness of central maxima increase or decrease in wavelength at a constant slit width. If the slit width is constant, number of photon allowed is the same. Number of photon allowed is the same. Intensity, energy carried by that number of photon n into hc by lambda. When lambda decreases, energy of each photon increases, and therefore energy of the photon increases, and therefore brightness of central maxima increase for decrease in wavelength. When lambda decreases, energy increases, and therefore brightness increases. Here statement brightness of central maxima increases, therefore that is true. Therefore, A, C, and E. That statement is not there. A, C, and E are correct. So that statement is wrong. Correct option is not there, but A, C, and D are correct. Width of the central maxima increase with the decrease of when A decreases, bandwidth increases. So that statement is correct. But there I only give the answer as D, which is wrong. Okay. Young Delphi setup, the two slits are kept 0.4 millimeter apart and screen is placed 1 meter away from slit. If a thin transparent sheet of thickness 20 micrometer is introduced in front of one of the slit, then the central bright fringe shifted by 20 millimeter on the screen. The refractive index of the transparent sheet is given by alpha by 10, then where alpha is. Now this is our experiment setup. These are the two slits. This is the screen. Now this is the equidistant bond. When slit is kept one of the path of one of the path of one beam of the one of the slit. Now it is given that this equidistant bond is shifted to this bond. It is shifted by M bands. Equidistant bond, this is the earlier M band. Now this is the equidistant bond and this is the mth band once it is introduced. Therefore, the path difference between the two beams If the slit is not there, it's called m lambda. That means when you introduce this slit, what will happen? The equidistant bond shifted by m bands, so that the path difference is equal to m. M is the number of bands by which it shifted. Here that is given m bands. And next data, the path difference introduced when a slit of thickness T and refractive index is introduced, do T into mu minus 1. So path difference again is equal to T into mu minus 1. Where mu is the refractive index of that sheet, T is the thickness. Equating T into mu minus 1 is equal to m. Now, we have to find the number of bands by which the equidistant bond shifted, the value of m. To calculate m, now in the problem it is given that the central point difference shifted by 20 millimeters. So this distance is 20 millimeter. And if bandwidth is beta, number of bands by which it is shifted is given by distance moved 20 millimeter, 20 into 10 raised to minus 3 by beta. Is equal to 20 into 10 raised to minus 3 by 1 bandwidth. Bandwidth is equal to d by d lambda. D by d lambda is equal to 20 into 10 raised to minus 3 into small d. Small d, the distance between the slits. Two slits are kept 0.4 millimeter apart. But small d, 0.4 into 10 raised to minus 3 by capital D. Capital D, 1 meter from the slit. 1 meter. So 1 into wavelength of the light used. And that is the lambda. Say lambda. Wavelength of the light used. So this is our value of m. Substitute here. Substituting in this equation the value of this m. Thickness is given by a sheet of thickness 20 micrometer. 20 into 10 raised to minus 6 into refractive index n or mu minus 1 equal to m 20 into 10 raised to minus 3 into 0.4 into 10 raised to minus 3 by lambda into lambda. Lambda will cancel out. The only unknown is there mu. Compute. The calculation of mu give you the value 14, and here is the 1.4, that is written as 14 by 10. And they were comparing alpha is equal to 40. So alpha is equal to 40. Okay, next question. Given below, there are two statements. Statement in young double slit experiment, the angular separation of the fringes will increase as screen is moved away from the plane of the slit. Now we know angular separation, beta by d is equal to lambda by d. This is the angular separation. Angular separation of the fringe will increase as screen is moved away from the plane of the, this is the angular separation. Do not depend on capital D. And there the statement is wrong. First statement is wrong. Linear separation increases, but not angular separation. In young double slit experiment, the angular separation of fringe will increase when monochromatic source is replaced by another monochromatic source of higher wavelength. Lambda increases, angular bandwidth increases. Therefore, this statement is correct. Therefore, option is 4. Next. In double slit experiment, the distance between the two slits is 0.1. The screen is placed at 50 centimeter from the slit plane. When one slit is covered with a transparent sheet having thickness T, refractive index 1. The central fringe is shifted by 0.2 centimeter, the value of T. Repetition of the earlier problem. Repetition of the earlier problem that we did. Only earlier problem U is asked. You know the formula? T into mu minus 1. We did. Is equal to number of bands by which is shifted. M. M is given here. There is 20 micrometer something. Here it is shifted by 0.2 centimeter. 0.2 into 10 raised to minus 2 by beta. Beta is equal to d by d lambda. D into lambda by capital D placed beta. Here we have to write beta. That is our M. M lambda into lambda. This is the way. That is equal to 0.2 into 10 raised to minus 2 by beta is equal to d by d lambda. D is 0.5 into lambda. Small d, the distance between the screen and slits, that is equal to 0.1. 0.1 into 10 raised to minus 2. This is our M into lambda. This will cancel out. Our thickness is as refractive index is 1.5 minus 1. So it's a repetition question. Now from this find the value of T. T on calculation, the value is given by 8 into 10 raised to minus
3 into 10 to the power of minus 19. So this is for one photon. This is n photons per second. So n into 3 into 10 to the power of minus 19 will give you energy per second. But energy per second is given to be 6 into 10 to the power of minus 3. From here, we can come to the end. You know the photoelectric equation, kinetic energy maximum is equal to h nu minus. Then kinetic energy is 0 means, it means that h nu is equal to work function. H nu is equal to kinetic energy is 0. Just not emitted. So one twist appear here, two radiations are incident. So one having maximum kinetic energy will be caused having one having maximum frequency. Let us start with the first question. First question on the board. Number of photons of equal energy emitted per second by 6 milliwatts laser operating at 663 nanometer. You have to calculate the number of. So, explanation is given very clearly. Energy of a photon, we know hc by lambda. hc by lambda. Yes, hq written, c written, lambda written. Correct? With proper units. Yes. Now, you know, this is the energy of one photon. If n photons are emitted, and this is coming to be 3.3 into 10 to the power of minus 19 joules. And power means energy liberated per second, energy liberated. That is given to be 6 into 10 to the power of minus 3 joule per second. And we want the number of photons emitted per second. One photon's energy we calculated to be 3 into 10 to the power of minus 19. Let n photons are emitted per second. So total energy will be what? N into that one step I am writing 3 into 10 to the power of minus 19. So this is for one photon. This is n photons per second. So n into 3 into 10 to the power of minus 19 will give you energy per second. But energy per second is given to be 6 into 10 to the power of minus 3. From here, we can come to the end. That is P divided by E. That comes to be 2 into 10 to the power of 16. Your answer is coming to be option 2. Okay? Very easy question, commonly asked question. Other one, ratio of the de Broglie wavelength of a deuteron of kinetic energy E to that of a alpha particle of kinetic energy 2E is n:1. So it's an easy question. De Broglie wavelength in terms of energy. I'm not going to explanation part. Lambda is equal to h by in terms of energy. So we have 2 into mass into energy. Now we have to compare the ratio of deuteron. So lambda deuteron will be h by root of mass of deuteron. We can take it to be 2. Energy is given to be E. Lambda alpha particle h divided by root of 2. M is 4. In terms of 4, I am writing 4 only because we are comparing into 4E is into energy is given to be how many? 2E. Okay. Then lambda deuteron divided by lambda alpha, cross multiplying h by root of 2 into 2, 2 into 2 into E. Here root of this is 16. This is coming to be 2 into 4 into 2E. That comes to be 16E divided by H. H is it cancel. Lambda D divided by lambda alpha is equal to root of 16 by 4. Root of 4, that comes to be 2. The ratio is coming to be 2. Answer is 2. Okay. Now let us go to the, so explanation I avoided. You can directly get the answer. The third one, when a light of given wavelength falls on a metallic surface, stopping potential is 3.2. Second light is having a wavelength twice the first wavelength is used. Of course, wavelength more, energy less, then stopping potential also will be decreasing to 0.7. Wavelength to the first light is used. So we can easily do the problem from explanation. Okay, then we have stopping potential E into stopping potential is at C by lambda minus V. So first case, it is given to be 3.2 E. Okay, we need no need of writing E because we are comparing it. We can avoid writing 3.2 into V. Systematically we write it. Yes, first case. Second case it is 0.7. 0.7 E into HC by lambda. 0.7 into HT by lambda, second case. Then we have to get what? Wavelength. Lambda we have to get, we have to eliminate work function. Phi is to be eliminated, lambda is to be retained. So what we are doing? We subtract it. So phi has got, so 3.2 E minus 0.7 HC by lambda by HC minus 2 lambda. This is coming to be 2.5 E HC by 2 lambda. 1 by lambda minus 1 by 2 lambda is 1 by 2 lambda. Now, from here we have to get, now lambda is equal to H into C 6.63 into 10 to the power of minus 34, substituting and finally solving out. The wavelength is coming to be 2.48 into 10 to the power of minus 7. That's coming to be nearly 2.5 into 10 to the power of minus 7. So answer is 2.5 into 10 to the power of minus 7. That comes to be option 2. We go to the next question. Then de Broglie wavelength of oxygen molecule at 27 degree is x into 10 to the power of minus 2. We have to calculate the Boltzmann's constant is the mass of oxygen. Mass of oxygen is given to be 5.31 into 10 to the power of minus 3. You have to calculate that the de Broglie wavelength is x into 10 to the power of minus 12. X into 10 to the power of minus 12. So we start from de Broglie wavelength formula, that is h by p, h by momentum, isn't it? So h by p, that is h by mv or h by root of 2me. For a particle, energy E can be given by 3 by 2 kT. So substituting for that, this is coming to be h by root of 2 into m into energy will be 3 by 2 k. K is Boltzmann's constant. Then we are coming to this formula. This from here 2 to get cancelled, we are directly coming here. So how this h by b becomes h by root of 2me. E is replaced as the energy of a particle 3 by 2 kT. So this is coming to be h by root of 3m into kT. Now some mere substitution, everything given in black and white. H 6.6 into 10 to the power of minus 34, root of 3, mass of oxygen is given 5.32, Boltzmann's constant 1.38 10 to the power of, and temperature is 27 degrees, that corresponds. When you work it out, this is coming to be 26 into 10 to the power of minus 12. So here in place of x, who is coming? Nearly 26 is coming. Okay. We go to the next question. Now, light is incident on a metallic plate having a work function 110 10 to the power of minus 20. Produce photoelectrons have zero kinetic energy, angular frequency. So, tell me, what is the meaning of zero kinetic energy? Zero kinetic energy means the incident energy just is equal to work function. Incident energy just is equal to work function. Okay. So look, we know the photoelectric equation, kinetic energy maximum is equal to h nu minus, then kinetic energy is zero means, it means that h nu is equal to work function. H nu is equal to kinetic energy is zero, just not emitted. So this is work function, and work function is h nu. H nu we can write work function is equal to, I write here h nu. How the steps came, I writing nu. Nu is equal to angular frequency divided by 2 pi. Correct? Angular frequency, that is given here, angular frequency divided by 2 pi. Then we want angular frequency. Angular frequency is 2 pi into work function by h. So this is coming to be 2 into pi, we have taken 3.4. Work function is given to be 110 into 10 to the power of minus joule, that is 2.25 divided by h 6.63. When you work it out, this is coming to be nearly 1.04 into 10 to the power of 16. 1.04 into 10 to the power of 16. Answer is coming to be 4. Sixth question. Particle having charge 3 in 10 to the power of minus coulomb, mass 6 into, are accelerated through applying a potential difference of 1.21. Wavelength of the matter waves associated with the particle is alpha into 10 to the power of minus 12. Okay. Again, direct question. We want the de Broglie wavelength in terms of accelerating potential. Once again, I write it. De Broglie wavelength in terms of accelerating potential, h by root of 2m into VQ. We have seen 2-3 problems based on that. We have used h by me, h by root of 2me, and instead of energy we have written 3 by 2 kT. Here instead of E we are writing VQ. So this is a form of de Broglie wavelength in terms of accelerating potential. Now tell me, everything clear? Everything clear? Root of 2m into VQ is separately calculated. That is coming to be 6.6 into 10 to the power of minus 23. Then lambda will be h is 6.6 10 to the power of minus 34. This is coming to be 6.6 in 10 to the power of minus 23. That is coming to be 10 to the power of minus 11. But your option is given to be how much? Alpha into 10 to the power of. So this is 10 to the power of minus 11. We have written as 10 into 10 to the power of minus 12. to bring this format. What is that format? Yes. Alpha into 10 to the power. So who is in place of alpha? In place of alpha is 10 is coming. Okay. Yes. Answer is 10. Now, next question. I go to the explanation along with that. Light of energy 6 into sine 3 into 10 to the power of 15t plus sine 12 into 10 to the power of 15t fall on a metal surface of work function 2.8. Maximum kinetic energy of the photo work function is given. So, first of all, we have two angular frequencies. One is 3 into 10 to the power of 15 per second is there. Omega 2 will be 12 into 10 to the power of 15. Both radiations are incident. Both radiations are incident. So surely who will be causing emission more? Surely. So whose effect is to be considered? The one having more angular frequency is to be considered. So that is what 12 into 10 to the power of 15. That will be causing what? Emission of photoelectrons. Okay. Then energy will be, we have to calculate the energy is equal to h nu. But nu we don't have, we have omega. So h nu is given to be h, we want, this is not h omega, we want h nu, h nu. H omega by 2 pi, that is coming to be nearly 12.6 into 10 to the power of minus 19 joules. And when we convert it into electron volt divided by 1.6, so that is coming to be 12.6 into 10 to the power of, that is coming to be nearly 7.8. So we got incident energy is coming to be 7.87 in electron volt, and work function is given to be in what unit? 2.8 electron volt. Therefore, we have to calculate maximum kinetic energy of the photoelectrons emitted. That comes to be h nu minus work function 7.87 minus 2.8. That comes to be 5.07. That is nearly 5.1 electron volt. The option is fourth option. Okay. Very direct question. So one twist appear here. Two radiations are incident. So one having maximum kinetic energy will be caused having one having maximum frequency. One is having angular frequency 3 into 10 to the power of, second is 12 into 10 to the power of 15. Surely one with more frequency will be causing more kinetic energy of emission. So we have to count for that. Second thing, we want energy. Energy, we remember h nu, but here it is omega. So we converted into h into omega by 2 pi. That value is coming to be 12.6, but work function is given in electron volt. We have changed it to electron volt 7.87. Now simple equation Einstein's formula, that energy of the emitted photoelectrons, maximum energy is equal to 7.87 minus work function is 2.8. We got 5.01, nearly 5.1. Okay. So first you get orbit number, then L is equal to NH by 2 pi. So we want 2 pi L by NH. Then 2 pi by L by H will be equal to, L is equal to 5H by 2 pi. Therefore 2 pi into L by H will be 5. So answer is 5, option 2. Both of them, the radius of the orbits are nearly same. And radius formula is what? R0 n square by z. Kinetic energy of, that is, alpha particle stops for a moment and then retraces. So at distance of closest approach, alpha particle stops for a moment and it is reaching maximum close to nucleus. Entire kinetic energy becomes 0. Questions from atoms. questions from atoms. The questions are not difficult questions. Okay. And we have given weightage from almost all the chapters. So here the weightage is given from near about 5 or 6 questions are there. We'll go to that question. 2 electrons are moving in orbits of hydrogen-like atoms with speeds 3 into 10 to the power of 5 and 2.5 into 10 to the power of 5 meter per second. Radius, these orbits are nearly same. Okay, then possible order of energy. So I'm not going to the explanation given in the explanation material. I think somewhat easy way of doing it. Velocity of electron, we might have heard about a formula, C alpha by N into Z. C is a constant, alpha, C is velocity of light, alpha is constant, we call fine structure constant, N is the energy level orbit number, and Z is the atomic number. Now here, 2 cases of velocities are given, one is 3.8 and other is, okay. So I can say V1 by V2, C alpha is a constant, it will be N2 by N1 into Z1 by Z2. So first equation for velocity, we got the relation V1 by V2 is equal to N2 by N1 into Z1 by Z2. Okay. Then V1 is given to be how much? 3 into 10 to the power of 7. So 3 into 10 to the power of 5 divided by 2.5 into 10 to the power of 5. That comes to be 3 by 2.5. That comes to be 3 by 2.5. That comes to be 6 by 5. 6 by 5 is coming to be N2 by N1 into Z1 by Z2. I want the ratio of N1 by N2. Now second regarding radius, both have same radius. Both of them, the radius of the orbits are nearly same. And radius formula is what? R0 N square by Z. So I am equating the radii R0 N1 square divided by Z1 is equal to R0 N2 square divided by Z2. Okay, from here we will be getting N1 by N2 whole square. That comes to be, because radius are equal, therefore I equated N1 by N2 whole square. That comes to be Z1 by Z2. Equation number 2. In equation number 2, instead of Z1 by Z2, I am replacing this. What is that? N1 by N2 whole square. Therefore, I have from the equation, this is equation 2. This is equation 3. From equation 2, 6 by 5 N2 by N1 into Z1 by Z2. Z1 by Z2 is also N1 by N2. This is N1 by N2 whole square. So 6 by 5 is coming to be N1 by N2. And what is asked you? The radii of these orbits are nearly same, then possible order of energy states are there. What are they? First one is 6, second is 5. So this is the answer. Fourth one is the answer. Okay, this is the easiest way of doing it. Easiest way of doing it. Here, I have given a velocity equation in terms of fine structure constant. So that is a convenient way. So answer is 6 and 5. We go to the next question. Tell me electrons moving in. So this we have done it. So this is explanation part. We come to the second one. Here also, look, maximum wavelength of radiation of energy lambda by 3 by 4. That's a correct option. We can refer 1 by lambda is equal to R into, this is Lyman square, means 1 by 1 minus 1 by 2 square. This is a correct option. Then Balmer series lies in the visible region. Anyway, here we accept it as correct because it's not completely invisible region. This is partly invisible region and partly in mostly 90% invisible region. So for practical point of view, we take this as also correct option. Then minimum wavelength of the radiations in fashions, minimum wavelength is maximum energy. What is the transition? 1 by lambda is equal to 1 by R is equal to which orbit? Fashion, that is third one, that is 3 square minus 1 by infinity. That gives you lambda is equal to 9 by R. That gives you lambda is equal to 9 by R. So that option is also correct. So A is correct, B is correct, C is correct. And B, I told you that limitation. Minimum wavelength of Lyman series, that is not. Minimum wavelength of that, everybody remembers it. Minimum wavelength of Lyman series is 1 by R, and that is nearly 912 amp strength. Due to the continuous use, we are remembering it. So that option is wrong. So what options are correct? A correct, B correct, sorry, D is wrong. A correct, B correct, C correct. So this is the one. Fourth one is correct. Okay. We go to the next one. This is explanation I given you in an easy manner. Come on. Alpha particles from target material of atomic number 79. We have to calculate the estimated diameter of the nuclei. So this is a calculation based on distance of closest approach. We have a ready-made formula. At distance of closest approach R0, kinetic energy of, that is, alpha particle stops for a moment and then retraces. So at distance of closest approach, alpha particle stops for a moment and it is reaching maximum close to nucleus. Entire kinetic energy becomes 0. Kinetic energy is converted into electrostatic potential energy. K is equal to 1 by 4 pi epsilon 0. Charge of alpha particle 2e. Charge of nucleus is ZD. Isn't it? Okay. Now here Z is given to be 79 and we calculate this mere substitution. All the values are clearly given. This is coming to be 2.88 10 to the power of minus 14 meter. This is distance of closest approach. You know that the radius of nucleus is surely more than that. Surely distance of closest approach is not exactly not equal to the radius of nucleus, but it is a measurable, linear measurable limit of size of nucleus. So we got an idea that is in the order of 2.88 into 10 to the power of minus 14. Surely it is more than that. Surely it is more than that. Now we have to calculate the diameter. Diameter will be twice that of the radius. That is coming to be 2 into 2.8. That is 5.76 into 10 to the power of minus 14. 5.76 into 10 to the power of minus 14. So that is the most. I told you it should be even more than that. More than that. Tell me, let me come to the options here, given here. What are the options given? One is 1.69, but this much will not be. It will not be nucleus order. 2.88 radius, this cannot be. This cannot be surely. 5.6 is double the radius, distance of close approach. This is the possible value. And this cannot be also the possible value because it should be in the order of 1 to 10 Fermi normally. not more than 10 Fermi. So this answer is also not possible. Then this is the possible answer. Next question. Tell me, energy of an electron in orbit of Bohr's atom is 0.064. This is energy. E0 is the ground state energy. Then we have to calculate the angular momentum. We know energy of nth orbit is equal to minus E0 by square. Minus E0 by n square. And this is coming to be minus E0 point, what is 0.04? That comes to be 4 by 100. 0.04 means 0.4 by 100 into E0. Minus get cancelled, E0 get cancelled. N square is given to be 100 by 4, that is 25. Or N is coming to be 5. And what is the question asked you? Angular momentum. Angular momentum is an integral multiple of h2 pi. h2 pi, isn't it? Then N is coming to, so we have to calculate what? The L is angular momentum of electron, h is the Planck's constant. Then we have to find the value of 2 pi L by h. This is, N is 5. So we know L is equal to 5h by 2 pi. We have to get what value? 2 pi L. 2 pi L divided by h. 2 pi L divided by h is coming to be 5. So first you get orbit number, then L is equal to nh by 2 pi. So we want 2 pi L by nh. Then 2 pi by L by h will be is equal to, L is equal to 5h by 2 pi. Therefore 2 pi into L by h will be 5. So answer is 5, option 2. So explanation is given. So we have given a little bit simple explanation. Then alpha particle of energy 7.1 is bombarded with thin gold foil. Distance of closest approach. The same problem. Second problem is asked about distance of closest approach. Very direct problem. You know, entire kinetic energy is converted into the potential energy. R0 is 1 into 2 Z square. Substituting, we are getting distance of closest approach is coming to be 2.95 into 10 to the power of 5 s 2.95. The answer is coming to be 2. Answer is coming to be 2. Second option is given there. Okay, mass number is same 3, but atomic number different, nuclei different. One is helium and another is helium. Okay, that is a correct answer. Let us check any more are there. Uranium 236 and 238. They are isotopes, not isobars. Radius is equal to R0 into Rutherford's formula. Rutherford's formula is this. Now, very direct application of the Rutherford's formula. When mass number increases, binding energy increases. 30 to 170 mass number, binding energy per nucleon is more or less same. Further, heavier nuclei, when mass number increases, when nuclear mass increases, binding energy decreases. Now we are coming to the questions from nuclei. Some questions I am directly writing on the, and some I am taking the help of the explanation chart. So if we take explanation chart, we have the advantage of avoiding so many calculation, but method I am explaining in detail. Come on. Radius has mass number alpha. Radius, that's R alpha. Another nucleus has beta. Radius is R beta. If beta is 8 alpha. So very direct question. Radius is equal to R0 into 8 to the power of 1 by 3. Radius is equal to R0 into Rutherford's formula. Rutherford's formula is this. Now, very direct application of the Rutherford's formula. Now tell me, R is equal to, first R alpha, first one. R0 is same for both of them. Then what about mass number given? Mass number is alpha whole to the power of 1 by 3. R beta is are 0 into beta to the power of 1 by 3, Rutherford's formula. Then I want R alpha by R beta. R alpha by R beta is coming to be alpha by beta whole to the power of 1 by 3. But what is given to you? Beta is given to be 8 alpha. So I am going to make a substitution. R alpha divided by R beta is equal to alpha divided by, instead of beta I can write 8 alpha whole to the power of 1 by 3. That comes to be 1 by 8 to the power of cube root of 8. That comes to be 1 by 2. Therefore, R alpha by R beta, that comes to be 1 by 2. 1 by 2 is equal to 0.5. Yes, the second option is there. It's a very direct question. And this formula, that is the relation between radius and mass number, is very commonly, very frequently asked, isn't it? So be ready with that. Very simple. And you can make out the beauty of this question, why we are getting within the bracket, we are getting a perfect cube. We are getting 1 by 8. Coming a perfect cube coming itself is an indication that we are going in the correct way. Go to the next question. Okay, I am avoiding explanations. Now tell me, atom X35 is bombarded with shower of fundamental particles in 10 seconds, absorb 10 protons, 10 electrons and 9 neutrons. Okay, percentage grows in the surface area. So surface area I am writing A, that is 4 pi r squared. R is the radius. So you have to get the nuclear radius, isn't it? And again we are using the formula, nuclear radius is R0 into 8 to the power of 1 by 3. Isn't it? Here first case, mass number is 8. Second case, A dash. It is absorbed 10 protons and 9 neutrons. So mass number increases by, so 8 plus 10 plus 9. Mass number increases by 19. New mass number becomes 27. Therefore, R dash is equal to R dash into A dash to the power of 1 by 3. Therefore, R dash by R is equal to A dash by A whole to the power of 1 by 3. A dash by A dash by A dash is coming to be 27, A is coming to be 8. I told you this is coming beautifully. Both numerator and denominator are perfect cube. Answer is coming to be 3 by 2, that is 1.5. Then tell me, we have to calculate percentage growth in area. So tell me, A dash by A will be equal to R dash by R whole square. That comes to be 1.5 square. That comes to be 2.25. And according to the question given, percentage growth of area, we want A dash minus A by A into 100. We want percentage increase in area. A dash minus. From this, how do you come to this? We have to subtract 1 into 100. This is in mechanics in almost all chapters, this percentage change calculation is coming. Now it has come in nuclear non-mechanical chapter also, it has come calculate the percentage change. So we have A dash by A is equal to 2.5. To get percentage change, subtract 1 into 100. That comes to be 125%. But unluckily, in the options, there is no such answer given. So I think we have to correct it. This is correct answer is not 225. This must be one. That might be no other possibility we are not finding here. It will be 125%. Okay. Now we go to the next question. Come on. Look here, binding energy of the nucleus nuclear reaction. first nuclear reaction. 2He3 is becoming 2He4, absorbing, fusing with neutron, it becomes 2He4. And it releases 20 MeV of energy. And it becomes tightly bound. So more the energy it is releasing, more tightly bound, more tightly bound. So compared with 2He3, the 2He4 is much stable, okay, because it is emitting much more energy, 20 MeV of energy is being emitted, makes more stable, more tightly bound. Now come to the second case. Here it is minus 0.9. Minus 0.9 means ultimately what? 2He4 absorbs, correct? Absorbs what? Sorry, not 2He4. 2He5 is absorbing. Absorbing means what? It is that much not. So again, compared with 2He4, 2He5 is absorbing. 2He5 is absorbing. So that is not emitting. So this is less tightly bound than. So compared with the 2He4, 2He5 is absorbing energy. So it is less tightly bound. So compared with 2He4, 2He5 is less stable. But it is not less stable as what? 2He3. You know, 2He3 is, in the case of 2He3, 2He4 is rejecting 20 MeV of energy. So it is release much energy. So compared with the 2He3, 2He4 is very stable, very tightly bound. But here, one thing is clear, since 2He5 is absorbing energy, not emitting energy, so it is compared with the 2He5 is less stable than 2He4, no doubt about it. Less stable than 2He4. But it is absorbing only very few, less than 1 MeV energy, 0.09 MeV, less than 1 MeV of energy. So it is not what? Less stable as 2He3. So who is having most stable? 2He4, that is X4. Then comes 2He5, so greater than X5, greater than X3. So this is fourth option is correct. So logically we have to come to the argument. Okay, now again, two statements are given. Statement one, 4 elements greater mass of nuclear, greater the binding energy per nucleon. So when nuclear mass is getting more, nucleus is becoming less stable. Isn't it? Less stable. So statement 1 is not a correct statement. What is statement 1 saying? For all elements, greater the mass of nucleus, greater is the binding energy per nucleon. Some cases we have seen that binding energy curve for up to mass number 30, when mass number increases, binding energy increases. 30 to 170 mass number, binding energy per nucleon is more or less same. When further heavier nuclei, when mass number increases, when nuclear mass increases, binding energy decreases. So we cannot make a jurisdiction for all nuclei. Of course, in that point of view, statement 1 is false. Statement 1 is false. Now, second statement, for all elements, nuclei with less binding energy per nucleon transfer to nucleus gaining energy per nucleon. So tell me, in what process fusion happens, those nuclei with less binding energy per nucleon, with those who are coming up to the mass number 30, they have binding energy per nucleon less than 8 MeV per nucleon. So they have a tendency to fuse into moderate range of nuclei so that they can become more stable. That is their motive. motive in fusing. So who are fusing? One having less binding energy per nucleon, less mass number. So what about this statement says for elements with less binding energy per nucleon, they will attempt to fuse together to form a nucleus of large binding energy per nucleon. They will come to more stable state. So statement 2 is correct. 1 is wrong, 2 is correct. Statement 1 is wrong or false, 2 is correct or 2 is true. So third option is the correct one. Next one. Yes, average energy release per fission for nucleus of 95, 92 to 35 is 190 MeV. And all the atoms of 17 grams of uranium undergo fission process. Energy release is alpha into 10 to the power of T. That is also easy one. Look, tell me, one atom uranium 92 to 35 releases 190 MeV. Equation number 1 is 47 grams. So, 1 mole means how many gram? 235 gram of uranium 92. Isn't it? And it is given that 1 mole contains 6 into 10 to the power of 23. Therefore, 47 grams 47 grams is equal to how much? 1 by 235 into 47. And that is exactly divisible. That comes to be 1 by 5. 47 into 5 is 235. 175. And 1 mole contains Avogadro number. Therefore, 1 by 5 mole contains 1 by 5 into 6 into 10 to the power of 23 atoms. Then each atom is releasing 190 MeV. Therefore, energy released in fission of 47 gram of uranium 92 to 35 will be 1 by 5. Or this better right here, this is 1.2 into 10 to the power of atom. I worked out. So this is equal to 1.2 into 10 to the power of 3 into how much per atom? 190 MeV. So this comes to be how much? 19 into 12. 10 remaining. That's 12. 12 plus 10, 22. 228. So this is coming to be 228. 228 into 10 to the power of 23. Let us go to the question. What is that? Alpha into, this is given to be alpha into 10 to the power of 23 MeV. So we can very clearly say alpha is coming to be 228. Alpha is coming to be 228. Okay? So it's not a difficult question. We come to the next. So explanation I'm going. This we have less explanation given. Now tell me which of the following nuclear isobars. Isobars, same atomic number. Same mass number, different atomic number. Isobars, same mass number, different atomic number, different nuclei having same mass number. Let us check first one. Okay, first one. What about the first one? First one, mass number is same 33, but atomic number different. Nuclei different, one is helium and other is helium. Okay, that is a correct answer. Let us check any more are there. Uranium 236 and 238, they are isotopes, not isobars. Same element, same nucleus, same atomic number, but different. So this is not your answer. Third one, okay, they are different mass number, same atomic number, same atomic number. So this again not what? Surely not isobar. So this is not, because mass numbers are different. And here also mercury 8198, gold 7919. If we check it, we can find the different mass numbers. They are not at all coming in our category. They are not isotopes. We can find they are isotones. It is a question given in the NCERT book, if you refer that. So the question is a direct pick from NCERT. All this, they've given a discussion about isotopes, isobars, isotones, etc. In isotones example, they've given gold and mercury. So this is isotone. Only one answer correct is 1. They have same mass number and different atomic number, different nucleus. So we go to the next question. Minimum frequency of photon required to break a particle of 15.38 into 4 alpha particle is so many kilohertz. So let us find out energy released. So energy of alpha particle. So minimum photon required to break an alpha particle of mass number is 15.348. Isn't it? Mass of the products. Mass of the products. What are the products? We have 4 alpha particle. So total mass will be 4.002 into 4. That comes to be 16.008. 16.008. Okay. Now tell me delta M, mass defect or mass loss, 15.348 minus, alpha particle mass is more, that is 16.008 minus 15.348. 18 becomes 0, this is 6, this is 6. So delta M is 0.66, that is coming in AMU. Okay, now we know we need easy step. 1 AMU of mass released, energy released is 931. Here we want an approximate value, so we can take an approximately energy released is 0.66 into 1000, nearly 1000. Actually 932, but roughly we take a rough value we are taking, that is nearly 1000 MeV. So that comes to be nearly 660 watt MeV of energy. 660 MeV of energy. Okay. Now we have to calculate what? We have to calculate the frequency. H into nu, that is the energy of photon. That should be equal to 660 MeV. 660 MeV means 660 into 1.6 into 10 to the power of minus 13. Therefore, frequency is coming to be 660 into 1.6 into 10 to the power of minus 13 divided by H. H is 6.6 into 10 to the power of minus 34 given. Value of H is given. Okay. That value we can take it out. So this will be convenient way. This is coming to be, this is 100. 100 into 1.6 into, this is coming to be 10 to the power of minus 13 into 10 to the power of 34. So this is coming to be, this is 36. 36 minus 13, that is coming to be 1.6 into 10 to the power of 23 hertz. Or in the option given, let us check the options given. This is approximate value, 16 into 10 to the power of 23 hertz. We want in kilohertz. So divided by 1000. So that is coming to be 16 into 10 to the power of 19 hertz. And we have taken, instead of taking energy 932, we approximated it to be 1000. So value you obtained is slightly more. We got 16 into 10 to the power of 19 MeV. So this is coming to be a value less than that. That comes to be how much? 14.94 into 10 to the power of 19. Okay. And approximate and holds good because another 14.94, but that is 10 to the power of 20. So there is no mistake in approximating like this. Your calculation has become very quick, very easy, isn't it? Quickly. Since I explained each step, it took this much time. Otherwise, when you're doing alone, you can do it quickly. Okay. So I don't require its explanation. Okay. All the questions are over. We have completed 3 chapters today. Atoms, nuclei and radiations. Okay. Bye. So those who are writing April 2nd onwards, JEE Main examination, the second phase. All the best for them. You have now clear idea of the questions asked in the January session. Not only that, we have discussed all the papers clearly. So you can do a better performance in the April examination. Those who are doing second time, you can make it that. Okay, bye.
Net EMF. The current I is given by net EMF by total resistance. Sorry, net EMF is 12. The voltage drop across the diode. Voltage drop across the diode is this forward bias voltage. The potential barrier voltage is 0.6. So minus 0.6. Sorry. By total resistance. 0.3 into 10 raised to 3. ABCD, which you can cause the LED to glow. The LED glow only when it is forward bias. Forward bias, it means this is 1 and this terminal is 0. Then the LED will glow. PN junction diode D1 and D2 are connected as shown. A and B are input signal and C the output. The Gauss will be a function of, it is given that. Now you can see this is the standard figure that is taught for the gate AND gate. Materialization, electronic materialization of AND gate. So AND gate. There is no more much Now come to the questions from semiconductor physics. PN junction diode D1 and D2 are connected as shown. A and B are input signal and C the output. The Gauss will be a function of, it is given that. Now you can see this is the standard figure that is taught for the gate AND gate. Materialization, electronic materialization of AND gate. So AND gate. There is no more much explanation. Yes, because the standard figure to demonstrate the materialization of AND gate using semiconductor diodes. Okay, and therefore is AND gate. Now, assuming the forward bias condition, there is a voltage drop of 0.7 volt across the silicon diode. The current through diode D1 the circuit is in millimeter. Now, assume the diode or given circuit are identical. You see in this figure, here the diode, silicon diode, forward bias. This one is also forward bias. This one is reverse bias. This one is reverse bias, and that won't conduct. So conduction takes place through D1 and D3, and D2 won't conduct because it is a reverse bias. Then, assuming they have no resistance, the main current through the circuit, main current through the circuit I, the main current through the circuit I is equal to net EMF of 12 volt by total resistance here is equal to 0.53 kilo into 10 raised to 3. So on calculation is equal to 4 into 10 raised to minus 2. Whereas the ampere is equal to 4 into 40 milliampere. This is the main current. The main current now conducts through two identical resistors, and therefore by Kirchhoff's law, the current will be equally divided. The current will be equally divided through both of them. And therefore, you can see answer is correct. One thing, oh, sorry, I'm sorry. Here is the voltage drop 0.7 volt across silicon diode. And therefore, I'm wrong. You can mark like this again. Net EMF, the current I is gone by net EMF by total resistance. I'm sorry. Net EMF is 12. The voltage drop across the diode. Voltage drop across the diode is this forward bias voltage. The potential barrier voltage is equal to 0.7. So minus 0.7, sorry. By total resistance, 0.3 into 10 raised to 3. This one calculation is equal to 11.3 by 0.3 into 10 raised to 3. This, it is not a barrier voltage is required, and the net EMF is gone by 12 minus. And this on calculation, the value is equal to 18.8 into 2 is equal to 7. This value on calculation is equal to 37.6 milliampere. Now you know this main current distributed equally. The current through each branch is 37.6 by 2 milliampere. The calculation is 18.8. So the option is equal to 1. Now, next question. You are given a digital circuit. Rather than discussing the Boolean and applying the Morgan theorem, better we give the inputs. What are the inputs? 0, 0, 1, 0, 0, 1, and 1, 1. See the output. Then whichever table that agree with that is our option. That's okay. Our option checking. That's what we are doing. Give the input and see the outputs. And this is not doing. If you verify, you can say that this truth table will be true for this circuit. 0, 0 is 0, 0, 1 is 0, 1, 0 is equal to 1, 1, 1 is equal to 0. That is the result that you are going to obtain, and therefore the correct option is equal to 2. Voltage regulated circuit of Zener diode having breakdown voltage of 10 volt and a maximum power dissipation of 0.4 watt is operated at 15 volt. The approximate value of protective resistance. You can see This is our circuit, and this is our protective resistance, and this is the diode. And breakdown voltage is given to you. Breakdown voltage, that means the voltage across this is equal to 10 volt. And maximum, next one, operating voltage is equal to 15 volt. This is 15 volt. Next thing that is given, we are asked to find what is the value of protective resistance, this one. Yes. That we have to find what is the value of RS. The power is given to you. Power is equal to 0.4. The problem, it is given power is equal to 0.4. At once you can calculate power is equal to P into 1. And therefore you can calculate the value of I. I is equal to P by V. P by V on calculation. P by V on calculation. 0.4 by 10. 0.4 by 10 is equal to 0.04 ampere. This is the main current. Next, here 15 is the input voltage and output voltage is 10. Therefore, the potential drop across this one by Kirchhoff law is equal to 5 volt. And current that you got is equal to 0.04. Then what is the potential drop? Cross required is equal to 5 volt. Then what is the resistance? Again, by Ohm's law, 0.04 into Rs is equal to 5. Therefore, Rs is equal to 5 by 0.04. That value on calculation is equal to 125. The value is equal to 125 ohm. Okay. Again, repetition question is there. Now, verify the possible input 0, 0, 1, 0, 0, 1, and 1, 1, and see the output. Whichever truth table agree with this one, that is our answer. This one doing, the option is equal to 3. And next. The following diagram, there are diodes, voltage regulators, and our diode are rated at 5 volt. And the desired current is current in the load is equal to 5 milliampere. The unregulated voltage source can supply up to 25 volt. Consider the Zener diode can withstand 4 times the load current. The value of resistor Rs. Similar problem that we did. Light modification. Okay. Now the Zener voltage is given. That is the output voltage 5 volt. This is 5 volt. And Zener diode rated 5 volt and the desired current in the load is 5 milliampere. So current through load IL is 5 milliampere. Next thing in the problem is that the Zener can withstand 4 times the load current. So IZ maximum is equal to 5 into 4 is equal to 20 milliampere. It can withstand 5 times. Therefore, 5 into 4, 20 milliampere. That is our IZ value. Next thing. Load, the voltage across the load is equal to 5 volt. The current through the load is equal to 5. And that by Ohm's law, P is equal to 5 is equal to I into 5 milliampere into load resistance RL. From this load resistance RL is equal to 5 by 5 into 10 raised to minus 3 is equal to 1000 ohm. The load resistance is 1000 ohm. Here, again by second Kirchhoff law, the maximum input voltage is equal to 25 volt, 25. Drop across the or output is equal to 5 volt. Therefore, by Kirchhoff law, the excess that is going to drop across R, voltage drop across RS is equal to 25 minus 5 is equal to 21. What is the main current? Main current is equal to current through the load 5 into 10 raised to minus 3 plus current through the Zener is equal to IL plus IZ is equal to 20 into 10 raised to minus 3. So 25 into 10 raised to minus 3 ampere. That's the main current. Now, then by Ohm's law, voltage drop across the limiting resistor is 20 volt and the current through that is equal to 25 into 10 raised to minus 3. Therefore, what is the value of RS? RS is equal to voltage drop across that 20 by current through that 25 into 10 raised to minus 3. That on calculation, the value is found to be 800 ohm. So this is 800 ohm. Okay. Again, a diagram is given and what is the truth table? Again, no, not truth table. It is said that the correct truth table for which given the input data for the following logic gate is. Now you can see this as we did earlier. Now give different values for A, B, and C and D. And each truth table is verified and get the truth table which agree with this one. By trial and error, you verify A, B, C, D values, and out of this, which is found to be agree with the result. And on calculation, you can see that the option 2 agree with the results. Okay. In which our trial and error give the different possible input and see the output. Next. Find the correct relation between A, B, C. A, B, C, D, which can cause the LED to glow. The LED glow only when it is forward bias. Forward bias, it means this is 1 and this terminal is 0. That's okay. Then the LED will glow. This is 1 and this is 0. Now, out of the given options, A, B, and C, D, which one will satisfy this one? You can see that if these are 1 and 1, here it is 0, 0. 0, 0 on landing is equal to 1. So here is 1. Here 0, 0, then OR gate, it is 0. Sorry, 0, 1. It is 0, 1. If it is 0, 1, then NOR gate, and therefore this is 0. Therefore 1, 0, that is satisfies this equation. And therefore option is equal to. Now that finishes our questions. And thank you for watching this video. Once again, thank you. Zero error, you know that always subtracted from the final value. Zero error. Here zero error itself is positive and therefore you have to subtract from the final value. In what, how you find the final observed value? One main scale division 0.05. So 48 into 0.05 by number of division on the vernier, that is called 50. This is one vernier scale division. So substituting one main scale division is equal to 0.05 minus 48 into 0.05 by 50. Zero error is equal to minus 3 into least count 0.01 millimeter is equal to minus 0.03 millimeter. This is the zero error. Zero correction is always subtracted from the final answer. Now the questions are from experimental techniques. When jaws of a vernier caliper touch each other, zero mark of the vernier scale right to the zero mark of the main scale. That means, suppose this is the main scale and this is zero. Vernier scale 0 is shifted to this. Vernier scale 0 not here but here. And therefore 0 error is there. That's okay. Main scale, fourth mark of the vernier scale coincide with the certain mark on the main scale. While measuring the length of the cylinder, observer observed 15 division on the main scale and the fifth division of the vernier scale coincide with the main scale division. The measured length of the cylinder is how much millimeter? Least count of the vernier directly given to you. First of all, we have to say what is the zero error. Zero error here is equal to, now zero of the vernier not coinciding but towards the right, therefore zero error is positive. And how much division? Fourth division is at 4. In the least count is equal to 0.1 is equal to plus 0.4 millimeter. This is the zero error. Zero error, you know that always subtracted from the final value. Zero error. Here zero error itself is positive and therefore you have to subtract from the final value. In what, how you have find the final observed value? Main scale reading, coinciding, vernier scale reading, in the least count, that is our basic formula. Now the main scale reading is given to you. While measuring the length of cylinder, observe 15th division, therefore is equal to 15 plus coinciding 5th division, 5 into least count 0.1 is equal to 15.5 millimeter. This is the measured value. Now the correct value. Correct value is equal to 15.5 minus zero correction plus 0.4 is equal to 15.1 millimeter. 15.5 millimeters, option is equal to 1. Next question. In a vernier caliper, 50 vernier scale divisions are equal to 48 main scale division. If one main scale division is equal to 0.05, then least count. Basic formula of least count is value of one main scale division minus value of one vernier scale division. This is the basic definition. Here we have to calculate what is the value of one vernier scale division. One vernier scale division value is given by, in the probability given for 50 divisions of the vernier occupy 48 main scale division. So 48 into 0.05. One main scale division is 0.05. So 48 into 0.05 by number of division on the vernier, that is equal to 50. This is one vernier scale division. So substituting, one main scale division is equal to 0.05 minus 48 into 0.05 by 50. That value on calculation is equal to, this value on calculation is equal to 0.002. That is the option, 0.002 and the unit in millimeters. Okay. Next, millimeter. In screw gauge, the zero of the circle scale lies 3 division above the horizontal pitch line when a metallic stud are brought in contact. Zero error is there. Using the instrument, the thickness of a sheet is measured. If pitch scale reading is 1 millimeter and the circle scale reading 51, then the correct thickness of the sheet is. Now the situation is this one. This is the reference line. And in our problem, that zero of the circle scale 3 division above the pitch. Here is zero. And this is 3 divisions. That means here the reading is equal to 97. And this is 100 means 0. So 3 divisions above. Then, therefore, zero error here. Zero error is equal to minus 3 into least count 0.01 millimeter is equal to minus 0.03 millimeter. This is the zero error. Zero correction is always subtracted from the final answer. You know that. Now the measured value, scale reading plus scale reading in the least count. The scale reading is given. When a sheet is induced, the scale reading is 1 millimeter plus 51 in the least count 0.01. It's equal to 1.51 millimeter. This is the measured value. So correct value. Correct value is equal to 1.51 minus 0.03. 1.54 millimeter. So that is the correct value 1.54. So option is equal to 2. Okay. Using a simple pendulum experiment, G is determined. Measuring the time period T, which of the following plot represent the correct relation between pendulum length and the time period. You know, time period T is equal to 2 pi into root of L by G. Squaring, T square is equal to 4 pi square into L by G. Here this is a constant and the graph is between 1 by T square. So take into this L by T square. L by T square is equal to G by 4 pi square. This is a constant. Curve L into 1 by T square is constant. Mean just like P into V is a constant. And therefore definitely the graph must be rectangular, hyperbolic between L and 1 by T square. So L and 1 by T square graph will be this one. Okay.